Welcome to this course focused on getting started with Claude on Amazon Bedrock. My name is Stephen Greider, and I'll be guiding you throughout this course. Let's first begin by understanding exactly what we're going to cover in the coming videos. We will first take a look at some of the different models authored by Anthropic, and then quickly learn how to access those models through Amazon Bedrock. We will then spend some time learning how to write and evaluate prompts, followed by an in-depth look into tool use. Then it is on to retrieval augmented generation, which we'll use to provide Claude with knowledge relevant to the tasks that we give it. We will then take a look at Model Context Protocol by working on a small app, and then wrap things up with a look at two agentic apps authored by Anthropic called Claude Code and Computer Use. There's a lot of content for us to get through, so there are a couple of requirements on your side. First, you need to have some basic Python knowledge. Second, you will, of course, need to have access to Amazon Bedrock. So with all this out of the way, let's dive into our first technical topic in the next video. In this video, we are going to examine Claude's three model families and understand which one is right for your specific use case. To help you understand how these models differ, I'm going to walk you through each model's key characteristics and then show you a simple framework for picking the right one. Before we dive into the specifics, let me make one thing clear. All three of these models share Claude's core capabilities, so they can all handle text generation, coding, image analysis, and many other tasks. The real difference between them is how they are optimized. One is built to focus on intelligence, one for speed and cost efficiency, and one for more of a balance between intelligence and speed. The first is Opus. Opus is Claude's most capable model, and when I say capable, I mean to say that this is a model that delivers the highest level of intelligence that you can get out of Claude. In practice, that means that Opus is designed for scenarios where you have complex requirements that need a high level of intelligence and planning to complete. It can work independently on complex projects for a long period of time, like a task that can run on for several hours, where the model needs to manage multi-step processes and navigate a lot of different requirements on its own without a lot of human intervention. Opus supports what we call reasoning, which means it can provide a quick response for simple tasks, or it can spend some time thinking for a more complex task. The downside is that Opus has a moderate latency and a higher cost, and that's really the trade-off that you are making. While you get really high intelligence, it also takes a little bit more time and cost for every request that you make. Next up is Sonnet. Sonnet sits in a kind of sweet spot in Claude's lineup. It has a good balance of intelligence, speed, and cost that makes it really useful for most practical use cases. What makes Sonnet great is its strong coding ability along with its fast text generation. Many developers like its ability to make precise edits to complex codebases, meaning it can make changes to a project without breaking a lot of existing functionality. Finally, we have Haiku. Haiku is Claude's fastest model, and it's made specifically for applications where response time is really important. One important thing to note around Haiku is that it doesn't support the reasoning capabilities that Opus and Sonnet have. Instead, Haiku is optimized for speed and cost efficiency, and this makes Haiku a really good choice for user-facing apps that need some real-time interactions. Now let's talk about how you decide which of these three models to use for your particular application. The way to think about model selection really comes down to understanding the trade-off between these different models. On the one hand side, you've got a really high intelligence, and on the other side, you've got more cost and speed. Opus sits on the intelligence side. It's really intelligent, more expensive, and also has higher latency. Haiku sits on the cost and speed side. It has moderate intelligence, low cost, and the highest speed. And Sonnet is right there in the middle, striking a good balance between these different qualities. So here's how you decide which model to use. You really need to identify or figure out what matters most for your specific use case. If intelligence is your top priority, meaning you have a complex task that needs really strong reasoning, then you probably want to make use of Opus. You are choosing quality over speed and cost. If speed is your priority, meaning you have real-time user interactions or you've got some high-volume processing where you need to get some responses back as fast as possible, then you want to choose Haiku. If you need more of a balance between intelligence, speed, and cost, which is often the case for most applications, then Sonnet is probably your best choice. One important thing to note here is that many teams don't just pick one model and stick with it. Instead, you might use multiple different models in the same application. You might use Haiku for user-facing interactions where speed is really important, maybe Sonnet for your main business logic, and Opus for the really complex tasks that need some deeper reasoning. So that covers Claude's three model families and how to choose between them. Just so you know, we are most often going to use Claude Sonnet in this course just because it gives us a really fantastic balance of these three different qualities. In this module, we're going to understand how to access Claude models through AWS Bedrock and use them to generate some amount of text. To get started, I want to walk you through a small example app, a straightforward standard chatbot application. So let's imagine that you are making a web app and you want to show a chat interface to a user where a user can enter in some message and then click on send. Whenever they do so, their expectation is that some response is going to just magically appear. But let's examine what's going on behind the scenes to actually make this happen. Whenever a user submits some text, a request containing that text is going to be made to your server. Your server is then going to use the Bedrock client to make a request to the AWS Bedrock service, where the Anthropic models are actually hosted. In this request made to the Bedrock service, we'll include something called a user message, which contains the text the user submitted, and a model ID, which specifies which model we want to run. The chosen model is going to run, it's going to generate some text, and it's going to be sent back to your server inside of something called an assistant message. Your server can then take that generated text and send it back down to the browser where it can be rendered on the screen for the user to view. Now, in this section of the course, we're going to be entirely focused on this communication layer between this Bedrock client and the Bedrock service. We're going to investigate how to make API requests, how to access generated text, and discover some common design patterns along the way. And before we move on, I want to clarify a common point of confusion, specifically the difference between the Bedrock API and the Anthropic API. First, a very quick review. Earlier on inside this course, we discussed the Claude Sonnet and the Claude Haiku models. Now, these models are responsible for the actual computational work that is done to generate some amount of text. The Claude family of models are currently hosted through two different services, AWS Bedrock and the official Anthropic API. If you're inside of this course, you're going to be using the Claude family of models through the AWS Bedrock service. Now, here's the point you really need to be aware of. These truly are different services. They're accessed through different SDKs. They have different sources of documentation. So whenever you are looking up documentation or trying to understand how to use a model, just be sure that you're looking at resources specifically for AWS Bedrock. So now that we've cleared up that point of confusion, let's move on to making our first request to Bedrock in the next video. Let's get our hands dirty and write out a little bit of code. In this video, we're going to focus on making our first API request off to AWS Bedrock. We are going to run a model and just generate a very small amount of text. Now you'll notice that I've already created a Python notebook. I would encourage you to pause the video right here and create a notebook of your own so you can code along with me, just to get some experience in making these API requests. In order to make our first request, we are going to need three different things. First, we need a client to actually access Bedrock. We're going to make this client using the Bodo3 Python module. Second, we need a model ID. This is going to be the ID of the exact model that is hosted inside of Bedrock that we actually want to run. And then finally, we also need something called a user message. This is going to be a very specially formatted object that contains some amount of text that we want to feed into the model. So back inside of my notebook, let me show you how we're going to create that client, get the model ID, and create a user message. First, I'm going to make a client using the Bodo3 module. I'm going to specifically connect to the Bedrock runtime and specify a region name. In my case, I'm going to use US West 2. Next up, we need to designate our model ID, which is going to be a string. Now, unfortunately, the model ID is actually going to end up being a little bit more complex than it might seem at first glance. So let me show you a couple of diagrams, help you understand what's going on. Now, as a reminder, whenever we make a request off to Bedrock, we need to include the ID of the actual model that we want to run. And we're going to send that request off to a very specific region. In my case, I put in US West 2. But there's a really big gotcha here, something that's not super clearly outlined in the documentation, but something that you very much need to be aware of. It turns out that not every single model is hosted in every region. So, for example, US East 1 is another region in AWS, and US East 1 might not be actually running the exact model that I want to execute. So if I were to send this request into US East 1, I would probably end up getting an error message saying something about this model just plain not being available. To fix that error, I could try to figure out which region actually is hosting the model that I'm looking for. Or alternatively, I could try to keep track of what model is hosted in which region. But there's an easier way to solve this problem using something called an inference profile. Inference profiles are used to route requests to a different region where your chosen model is actually hosted. So as an example, we might have an inference profile that says that this particular model is guaranteed to be hosted in US West 2 and US East 2. Here's what the inference profile does behind the scenes. We are still going to make a request off to some particular region hosted in AWS. But rather than specifying a specific model ID, we're going to instead specify the ID of an inference profile. When we then send that request in, AWS is going to automatically reroute our request to another region where the model that we are looking for actually is hosted. So the reason that I mentioned that this model ID right here is a little bit tricky to understand is that it is referred to as a model ID all over the place. But in reality, we usually don't actually put in a model ID. Instead, we provide the ID of an inference profile so that we get that automatic request routing. Let me very quickly show you an example of this inside of the Bedrock dashboard, just so this idea of an inference profile is super clear. So inside of my Bedrock dashboard, I've gone to the model catalog on the left-hand side. I'm then going to take a look at one of the Claude series of models. Then on this page, if I scroll down a little bit, I will see right here, yes, I have a model ID. But again, this model ID is probably not what we actually want to add into our request. Instead, what we're probably going to want to use, over here on the left-hand side, I'll find cross-region inference. And if I click on that, I'll then find the model that I'm looking for. Here we go. And then on this page, I'll find my inference profile ID. And that inference profile ID is what we want because that's what's going to automatically route our request off to some region where our model is guaranteed to be hosted. So I'm going to take that inference profile ID, I'm going to copy it, and then put it back over here inside of my notebook and assign it to model ID. The last thing that we need to create before we make a request is our user message. Remember that this is a very specially formatted object that contains the text that we want to feed into the model. I'm going to make a variable down here called user message. It's going to be a Python dictionary with a role of user and a content that's going to be a list with another nested dictionary inside of it with some text. The text value is going to be whatever I want to feed into my model. So in my case, I'm going to ask the model, what's 1 plus 1? Now, I'm going to tell you more about the structure of the user message in just a moment. But for right now, let's just focus on making a request to make sure that we can actually generate some text. To make our actual request, I'm going to go down a little bit and add in a call to client.converse. We're going to feed in our model ID, and notice that the keyword argument here is model ID with a capital I. I'm also going to add in messages. That's going to be our list of messages. In this case, we only have one. It's going to be the user message that we just created. Then I'm going to make sure that I run both cells. Then I'm going to add in a new cell underneath this one and print out response. There's a lot of information inside this response, but if we look very closely, we can see that we actually do get an answer to the question that I put in, which was, what is 1 plus 1? So I got an output of 1 plus 1 equals 2. So if we wanted to get just the generated text by itself, we would have to write out something like response, and then look up output, message, content, 0, text. So that's going to look at the output property, look at message inside there, look at the content inside there, look at the first element inside this list, and then get our text, and that's where our generated text actually sits. So if I now run the cell again, I'll see just the generated text of 1 plus 1 equals 2. Now, very quickly, I'm going to make a change to this line. I'm going to remove the content, the 0, and text lookups, and then run that cell again. Now I'm going to get a dictionary that has a role of assistant and some content assigned to it. And if you look at this dictionary, it might actually look a little bit familiar. It looks rather similar to a structure we created just a moment ago, specifically the user message right here. So let me help you understand what these message things are all about and what they do for us. Messages contain the text that we want to feed into our model, and they also contain the text that eventually gets generated by the model as well. There are two different types of messages, user messages and assistant messages. So a user message is always going to contain the text that we want to feed into the model. And assistant messages are going to contain the text that was generated by the model itself. The structure of these two different message types are always going to be very similar in nature. The only big difference between them is that a user message will always have a role of user, and an assistant will always have a role of assistant. Both message types will always have a content property that will refer to a list. And you might be a little bit curious why there's a list there at all. Why isn't it just some simple text property that tells us whatever we fed into the model or what we got out? The content property is a list because eventually we're going to see that a single message can have many different parts tied to it. For example, we might to send a message into our model that contains both an image and some amount of text as well. We would encode the image and the text as separate parts inside of this list of content items. We are not going to worry about messages with multiple content parts inside them just yet. I only mention it to help you understand why there's that extra little bit of syntax. Okay, so now we've made our first request successfully. Let's come back in just a moment and go into a little bit more detail. The code that we've written out so far simulates a very simple exchange with our model, and we can kind of visualize this conversation inside of a chat box like this. So we sent in a request asking in something like, what's 1 plus 1? We got a very simple response back, something like, the answer is 2. Naturally, we might want to continue this conversation at some point in time. So we might want to send in a follow-up asking something like, and 3 more. And then we would expect to get back a response saying something like, adding 3 to 2 would result in 5. To have a multi-message conversation like this, there's something really critical you need to understand around the Bedrock API and Claude itself. And that is that Bedrock and Claude do not store any messages. None of the messages you send to it get stored in any way, and none of the responses you get back are stored in any way. So if you ever want to have some kind of conversation going on, where you have multiple messages that kind of maintain a context or a flow, then there are two things you need to do. You need to manually, inside of your code, maintain a list of all the messages that you are exchanging. And second, you need to make sure that you provide that entire list of messages with every follow-up request that you make. So let's go into some detail on this entire idea just so it's really clear and you understand what's going on here. The first thing I want to do is run just a little bit of sample code. So I've still got the code we wrote in the last video up here where we asked what's 1 plus 1, and we got back the 1 plus 1 is 2. Now I'm going to paste in some additional code snippet here that I wrote ahead of time. So in this additional code snippet that I just pasted in, I'm making another call to Bedrock, and this time I'm providing a message of just and 3 more. So this kind of simulates that screenshot I showed you a moment ago. And now if I run this cell, I will eventually get back a response that doesn't make any sense whatsoever. So let me show you a diagram to make sure it's clear why we got this very strange text. Okay. So on the left-hand side, I've got the messages that I'm including in my request off to Bedrock. I start off with just a message of what's 1 plus 1. We send that in and we get back an assistant message of 1 plus 1 is 2, exactly what we expect. When I then executed the code that you saw just a moment ago, that extra little code snippet, I sent in a request that contained just one single message that said, and 3 more. Now, when we send this and 3 more in, Claude is going to do its best to give you a response. In our case, the response we actually got back didn't make a lot of sense, but it's doing the best job it possibly can, because all it knows is the fact that we said, and 3 more. So to solve this problem, here's what we're going to do. As I mentioned just a moment ago, we're going to manually maintain a list of these messages and make sure we provide that list with every single follow-up request. So as a demonstration of what we're going to do going forward, whenever we want to have a multi-turn conversation, we're still going to send in this original user message. We're going to get back the assistant response, and then we're going to include that assistant message in our list of messages. So we're going to kind of move it on over there to the left-hand side. Then whenever we want to continue this conversation, we're going to append onto the end of the list another user message where we ask, and 3 more. And now when we take this full list of messages and make our request, Claude will have the full context of the conversation. It will see all 3 messages and will know exactly what we are talking about when we say, and 3 more. So we'll get back hopefully a response of something like 3 plus 2 is 5. Let's go back over to our notebook and try to simulate a multi-turn conversation like this. Okay, so back over here, I'm going to delete that little code snippet I pasted in very quickly. Then inside this earlier code cell, I'm going to write out 3 helper functions. These helper functions are just going to make it a little bit easier for us to maintain the entire context of this conversation and maintain that list of messages. So right above user message, I'm going to put in a function definition of add user message. I'm going to assume that I'm going to call this function with a list of messages and some text. I'm then going to indent user message like so. I'm going to replace what's 1 plus 1 right here with the text argument that we're going to pass in. And then right after we define user message, I'm going to add that into the list of messages. Next up, I'm going to copy this function entirely. I'm going to paste it right down here. I will rename it to add assistant message. I will change the name of this variable to be assistant message, change the role to be assistant, and then finally update messages.append right here to be assistant message instead. So now we have two helper functions that can very easily make a message type for us, either a user or an assistant message, and append it into an existing list of messages. Then one more helper function. Down here, I'm going to make it just a little bit easier for us to call our model, get a response, and then get the actual text we care about out of it. So I'm going to also define a function right here called chat. It will take in a list of messages. I'm going to indent response. I'm going to pass in the list of messages like so. And I'm going to return from this function response, output, message. And do you remember everything we have to put in there? It's then content. That's right. We then get a 0 and text like so. So now with these three functions, we can very easily simulate a full conversation. Let me show you how we would do it. Down here in this cell, I'm going to paste in a couple of comments that I wrote ahead of time just to guide myself and make sure I'm doing this entire conversation correctly. So here's my list of comments. We're going to put in one line of code for each comment that I've added in. But don't worry, each line of code is going to be very short and simple. First, I'm going to make a starting list of messages. So initially, I start off with no communication whatsoever. I'm then going to add in the initial user question. So that initial user message of what's 1 plus 1. To do so, I'll call add user message, pass in the list of messages, and then the second argument is going to be the actual text I want inside this message. So in this case, it'll be what's 1 plus 1. And then immediately after that, I'm just going to print out messages really quickly to make sure that we are on track. So I'm going to run this. And it looks like, yep, we added in our user message correctly. So I've got the role of user, content is a list, and a Python dictionary inside there. So I'm going to continue on to the next step. I'm going to pass the list of messages into that chat function we made to get back an answer. So when we call that chat function, it's going to reach out to Bedrock and call our API. So we'll say answer is chat and pass in the list of messages. And once again, just to make sure I'm on track, I'll print out answer. I'm going to run that. And after a short pause, I see, yep, we got it correctly. We got our answer of 1 plus 1 equals 2. So now we have this answer back as a plain string. We need to take that and add it as an assistant message into our list. And again, we're going to do so by using that helper function we just made. So we'll say add assistant message, pass in our list with the answer we just got back. And once again, print out messages just to make sure we're doing this correctly. So now we will see, yes, we are in fact building up our conversation. We're building up our list of messages. We've got first user and then assistant. We got what's 1 plus 1 and then the answer we got back. So now we can follow up with the user's additional question, which was add user message. And we'll say, and 3 more added to that. And we'll skip checking messages again. We'll just go ahead and get our follow-up answer by calling our API again with a full list of messages. I'll print out the final answer and let's see what we end up with. And so sure enough, starting with the result of that, and we add 3 more, we end up getting 5. So now it's very clear that we are maintaining the context of this conversation by including all the previous messages inside of our follow-up request. Now, this might initially seem a little bit tedious, and even this code right here might seem a little bit confusing. I don't blame you if it is confusing. Don't worry, this is the kind of thing that you're going to get really used to very quickly. And there's just one last thing I want to mention around lists of messages like the one we have assembled right here. And that is, whenever we send in a list of messages to the API, we always need to make sure that we are alternating roles between each message. So in other words, we should always have a user, and then an assistant, and then a user, and then an assistant. We should never have 2 user messages in a row, and we should also never have 2 assistant messages in a row, or any variation thereof. So we always want to make sure that we are varying or alternating those roles. Let's go through a very quick exercise just to make sure everything is making sense so far. Our goal inside this exercise is to make a very simple chatbot using those 3 helper functions that we just put together a moment ago. Now you can read through the different steps that I think you're probably gonna have to implement right here, but to understand the exercise, it might be easiest if I just give you a quick demonstration of what I would like you to try to build. So here's what we're going for. Inside of a Jupyter notebook, we're gonna make a single cell, like the one I've got right here. I've got my solution inside of here, but I've collapsed it just so you can't see it. And now if I run the cell, I want to prompt my user to enter in some input. So for me, that's appearing up here at the top. Then I'm gonna enter in some string that I want to send off to my model. In my case, I'm gonna enter in write a 1-sentence product description. Now if I hit enter, I'm gonna wait just a second, and I should then see a response right back here. And now I should see my input up here once again, and I should be able to enter in a follow-up message that's gonna still contain these previous messages as context. So I should be able to say something like, make it shorter, and see a response that's gonna make it clear that we're still talking about a product description because we included those previous messages. And I definitely do. And then I should be able to repeat this as long as I want. So maybe I could say something like, make it mention a color. And I could just keep on going and going and going. Now you should still be able to complete this exercise even if you are running a Jupyter notebook outside of VS Code. So just as a quick demo, if I flip over, I've got this running inside of a browser notebook as well. And so if I run that cell, I can type in my prompt right here. So 1-sentence product description, and I should still see an output in the exact same way. Now this exercise is just a little bit tricky because it is gonna require a little bit of basic knowledge around Python. And if you're not super familiar with Python, that's totally fine. I'm gonna give you a quick hint right here on the general structure or the code you're gonna write to make this work. So as a hint, I'm gonna put in a little couple comments right here in just a snippet or 2 of code. Here we go. This is kind of our starting point. So just in case you need a little bit of help, you can first make that initial list of messages. We can then run our chatbot forever by putting in a while true. And then to get our user input, we can call the built-in input function. And then I put in some comments for the other steps you'll have to go through. I bet you could figure these out based upon the code that we went over in the last video around adding user messages, calling chat, and then appending on an assistant message. So I'd encourage you to give this exercise a shot. So pause the video right now and go ahead and give it a chance. All right, if you've unpaused, we'll go over solution right away. So I'm gonna start from the snippet that I gave you just a moment ago. All we have to do is fill in a couple of lines of code. We've already got our initial list of messages. We've got a while true right here to run this thing forever. We've collected some user input as text. Now all we have to do is kind of fill in some different tasks right here for each of these different comments. For the first one, we're gonna take whatever text a user just typed in, and we're gonna add it into our list of messages. And for that, we can use the function we put together a moment ago, that add user message function. So I'll call add user message. I'll put in the list of messages I want to add to, and then whatever the user just typed in. Then we're gonna take that list of messages and send it off to our API and save whatever text we got back. So I'll say our text that we're generating is going to be chat with messages. So text right here, that is the response we got back. That's the generated text. So we'll now add that generated text to our list of messages with a add assistant message. And we should probably also print that up as well. Okay, now depending upon whether you are running your notebook in VS Code or not, there's one other thing you might need to do here. If you're running in VS Code, you are going to want to print out the user input. So I'm going to print user input right here. I'm going to put a little caret and a space before it just to make it look like a nice little prompt. You only have to do this if you are in VS Code. If you're not in VS Code, if you're running your Jupyter notebook inside of a browser, you're going to automatically see the user input printed out for you. So again, only necessary if you're in VS Code. I also might want to put in some nice formatting around the text right here when I print it out, but that's totally optional. Let's just run this to make sure it actually works. So I'll run it. And then just as we saw previously, I get this nice little prompt up here, and I'll ask for a 1-sentence product description. And I should see my, yep, there we go. Very good. That's my response. And now I can follow up on this conversation, add in additional messages over time. So I could say, shorten it, add a color, and so on. Very good. Now, if you had any trouble with this exercise at all, don't sweat it. This is our first practice with AI, first time kind of taking a look at this stuff. So you get a lot more practice throughout this course, a lot more opportunities to make sure that you're super confident on what's going on. Earlier on inside this module, we discussed making a web-based chat interface. Now I want to revisit that example, but with a little twist. I want to imagine how we could take that example and turn it into a kind of AWS support specialist chatbot. So maybe a user would ask a question like, how do I host a Postgres database? Then our answer that we get back should probably satisfy some requirements. So for example, our response we get back and show to the user should probably directly answer the user's question and list out some different ways of hosting Postgres on AWS. It might even want to guide the user through some of those different initial steps. And then finally, it might also want to mention some related AWS services that the user might be interested in. Now, just as much as we want our response to include some content, there's also some kinds of content that our response definitely should not include. So for example, we would not want to see any kind of answer that mentions how to host Postgres with a competitor solution. We would also not really want to see any kind of answers related to questions that are not about cloud services in some way. So if a user asks, how do I fix my car? We would probably want our chatbot to very politely refuse to answer that question. Now we're going to take a look at two different possible ways of implementing a chatbot like this. So a user can ask a question and then get back some answers that follow some specific requirements. Option number one, which is maybe not the best option, but we'll take a look at it anyways. We could write out a user message that lists all these different requirements. So inside of a user message, we could say, make sure that you mention how to host things on AWS. And we could also say, do not mention how to host services outside of AWS. And also don't answer questions that are not related to AWS in any way. Now, using option number one would just be really tedious because we would have to think up of a very comprehensive list of do's and don'ts that would address every possible different question a user might ever ask us. So maybe this isn't the best solution here. Maybe there's a better way we could handle this. With that in mind, let me show you option number two, which is going to be a better way of solving this problem. In option number two, we're going to provide a system prompt to that converse function call. A system prompt is going to provide Claude some guidance on exactly how to respond, and it does so by assigning a role to Claude. By role, I mean to say that we're going to essentially tell Claude to pretend as though it has an actual real-life job. So in this case, our system prompt might say, you are an AWS Cloud Support Specialist. This is going to force Claude to pretend as though it is a real-life cloud support specialist, and it's going to attempt to respond in the same way that a real-life support specialist would respond. So presumably, a real-life specialist would never try to answer with competitor solutions and would probably refuse very politely to answer questions that are not related to cloud services. By just assigning this system prompt, Claude is going to try to do the same thing. It's going to try to respond in the same way that a real-life support specialist would respond. Now, the best way to get a hold of system prompts is to write out some code. So let's go back over to our Jupyter notebooks and get a little bit of experience with system prompts. So back over here, I have made a new notebook, but it has pretty much the same code we had previously. So I'm still making a client, a model ID, and then defining those three helper functions. I've also put together another cell here where I'm just asking a very simple question, how do I host a Postgres database? Now at this point in time, I do not have any system message hooked up whatsoever. So if I run this, I'll expect to see a response come back that's kind of like a general purpose Claude answer. It's going to respond as Claude normally would by giving a really well-rounded answer. And it's not going to fulfill some of our big requirements for our chatbot. Namely, if I take a look at the response here, it's probably going to end up mentioning some competitors, which is not really what we want. So one way that we could fix this up is by adding in that system message. For right now, I'm just going to hard code a system message in, and I'll show you how to make this chat function a little bit more reusable after that. So first, inside the chat function, I'm going to add a system prompt right here. And I'm going to copy paste in a system prompt just to save a little bit of time. It's just the same thing you saw on that diagram a moment ago. So it just says you are a cloud support specialist and you just have to answer questions related to cloud hosting. Then to pass this into the converse call, we're going to add in a system keyword right here. It's going to be a list with a dictionary that has text of that system prompt, like so. So now I'm going to rerun that cell to redefine the chat function. And then I'll try to rerun my conversation right here, and we'll see how the response gets updated. Hopefully, it's going to respond with some AWS particular Postgres solutions and not mention any competitors. And so that ends up being exactly what we see here. We're going to see the different managed solutions, some self-managed options, and then some initial setup. And then notably, it's not going to mention anything about any competitors or anything like that. Likewise, we can also try updating our query to something that is not at all about cloud hosting. Now, this doesn't always work, but it usually does. So I'm going to try to ask something like, give me a bread recipe. And we'll see what kind of response we get now. So naturally, without the system prompt, we would expect to get back an actual recipe, but with a system prompt, we get that very polite refusal. Says, okay, I understand what you're going for, but I'm really all about AWS cloud support. So if you have any questions about that, I can help, but otherwise, maybe I can't really answer your question about bread. Let's go back up to that chat function. As I mentioned, I would like to refactor this thing and make it a little bit easier to pass in the system prompt rather than always having it be hard-coded as it currently is. Just so you know, if we pass in this system keyword right here, we are required to put in a system prompt that has at least one character inside of it. So if we try to put in an empty string like so, and then I run this cell and the next one down, I'll end up getting a big error message. It's going to tell me that I provided a system prompt of length 0 and must have at least one character inside of it. So to refactor this thing and just make it a little bit easier for us to specify that system prompt, I'm going to copy paste a little bit of code in here just to save us some time. I'm going to replace the chat function like so. So now I'm going to expect to receive a system prompt. By default, it will be none. I then make my params object ahead of time. And then if a system prompt is passed in, I'm going to add that into the system keyword. And I'll pass all those params into the converse function. So now as a quick demonstration of how we can use this updated chat function, I'm going to rerun that cell. I'm going to go down here. And now when I call chat, I can pass in a system of you are a AWS support specialist. And of course, we could really flesh that out. But for right now, we'll just try it with that and make sure we still get some appropriate output here. Namely, should not really give any good output for still the give me a bread recipe. And it looks like, yep, we definitely get back some good output. Let's try going through an exercise around system prompts very quickly. So in this exercise, I'd like you to write out some code like what you see right here. I've created a list of messages, and I added in a user message of write a function that checks a string for duplicate characters. I then get some text out of that and then print the text out. Now with this starting prompt, I end up getting a lot of output back. So here's the result that I personally got. You can see that there's a little bit of preamble up here, so kind of explaining the solution. And then there's a ton of comments inside the code. And then finally, some closing statements around the code that was written. Now this is a lot of response here for a rather simple function. So I want to somehow get a much more concise answer. One way that we could get a more concise answer would be to adjust the user message and add in a ton of different requirements. So for example, in the user message, we could say, do not add in any comments or anything like that, respond just with some code, etc. Or alternatively, a better way we could get a more concise answer would be to add in a very short system prompt that assigns a role to Claude. So in this exercise, I would like you to take the code you see right here, and then just add in a system prompt to the chat function and see if you can get a result back that has none of the header text or the footer, no comments or anything like that, besides maybe a general function comment like the one right here. That's totally fine. But other than that, I want really just the code and nothing else. So I would encourage you to pause this video right now and go ahead and give this exercise a shot. Otherwise, if you want to stick around, I'm going to go through a solution right away. So here's how you would solve this problem. Now I'm going to add in a system prompt to our chat function call. And in this case, I'm going to put in a system prompt, something really simple, just a role that kind of implies to Claude that it should write some very concise code. So I'm going to put in a system prompt of, you are a Python engineer who writes very concise code. And that's probably going to be enough to get all those extra comments removed. So I'm going to go ahead and run this, and we'll see what we get here. And yeah, I'd say that's probably very much what we're going for here. So it's going to check and see if we have any duplicate characters inside the string. We get that nice function comment right there. But besides that, we don't get any preamble header or footer explaining what's going on and no additional comments. So I would say that adding in the system prompt was a lot easier than trying to adjust our prompt a ton, or specifically the user message, and add in a ton of all those additional requirements. So I'd say this is a pretty good solution. Now, once again, if you had any trouble with this exercise, do not sweat it. We're going to continue to have a lot of exercises throughout this course. Earlier on inside this course, we spoke very briefly about how Claude actually generates text. Remember, we feed some amount of text into Claude, like the words, "What do you think?" Claude is then going to tokenize this text or break it up into smaller chunks. Claude is then going to go through a prediction phase where it decides what possible words could come next and assign a probability to each of those different options. Finally, in the sampling phase, a token is actually chosen based upon these probabilities. So in this diagram I have on the screen, given inputs of "what do you think," possible next tokens might be about, would, of, and so on. Everything you see here on the right-hand side. Each of these gets assigned a probability. And then maybe in this case, Claude settles on about as being the best possible next token. So we would end up with the phrase, "What do you think about?" This entire process is then repeated to complete the sentence or complete the entire message. Now, just to make sure things are really clear, the numbers I'm showing here are probabilities, the percentage chance of each token being selected. Just to make things a little bit more clear with these probabilities, I'm going to display them in a chart for the rest of this video. So still the same probabilities, just in a format that's easier for us to understand. You also notice I've kind of sorted them from left to right. There's no actual internal sorting going on. I'm just sorting them greatest to least probability just to make this chart a little bit easier to understand. So now that we have a reminder on how Claude generates text, I want to show you one way that we can directly influence these probabilities and control which token Claude might actually decide to select. So we can control these probabilities using a parameter called temperature. Temperature is a decimal value between 0 and 1 that we provide when we make our model call. So whenever we call that converse function. Temperature is going to influence the exact distribution of probabilities. This is a little bit tricky to understand, so you can look at the plot or these charts I've got right here, or alternatively, I put together a quick little demo with Claude itself, just to give you a better idea of what's going on. So let me show you that demo. Okay, so this is the same chart we were just looking at in that diagram a moment ago. Whenever we provide a temperature value going down to 0, so you'll see I got temperature right here, the highest probability becomes more likely to occur. So our highest probability was about, and it's going to increase all the way up to 100%. So at temperatures of 0, we start to get what we call deterministic output, where we always select the token that has the highest initial probability. Then, as we start to increase our temperature, it increases the chances of us selecting a token that has a lower initial probability. So we go from maybe having a 0% chance of selecting we as the next best token, all the way up to, say, 9%. So this is the theory behind temperature, but what does this actually mean in the real world? Well, we start to use different values of temperature given the actual task that we're trying to complete. These are some example ranges and tasks that might fit into each sample range. For something like, say, data extraction, we really don't want a lot of randomness or creativity. If we give Claude a big chunk of text and ask it to extract very specific pieces of information, no real creativity required there whatsoever. We just want Claude to look at the exact text we provided and pull out the most relevant information. And then on the higher temperature side, this is where we start to get more creative, and we start to see less common tokens being used. We probably are going to want to use higher temperatures anytime we are doing any kind of really creative focused task, such as brainstorming, writing, maybe doing some really creative marketing, or something like a joke, where a lot of jokes really depend upon using words in ways that are not always quite expected. Now that we have an idea of what temperature is all about, let's take a look at how we can play around with it with the Bedrock API. So the first thing I want to show you is in the Bedrock documentation, or specifically the Bedrock user guide. Inside of here, on the left-hand side, I've navigated down to Anthropic Claude models, and I'm taking a look at some documentation around Claude Sonnet. If I do a search on this page for temperature, and then go down a little bit, I'll finally find temperature right here, so a description of this parameter. And you'll see that by default, temperature is set to 1. So that means that by default, whenever we access Claude through Bedrock, we're going to usually get back some really creative responses, which may or may not be good. So we might want to control this temperature value to sometimes make sure that we're getting more deterministic output for tasks like, say, data extraction. And then maybe we could adjust temperature depending upon whether we want a more creative task, like, say, writing a script for a movie or something like that. So now back inside of Jupyter, I have the same notebook I was working on in the last video. I have added in a new cell here where I've made a new list of messages. I'm adding in a user message where I'm asking Claude to generate a movie idea in one sentence. I then called chat, get back some text, and print it out. And before running this, let's update our chat function so it will take in an optional temperature parameter. And we'll pass that through to our converse call so we can adjust the creativity of our model a little bit. I'm going to go back up to the chat function right here. I'm going to add in an additional argument of temperature, and I'm going to match the default temperature value of the model itself, which is 1.0. I'm then going to pass that through this params dictionary. So I'm going to put in a new key to this of inference config. And notice that this is the word inference. It is not interface. So make sure you get the spelling there correct. I'll then put in a temperature of whatever temperature was passed in. And that's it. So now if I rerun that cell just to redefine chat, I'll then go back down to the cell I had added down here to generate movie ideas. And remember, now we have a default temperature of 1. I'm going to leave it like that for right now. And if I run this once, I should get back a movie idea that is at least somewhat creative. And if I read this over, a reclusive origami master, this is a very creative movie idea. You can tell right away. I'll run it again, and we're definitely going to expect to get back another movie idea that is really creative. Okay, that also looks reasonable. Just one more. And yeah, reasonably creative. So now I'm going to add in the temperature and set it to flat 0. Now, in theory, we're going to get back some ideas for movies that are a little bit less creative in nature, perhaps. So if I run this, I'll see a time-traveling archaeologist. Now, it's kind of hard for you and I to just run this prompt a couple times and decide whether or not it is creative. But let's run this 1 or 2 more times, and I think you're going to notice a theme really quickly. Notice how this is a time-traveling archaeologist. So if I run this again myself, I'm probably going to see another response here about, yeah, there we go, a time-traveling something related to history. I'll do it again, and I'll probably see, again, a time-traveling historian. So you can start to see right away that we start to get responses that are a little bit less creative, and they tend to be rather similar to all other responses that we get when we feed in this identical initial prompt of generate a movie idea in one sentence. Okay, so that's temperature. Now, remember, there's some general guidance here. Whenever we are doing tasks that require less creativity or where we want to have very deterministic output, we're going to use that lower temperature. And then whenever we have a task that requires a little bit more creativity, that's when we start to want to think about dialing up the creativity a little bit. I want to think back to our original chat interface example just one more time. So remember, we've got a chat interface running on a website or maybe a mobile app. A user is going to submit a question. We're then going to take that text in our server, put it inside of a user message, send it off to Bedrock. That's going to give us back an assistant message. We will extract some text from that and then potentially send it down to the browser where the actual generated text can be displayed to the user. Now, this would all work, but there's one big downside to it. And that is that the time between sending that initial request with the user message and getting a response can sometimes take a really long time, depending upon the length of the response that is being generated. So it can take anywhere from maybe 3 seconds, but it could also take maybe 30 seconds. Most users' expectations are that whenever they enter in some kind of initial message, like how do I host a Postgres database, they want to immediately start seeing some content being generated on the screen right away. They don't want to wait 30 seconds. So to implement this kind of immediate feedback, we can use a function that's kind of like converse. It just works a little bit differently. And that is the converse stream function. Converse stream allows us to stream back a response. It streams back some generated text as it is being produced by our model. Let me show you a couple diagrams to make sure it's really clear how this thing works. So once again, we're going to have a user submitting an initial question to our server. We're then going to send a request off to Bedrock, this time using the convertStream function. Then the response we get back is going to be a little bit different in nature. Right away, we're going to immediately get back an initial response. There's not going to be any generated text inside this initial response. It's really just going to be a message from Bedrock that says, hey, we received your request. We are now generating some text. We're then going to start to receive a stream of events. We're going to go into more detail around exactly what these events are. But for right now, just understand that they contain pieces of the generated response that we want to send back eventually to our user. We're going to get a number of different events. The number that we get depends upon how much text we are generating. Each event is going to contain just a little bit of the overall message that is being generated. So maybe this first event has the text "you can," and then the next one host A, and then the next one Postgres. In theory, we would probably have some additional events after that to really flesh the message out. As we receive each event, we would take this generated text, send it down to the browser, and then hopefully our browser or mobile app would display that part of the generated message on the screen. And then we would repeat this process for each additional event. So we'd take the text, send it down to the browser, and show that on the screen. And eventually, we would stream in each chunk, and so the user can start to read the response right away as soon as possible. Now, I want to spend a lot of time discussing the exact nature of these events, because that's really the kind of challenging part of understanding how convertStream works. But first, let's write out a little bit of code just to get our hands on convertStream and really understand it. So back inside of a notebook, I've once again got an initial set of messages right here that starts off empty. I've added in one message that just says, write a one-sentence description of a fake database. Now I'm going to get a response by calling client convertStream. I'm going to pass in my list of messages. And of course, I still need to pass in my model ID. And remember, our model ID keyword is actually model capital ID, but our model ID that we specified earlier is model underscore ID. I'm then going to print out just the response for right now. And when I run the cell, you'll notice that it only takes about a second for me to get the initial response back. So again, this is the initial response we saw in the diagram. It's this thing right here. Inside this initial response, there's not actually any generated text. Instead, we get this new key added inside of it of stream. Stream is an event stream object. Essentially, it's a generator that we can iterate over. And each value that gets emitted or yielded by that generator is going to be one of these different event objects. So let's update our code here a little bit. I'm going to change it to for event in response. And remember, that thing is specifically at the stream key inside the response object. I'm then going to print out that event. I'll then run this again. Let's see what we end up getting. So now we start to get a stream of different events being printed out. And even though it's a little bit hard to see, you might notice that when you run this cell, you first see the first print or two, like the first event print, and then you start to see the others start to trickle in with a little delay in between each one. So let me show you a diagram that's going to help you understand what these event things are all about. So again, whenever we make a request off to Bedrock, we're going to get back a series of these different events. There are several different kinds of events that are going to be yielded by that generator, and we can see these all being printed out when we run that cell. So we might see an event of type message start. We then might see an event of type content block start, and then content block delta, and so on. If I go back over to Jupyter, I'll see those right here. So here's message start. I've then got some content block deltas. And if I scroll down, I eventually get a message stop and a metadata event. Now, each of these different events has a different meaning in the context of our response. For right now, the only event that we're really going to be focused on is the content block delta. Each content block delta event contains a little piece of text that was generated by our model. And this is the actual text that we eventually want to probably show to a user or make use of in some way. So if I again look at my log right here, I'll see that each of these content block deltas have nested inside them a delta and then a text, and then that is the actual text I care about. So for me, I would end up with a generated message here of the Xenon Lin Q7 database is a revolutionary yet entirely blah, blah, you see, so on and so on. you are always going to see these different events listed out in the same order. So we're always going to end up seeing a message start event first. We'll then see some number of content block delta events, then a content block stop, message stop, and metadata. Now, as we start to take a look at some more advanced features of our model, we might eventually see multiple content block start and stops. But for right now, when we're only generating text, we're only going to get back a single set of content block deltas and a single content block stop. We're not even going to actually see a content block start, even though that is an event. So that is an event, but we're not actually going to see it if we're only generating text. It's only going to be relevant once we start to go into tool use, which we're going to cover a little bit later on. So again, for right now, the only event that we really care about when we only care about text is content block delta. So with that in mind, let's update our for loop back inside of our code. I want to collect all the different content block delta events. Whenever we get one of these, I want to try to print out the text inside of that event. So here's how we would do it. I'm going to update the contents of the for loop, and I'll say if content block delta in event. So I'm just checking for the presence of that string inside of this event dictionary. Then I want to get the chunk text, which I'll call chunk, and that's going to be event at content block delta text. And then I'll print out just that chunk. Whenever we print out a chunk using the print function in Python, it's going to automatically append a new line to the end of the print statement. So it ends up being a little bit challenging to read like this. So I might recommend adding in the end keyword and passing in empty string. That's just going to remove the automatically added new line at the end of every print statement. And so now if I run this again, I'll see everything printed up a little bit easier to read. You'll also notice right away that, everything is kind of being streamed into us chunk by chunk. Now, last thing I really want to do here is collect all this text. So at the very end, we kind of have the entire message, so we can maybe store it in a database or do something with it if we want to have a record of all the text that was streamed back to us. So I'm going to define text up here as an empty string. I'll then append on every chunk to that text variable. And then down here at the very end, I'm going to print out new line, total message, new line, and then I'll just add on text to it. So let's try this out. Okay, there we go. So we can see the chunks stream in. We are collecting all those chunks together and then eventually printing them out as one total message. Besides just changing our prompts that we send into Claude, there are two other ways that we could strongly influence the output that we get out of it. So in this video, we're going to discuss two techniques. One is pre-filling assistant messages, and the second is stop sequences. Let's first take a look at pre-filling assistant messages. Okay, let's imagine that we send Claude some kind of really tough to answer question, something like, is tea or coffee better at breakfast? I have absolutely no idea what kind of response Claude would give me. As a matter of fact, let's go over to our Jupyter notebook really quickly and see what kind of response we get in the first place. So back over here, I have created a new notebook. Still has all the same code we had previously though, so I'm still making a client, assigning my model ID, and then I define those three helper functions. In the next cell down, I'm going to make a list of messages. I'm going to add in a user message of is coffee or tea better for breakfast? And then let's see what we get with that. So after a brief pause, we're going to get back probably a rather long message because I think Claude has a lot of input on this topic, but you can see right away that it's just not really taking a position per se. So there might be some scenarios where we want to strongly influence Claude one way or another, where we want to kind of direct its output or direct its response in some particular fashion. So one way we could do this is by pre-filling an assistant response. With message pre-filling, we're still going to assemble a list of messages. We're going to put our user prompt inside there, but there's going to be one extra little difference. You and I are going to manually put on an assistant message at the very end, and you and I are going to author the content inside of that assistant message. We're then going to take this list and send it into Bedrock. And then in Claude, we can kind of imagine this is what goes on behind the scenes. We can imagine that Claude is going to see that first message and say to itself, okay, the user wants to know what I think about coffee versus tea. It's then going to take a look at the second message, which is an assistant message. And because it is an assistant message, Claude is going to say to itself, oh, it looks like I already have some thoughts on the situation. So I better continue my final response that I'm going to send back using this as a starter. So Claude is going to essentially use this as the start of its response. Because Claude sees the sentence, coffee is better because, that's going to very strongly steer it in the direction of supporting coffee as being better at breakfast. So chances are Claude is going to give us back a final assistant message that says something like it has higher caffeine, which implies it's talking about coffee. Now, the one very important thing here to distinguish is that whenever we put in this final assistant message right here, Claude is going to assume that that is kind of content that has already been authored, and it's going to continue its response from the very end of this sentence. So you would kind of expect Claude to give you back a full response like this, where it says coffee is better because it has a higher caffeine. That is not the case. It's going to continue the response from the very end of whatever you pre-filled with. So in other words, this is not really a complete sentence. And if you want to use this, you're probably gonna have to go back and kind of stitch together that text right there and that text right there. Okay, this is, when you explain it, something that's kind of hard to understand, but in practice, it ends up being really easy once you see a demo or two. So let's just go write out some more code and see how this actually works. So back over here, message pre-filling, super simple. All we have to do is say add assistant message, and we'll say coffee is better because, and now when we send this off, Claude is hopefully going to give us something that supports coffee much more strongly than it did previously. So before, it was kind of even on the fence. It said, oh yeah, either tea or coffee is fine. But now with message pre-filling, we have very strongly steered it towards preferring coffee. And of course, we could say tea is better because, okay, that works. And then of course, we could just give it a neutral position. And we could say they are the same because, and then we get back the more neutral response that doesn't favor either of them. Now, once again, I want you to notice that when we use this message pre-filling, we get back kind of a partial response right here. So it just says both drinks don't have any nutrients. So like I mentioned, when we were looking at the diagram, it's kind of up to you to take whatever your pre-filled response right here was and join it onto the end of the actual response when you're using this technique. So now that we have seen message pre-filling, let's take a look at our other topic for this video, which is stop sequences. Stop sequences are going to force Claude to stop generating a response as soon as it generates some particular string that you provide. So let's imagine that we provide a prompt of count from 1 to 10. And naturally, our expectation would be that we get back 1, 2, 3, 4, 5, all the way up to 10. We could stop the generation early by providing a stop sequence of the string 5. Then internally, whenever Claude generates the string 5, it's going to immediately stop the response and send whatever it has generated already back to us. Again, let's take a look at a quick example of this. Stop sequences are provided as an additional parameter to our converse function. So I'm going to scroll up a little bit, find where we define chat right here, because that's where we actually call converse. I'm then going to add in an additional optional keyword argument to the chat function itself. I'll call it stop sequences, and I'll default it to be an empty list. Then inside the inference config dictionary, I will pass in stop sequences, like so. I'm then going to make sure that I rerun that cell. Now let's test this out. I'm going to go down to the very bottom of my notebook and make a new cell. I'm going to copy everything out of the previous one just to save a little bit of typing. I'll remove the pre-filled message and then update the user message to say count from 1 to 10. And if I run this as is, I'll expect to get back the full list of, well, 1 to 10. So if we wanted to truncate the response or stop it at a certain point, we could now add in to our chat function a stop sequences keyword argument. That's going to be a list, and inside there, we're going to put in all the different characters that we might want to stop at. And these don't have to be individual characters. They could be full words. So I might say stop whenever you print out the character 5. And if I now run this, we'll see only 1, 2, 3, 4. And you'll notice that it does not include the character 5. So 5 is removed entirely. We can put in as many stop sequences as we want. So I could also put in, say, 3, 4, like so. And the response will just be stopped as soon as it sees any of these different sequences. Stop sequences and assistant message prefilling can be combined together in a really powerful way, something that you're probably going to end up doing rather frequently anytime you need to generate some kind of structured data. So to help you understand how these things work together, let me walk you through a really quick example. Let's imagine that we are building a web app like the one you see on the screen. This is a web app that's going to generate event bridge rules based upon some user input. If you're not familiar with them, event bridge rules are used in AWS. They're essentially little JSON snippets. So user is going to enter in some prompt like this and then click on generate. And chances are the user is going to want to see some generated rule just appear that they can very easily select right away or click on this little copy button and go use somewhere else. The point there is that part of the critical user experience here is that we want to show just the JSON for the generated rule and nothing else. So if we instead displayed a response that looked like this, it would definitely not be as helpful for our users. We're still generating the rule, but now it also has this header up top and this commentary footer down at the bottom. So now a user can't really use this copy all button. They would have to go in and manually select that JSON right there. So this is an example where we really don't want Claude to be that helpful and explain its work. We want just some very particular data and nothing else. Now, to be clear, this is not a problem that is just limited to generating JSON. It turns out that anytime you are using Claude to generate any kind of structured data, so it could be JSON, or it could be Python, or even just a bulleted list of text items, Claude is very often going to try to insert a header or a footer or some additional kind of commentary. And in many of these scenarios, you don't want that additional commentary, you just want the raw content that you asked Claude to create. So to help keep Claude on track here and only give us the raw content that we're asking for and no additional header or footer or commentary or anything like that, we can use our stop sequence in combination with a pre-filled assistant message. Let me show you how. I'm going to go back over to my notebook. I'm going to continue on by making a new cell down here. I'm going to again make a list of messages. I'll add in a user message. And I'll say something like generate a very short event bridge rule as JSON. I'll then pass that off like so. And then let's just see what we get with this kind of initial take. So right away, we can see that we do get back some JSON, but it has, unfortunately, that little backtick JSON right there, and then a matching closing one over there. Now, just to make sure it's super clear, these backticks are in place to format this all as Markdown. So it gets formatted very nicely if you were to render it as Markdown text. But in our case, we don't want any of those additional characters. We want just the raw JSON by itself. So to do so, we can do two things. We're going to use both an assistant message and a stop sequence. For right now, we're just going to write out the code to do so, and then I'll show you a diagram that explains how it all works. First, I'm going to prefill an assistant message. So let's say add assistant message. And my prefilled message will be backtick JSON. And then on my chat call, I'll add in stop sequences. And anytime we see a backtick, I want to immediately stop generation. So let's now run the cell and see what we get back. Okay, so now we get just the JSON by itself. You will notice that there are some new line characters in here, but that's totally fine. We can very easily remove those extra new lines by just parsing the response as JSON or by doing a strip call. So I could say text is chat, I'll print out text, and then on the next cell down, I might import JSON and do a JSON loads with text and strip on text as well. And if I run that, yes, we definitely get back some very well formatted JSON here that we can access in any way that we expect. All right, so what exactly is going on with the assistant message and the stop sequence? Well, let me show you a diagram just to break it all down and make sure it is super clear. So once again, we are doing our user message, we're providing a pre-filled assistant and a stop sequence. So when we send this all into Bedrock, Claude is going to take a look at all the different parts of this request. It's going to initially take a look at that user message content and say, all right, it's very clear that I need to write a full rule and I should probably also describe it. So maybe put on a header and a footer, because that's kind of what Claude naturally wants to do. It wants to explain the work that it is doing. But then it's going to encounter that assistant message. And just as we learned in the last video, Claude is going to assume that it already wrote that out in its response. So it's going to say, oh, I've already started the JSON part. So now all I have to do is write out the actual JSON. It's then going to write out all of this JSON in the response. And then as it gets to the very end, it's going to naturally want to close off that markdown code block that it thought it created earlier. So Claude is going to want to put in a closing backtick, backtick, backtick. As soon as it does so, however, it's going to encounter the stop sequence, which stops the generation entirely and immediately sends us back the response. So you can really imagine that what's really going on here is we're kind of saying start with this, end with that, and just give us everything in between. And that results in us just getting back the part we really care about, just the JSON by itself. Now, like I mentioned, this is a really powerful technique that we're going to use very often anytime we want to generate some kind of structured data and get just that data with nothing else besides it. And remember, this technique can be used for any kind of structured data. It is not limited just to being used on JSON. So anytime we have any kind of very specific content we want to generate and get just that content with no additional commentary on it, we're going to take a look at using assistant message prefilling along with stop sequences. Let's go through a very quick exercise just to make sure the idea of stop sequences and message prefilling are super clear. So in this exercise, I'd like you to write out the exact code I've got right here on the screen. All this code should be really familiar. If you take a look at the prompt, it says generate 3 different sample AWS CLI commands. Now, when you run this code, you're probably going to get back some output that looks vaguely like this right here. Just to make it a little bit easier to read, I rendered it as Markdown down here. So here's the sample starting output that I get. You'll notice that it does give us 3 different sample commands, but it has a lot of commentary around them. So I've got a header and then some numbers listing out each individual command. For this exercise, I would like you to take this code and using only message prefilling and stop sequences, I want you to get all 3 different commands in a single response, all right next to each other without any additional comments or explanation or anything like that. And I'd like you to do this using only message prefilling and stop sequences. So no adjusting this prompt at all. So go ahead and give this a shot. I did put a little hint on here, just as a reminder, with message prefilling, it's not limited just to using characters like the backtick, backtick, backtick. You could put any kind of prefill response you want. I would encourage you to pause this video now and give this exercise a shot. Otherwise, I'll go over a solution right away. So here we go. Here's how we're going to solve this. To solve this, the first thing I recommend you do is take a look at the output without any kind of prefilling or stop sequences or anything like that. So if we take a look at what we have right here, we'll notice that each of our 3 commands are wrapped in a series of 3 backticks. So a good place to get started would probably be to put in a pre-filled assistant message of 3 backticks to kind of tell Claude to just go right into the command writing right away and skip any initial commentary. And then we might also decide to put in a stop sequence of 3 backticks as well. Let's see how far that gets us. So I'll put in a add assistant message, and I'll start everything off with 3 backticks, and I'll put in a stop sequences of closing 3 backticks. Let's run this and see how far it gets us. My initial output looks kind of reasonable, but it's not perfect just yet. I do get 3 commands. So there's 1, 2, and 3. But you'll notice that I also get the word bash added at the very start. So where's that word coming from exactly? Well, let me show you what Claude is really trying to do here. We provided the initial assistant message of those 3 backticks. Whenever you put down 3 backticks, it's kind of indicating that you are writing out some markdown. And when you are writing a markdown code block with backticks, you can optionally put in a language identifier right here. If you choose to put one in, then whenever you render this as markdown, the content inside of those backticks will be rendered using that language's syntax highlighting. So in this case, Claude decided to put in bash right here just to say, hey, we should use bash style syntax highlighting when we render this stuff out. Now for us, we don't want that at all. So one way we could address this would be to adjust our pre-filled message right here and just include bash ourselves. So that's now going to make it super clear to Claude itself that yes, you are inside of a markdown code block, and inside this code block, you should be writing out bash formatted commands. So let me try running this again and see how I do now. Okay, so that looks better. Now I will tell you that from this point, there are probably 2 additional errors that you might want to address. The first is sometimes you will get back a single command, which is kind of an indication that Claude might want to write out 3 separate markdown code blocks. The other problem that you might run into, because we are now using a bash code block, Claude might try to insert some bash formatted comments in there as well. So it might be something like, this command does XYZ, and you might see that repeated. And so we definitely don't want those comments, really just because that was one of the requirements of this exercise. So to get rid of those comments and to also make sure that we get all three commands more reliably, we can use that hint I gave you. Remember, the hint was message prefilling isn't just limited to designating characters like backticks or stuff like that. We can also use the message prefill to dramatically guide Claude in how it's going to answer us. So in this case, we could add in something like, here are all three commands in a single block without any comments. And then I'll put in a colon right there and then a new line, just so it starts all the markdown stuff on the next line down. So I'm going to try running this, and we should now get some much more reliable output. Okay, that looks good. And of course, I can keep running it all day, and we're probably going to see exactly the result we want. Okay, this looks good. Now that we understand how to access Claude, we're going to shift our focus a little bit and look at two new topics, prompt engineering and prompt evaluation. These two topics are all about making sure that we are writing prompts that will get us the best possible output from Claude. Prompt engineering is a series of techniques that we'll use anytime that we want to write or edit a prompt. These techniques will aid Claude in understanding what we're asking of it and how we want it to respond. Prompt evaluation, on the other hand, is where we do some automated testing of a prompt with the goal of getting some kind of objective metric that tells us if our prompt is effective or not. In this section, we're going to be mostly focused on prompt evaluation. After we understand how to measure the effectiveness of a prompt, we'll then take a look at some prompt engineering techniques. So let's get to it. The first thing I want to do is help you understand where prompt evaluation fits in to the prompt writing process in general. Whenever you first write a prompt, you generally have three different paths ahead of you, three different ways you can go from there. With option number one, you might take that prompt you put together, maybe test it once or twice, and decide it is good enough to use in production. With option number two, you might test the prompt a couple of times with your own custom inputs, and maybe tweak it a little bit to handle a corner case or two that you notice. Now, right away, I want you to understand that options number one and number two are kind of traps that all engineers fall into, myself included. It happens to everybody. We all start writing out prompts that are going to eventually be used in serious applications, and we don't really test them enough to make sure that they are working as expected. So whenever you write a prompt, I highly recommend going with option number three. Run your prompt through an evaluation pipeline to get an objective score that will tell you how well your prompt is performing. You can then try to iterate on your prompt a little bit and make sure that it's performing as well as it possibly can. In this video, we're going to walk through all these steps implemented by a typical prompt evaluation workflow. Before we go through any of these steps, however, I just want you to understand two important things. First is there are many different ways that you can assemble a workflow. There's no one set methodology set in stone that is standard across the industry. The second thing to understand is that there are many different open source packages and even paid options online that will help you implement your own workflows. Now, in this video and this module, we're going to start to implement our own custom workflow from scratch inside of a Jupyter notebook. The reason we're doing this is to, of course, just help you understand how these workflows behave, but also to help you understand that you don't have to get a really heavyweight solution to do prompt evals. You can start small just to get started and get a sense of how everything works, and then scale up from there. All right, so let's get to it. Step one of a typical prompt eval. Step one, we're going to write out an initial prompt draft. So you and I will sit down and just write out some kind of prompt that we want to improve in some way. For this example, we're going to have a very simple prompt that just says, please answer the user's question. And then we're going to interpolate in some user input, so some question provided by a user. In step two, we're going to create an evaluation dataset. This dataset is going to contain some number of possible inputs that we might want to put into our prompt. So for us, our prompt only has one input, a question provided by a user. So for our eval dataset, we'll have a list of different possible questions that we might want to put into our prompt. My dataset is only going to have 3 different questions inside of it. But in real-world evals, you might have tens, hundreds, even thousands of different records in your dataset. Now you can assemble these datasets by hand, or you can of course also use Claude to generate them for you. Once we have our eval dataset, we're then going to feed each of these different questions into our prompt. So we get a fully fleshed out prompt that we can then feed into Claude. So we might have prompt 1 right here, where we have please answer the user's question, and then a sample question out of our data set, like what's 2 plus 2? And then we will repeat for all the other records inside of our data set. So here's 2 and 3. We'll then feed each of these into Claude and get an actual response out of Claude. So for the first one, we might get back a response of something like 2 plus 2 is 4, and then something about how to make oatmeal, and then something about the distance to the moon. Once we have these actual answers coming out of Claude, we're then going to grade them in some way. During this grading step, we're going to take each of the questions out of our data set and the answers we got out of Claude. We'll pair them all off together, and we'll feed them into a grader one by one. There are many different ways we can implement this grader. We'll take a look at some of the different methodologies a little bit later. The grader will then give us a score, maybe from 1 up to 10, based upon the quality of the answer that was produced by Claude. So a 10 would mean we got a perfect answer and there's really no possible way we could improve it. And maybe something like a 4 indicates that there's definitely room for improvement there. Now, as you can guess, there's kind of a lot of hidden complexity here with the grader, because you're probably curious or wondering, well, how do we actually get these scores at all? And again, don't worry, we're going to cover these grader things in much greater detail in a little bit. After we get these scores, we're then going to average them all together. So in this case, I would add the scores together, divide by 3, and get an average score of 7.66. So I now have some kind of objective way of describing how well our original prompt performed. Now that we have this score, we can then change our prompt in some way and iterate or repeat this entire process. So if I want to improve my score, I might try adding in a little bit more detail to the prompt to hopefully guide Claude a little bit more and help it understand what kind of output we want. So maybe I would add on to the end of the prompt something like answer the question with ample detail. Once I have the second version of my prompt, I would then run it through this entire pipeline again. I would then have a score for prompt version 1 and prompt version 2. I could then compare these two scores, and whichever score is greater or higher, it's kind of an objective sign, better than nothing, that tells me that prompt v2 in this case is perhaps the better version of our prompt. So now that we have a high-level overview of this entire process, as I mentioned, we're going to start to implement our own custom eval framework inside of a Jupyter notebook. So let's get started on an implementation in the next video. Let's get started on building our own custom prompt evaluation workflow. We're going to be writing out a prompt and then writing out some code to evaluate how well it performs. So let's first focus on making a prompt. The goal of our prompt is to help users in writing out some code specific for AWS use cases. So we are going to allow a user to enter in some kind of task that they need help with. And then we're going to respond with one of 3 types of output. We're either going to output Python, JSON configuration, or a raw, just plain regular expression. Those are our 3 possible outputs. So we need to make sure that whenever a user asks for us to complete some kind of task, we give them some output in one of these 3 particular outputs without any other kind of explanation or header or footer or anything like that. So that's the overall goal. Now, the first step of our goal is, of course, to write out a draft prompt. Now, I've kind of already done that for us on the right-hand side here. I've got V1 of our prompt where it just says, please provide a solution to the following task, and we'll put the user's task in there. Step 2 is to assemble a data set. Remember that a data set is going to contain some number of inputs that we're going to feed into our prompt, and then we're going to run our prompt for every combination of prompt and input. For our particular case, we're going to have an array of JSON objects, where every object has a task property. These tasks are going to describe something that we want to be done by Claude. So we're going to take each of these tasks, put them into our prompt, and then feed the result into Claude. Remember that when we make a dataset, we can either assemble it by hand, or we can generate it automatically with Claude. Now, as a side note, if you're using Claude for something like this would be a really good opportunity to use a faster model like Haiku. And that's what we're going to be doing here. Let's go back over to Jupyter. We're going to open up our notebook, and we're going to write out a little bit of code that's going to generate a sample dataset, like the one you see on the left-hand side, using Haiku. Okay, so back over here, I'm inside of a new notebook, and once again, very similar setup to all the others we have worked on. I'm creating a client. I have updated my model ID to use an inference profile that's referring to a Haiku series model, just so I get that additional speed. I've then got those 3 helper functions put together. I'm going to scroll down and make a new cell. And inside of here, I'm going to make a helper function called generate dataset. And then inside, I'm going to write out a rather lengthy prompt that's going to ask Claude to generate this kind of evaluation test set for us. Just to save some time, I'm going to copy paste the completed prompt in here, rather than asking you to sit around and watch me type it out. Remember, if you want to just copy paste the prompt, you can always open up the completed version of this notebook and copy paste the prompt yourself as well. So I'm going to paste this thing in. So here's my prompt. You'll notice that I'm asking it to generate some tasks related to AWS, and I'm giving it some example output here. And notice that the example output, I'm asking for specifically an array of objects, each of which has a task. And then at the bottom, I'm also clarifying and asking it to generate just 3 separate objects. So essentially 3 different tasks here. Remember that in a real world scenario, we would want to have way more than just 3 different test cases. But for right now, this is enough. Do note that we are going to eventually come back and change the structure of this object. So for right now, it's going to be just a very plain, flat, simple object, but we will come back later and change it up a little bit. And the only reason I mention that is that if you go and look at the completed code, you might notice that this prompt looks a little bit different. All right, so now that we have this prompt put together, at the bottom of the function, I'm going to make sure I indent because we are still inside of a function here. I'm then going to send this prompt off to Claude and ask it to generate some different tasks for us. So we'll add a user message. And then when we get our response back, we are expecting to receive some JSON. And to extract that JSON, we can use the same technique we covered in the last module, which is to use a combination of a pre-filled assistant module, or excuse me, assistant message, and a stop sequence. So we'll do a add assistant message. And I want to pre-fill a message with backticks 123 JSON. I'm then going to call chat with messages, and I want to provide that stop sequence of 3 backticks as well. And now when we get this response back right here of text, this is really supposed to be some JSON. So I'm going to immediately try to parse that JSON using the JSON module and then return it from this function. So I will do a return JSON.loads with text. I'm going to make sure that I imported that JSON module up here at the top. I did already. You might need to add in that import statement and rerun that cell. All right, then let's test this out really quickly. So back down here, I'm going to run that cell. And in the next down, I will call generate dataset. And we'll see how we are doing. Because I'm using Haiku and I'm only generating 3 records, this should generate pretty quickly. And there we go. So it looks like these tasks are actually pretty reasonable. Once again, just reminding you that we would definitely want to have more than 3 here, and we would also want to have a lot more variety in kind of the structure of these requests. But again, for right now, this is definitely appropriate. I have a sample task to generate a Python function, to write out a JSON schema, and 1 regular expression as well. So this is overall looking pretty solid. The next thing I'm going to do is save this data set into a JSON file, just so I don't have to constantly regenerate the data set. So I'm going to say dataset. It's going to be the result of that generation. I'm then going to open up a file called dataset.json in write mode. And I'll do a json.dump dataset, and I'll format it really nicely, just in case we ever want to open up that file and see what it looks like. So I'll write that file. It's going to take a moment just because I'm regenerating the data set again through Haiku, and that should be it. So now if I open up that dataset.json, here is my data. Okay, this is a good start. We've got our eval dataset put together. With our dataset generation complete, we now need to take every record in that dataset, which we're going to refer to as a test case. So we're going to take each test case and merge it with the prompt. We're then going to take the result and feed it into Claude. And then once we have all these different outputs, we're going to feed them through our grader. Remember, we have not discussed graders just yet. Don't worry, that's going to come up very quickly. And once again, just to save a little bit of time, I have written out a little bit of code here just to help guide this next phase of our workflow. I put together 3 separate functions with a very clear comment on what each one does. The first one that's easiest to understand is the run prompt function. This is going to be called with a test case. And those JSON objects that we generated just a moment ago, each of these is a test case. So you can imagine that each of these, one by one, are going to flow into the run prompt function. So inside of here, our goal is to merge that task that we generated with our prompt, generate some text with Claude, and then return the result. So let's do that right away. I'm going to put in my V1 prompt right here, which is very simple. Remember, we are starting off as simple as possible here. So it'll just say something like, please solve the following task. And I want this to be a F string, and I'm going to put in test case task. Next up, we want to send this off to Claude. So I'll make a list of messages. I'll add in a user message. I'm then going to pass this off to Claude by calling chat. And we're going to get back some resulting text, some result, or maybe we'll call it output this time around. And then for right now, I'll just return the output. Now, remember, we don't have any kind of formatting included or any formatting instructions inside the prompt right now. So we're going to probably get back a lot more output than we ever asked for. The real goal of our prompt is to make sure that we get just Python or JSON or that regular expression. And we don't have anything for that right now, so we'll almost definitely have to come back and make some improvements. But for right now, we at least have a start to run prompt. The next thing we're going to work on is run test case. The goal of this function is to take in one of those individual cases, call the run prompt function we just put together, get some output from Claude, and then grade the result and return a dictionary describing everything that happened there. Now, that sounds really complicated, but in reality, it's going to be surprisingly simple. So let me show you all we have to do here. We're going to put in output. That's going to come from calling the function that we were just working on a moment ago. So this run prompt function. Put in our test case. And then we're going to do some grading right here. That's going to be a to do. For right now, I'll just say that we have a hard-coded score of 10. So we definitely have to come back and do a lot of heavy lifting right there. And then at the bottom, we're just going to return some information that summarizes everything about running this test case. So I will return a dictionary with some output. It's going to be whatever we got back from Claude. I'll include the test case. And then our score. And then one final step here, we have to implement run eval. So this function is going to load up our dataset or receive it as an argument. Either one is fine. And then we're going to loop through that dataset. And for every test case, we will call run test case and then just assemble all the results together. So for our implementation here, I'll say results. It's going to start off as an empty list. And for every test case in dataset, I'm going to get our result from calling run test case and passing the test case to it, and then add that into our list of results. And then down here, I'm just going to print up all of our results. Actually, you know what? Let's actually just go ahead and return results. I think that's a little bit better. Okay, so there's the outline for our three major functions. Now, believe it or not, this is like a vast majority of what a eval pipeline is. We just put together the vast majority with the obvious exception of grading. So as you can see, there's not a whole lot of code that goes into this. Let's now test this out. So down here in the next cell down, I'm going to open up our dataset JSON file. And parse it as JSON. And then call the run eval function. That's the one that we were just putting together right here with the entire data set. Finally, I'm going to assign the results of that to results. I'm then going to rerun all the cells above just to make sure that I executed all of them. And then I'm going to run this cell. We'll see what happens. And just so you know, the first time you run this, it is going to take a pretty good amount of time, even if you are using Haiku. It's going to end up taking me about 31 seconds to complete this with Haiku. I'm going to show you some techniques for speeding up our eval runtime, but for right now, we're just going to have it take a little bit longer, but don't worry, we will speed it up. So now let's take a look at results and see what we have. Results is going to be a rather large JSON object, so I'm going to print it out really nicely with a print JSON dumps with results and an indent of 2. There we go. So now we get an array of objects. Every object represents the output from one of our individual test cases. I've got the output right here. That's the output coming from Claude. And we can see there was a lot of stuff generated here. And if I scroll down a little bit, I'll see the definition of the test case that this was based upon. And then the score, which again, right now is just hard-coded at 10. And then that's just going to repeat over and over again. All right, so at this point in time, we have successfully gone through this step right here. We merged together our data set with our test prompt, and we got some output from Claude, and we kind of collated all this stuff together. So now the last thing we really have to do here is take the input and the result that we got out of Claude and feed it into one of these different graders. So this finally is the time where we're going to start to learn about graders. We're going to start to discuss them in the next video. The next thing we're going to implement inside of our prompt evaluation workflow is a grading system. Now, as a reminder, a grader is going to take in some output coming from our model. And then our hope is that the grader is going to give us some kind of objective signal. It might be a number or a true or false value. It could be really anything, but very commonly, very frequently, you're going to see a number output between 1 and 10, where 10 means that we got a very high quality output, and 1 means we got a very low quality output. Again, that's not a requirement. We don't have to get numbers out of these graders, but it's a very common practice you're going to see very often. There's 3 different kinds of graders that we're going to discuss in this video: code, model, and human. Let's first figure out what code-based graders are all about. With a code-based grader, we're going to take the output from our model and feed it into a snippet of code that you and I author. Inside this code, we can do just about any kind of programmatic check you can imagine. So we might verify to make sure that the output from the model was not too long or too short. We might make sure that the output does have or doesn't have certain words. If we are returning JSON or code, we can do syntax validation programmatically, and we can even do more complex checks like implement a readability score, where we make sure that the generated text is at an appropriate reading level for our particular use case. The only requirement here is that when we run this code, we return some kind of actual signal we can use. And again, usually that's going to be a number between 1 and 10, but that is not a hard requirement. The next kind of grader that you're going to see very often is a model-based grader. This is where we take the output from our original model call, so the one that we already made, and we feed it into an additional model. So this is another API request. When we use a model grader, we get a tremendous amount of flexibility. We can ask a model to evaluate a response based upon its general quality, maybe how well it followed prompt instructions, maybe the completeness of the response, really just about anything you can imagine. Once again, the only real requirement here is that the model gives us back some kind of hard objective signal, usually as a number between 1 and 10. And then finally, human-based grading. With human-based grading, we're going to take all the outputs from our model and then put them in front of an actual person. This person is then going to be in charge of evaluating these responses in some particular way. As you can imagine, humans are very flexible, so we can ask them to evaluate responses in just about any fashion or for any metric you can possibly imagine. The one big downside to human-based grading is that it generally does take a lot of time, and it's certainly very tedious work. Now, no matter what style of grading you are using, you need to decide upfront what your evaluation criteria is going to be. So in other words, exactly what aspects of these responses are you going to be focusing on? For our particular use case, I've centered on 3 different evaluation criteria. I think first off, we should evaluate the responses to make sure that we're only getting back Python, JSON, or regular expression without any additional explanation being provided by Claude. Secondly, whenever we get that Python, JSON, or regex, we should make sure that it has some valid syntax. So there should be no typos in there or anything like that. And then finally, we should probably do some general task following and make sure that the model clearly addressed the user's task and answered it with some generally accurate code that doesn't contain any major errors or logic mistakes. So for these 3 different evaluation criteria, I think we can evaluate the first 2 with a code grader. So we can evaluate the format and make sure we got actual Python, JSON, or regex with code. And we can also validate the syntax of that code using, well, additional code. And then finally, the general response and making sure that the user's question was clearly addressed, that would be more appropriate to address through a model grader, given its flexibility. All right, let's start to implement first the model grader, because that's, believe it or not, going to be the easiest one to put together. I'm going to first begin by going back over to my notebook. I'm going to find that to-do we had put together right here inside of our run test case function. And then right above that cell, I'm going to add a new cell with a function that I'm going to call grade by model. And I'm going to assume that I'm going to pass in my test case dictionary. Remember, the test case dictionary is essentially these objects right here. Each of these data set values, these are our test cases. I'm also going to pass in the output from our original model call. And then inside of here, we're going to essentially make a call off to a model and ask it to grade the output. So for this, we usually end up writing a fairly long prompt. And again, just to save us a little bit of time, I'm going to copy paste a prompt in. So here we go. I'm going to paste this in. And yes, it is a little bit long, but this is kind of the bare minimum of what we want. So this prompt is going to set a role. It's then going to ask very clearly for the model to evaluate an AI-generated solution. We're then going to print out the task. We're then going to list out the solution that was generated by the model. And then we're going to provide some directions on exactly how to respond. In this particular case, I'm asking the model to give me a list of strengths and weaknesses of the AI-generated solution, along with some reasoning behind that and an actual score. Now, we could just ask for a score by itself, but if you do so, you're going to see very often you tend to get scores of just 6. So if you don't ask for any additional strengths or weaknesses or reasoning, you're going to very often just get very middling scores because the model kind of assumes, well, could be better, could be worse, we'll give it a 6. By asking the model to provide some reasoning, strengths, and weaknesses, you really make it hone in and decide upon a more concrete score. So now that we have that prompt in here, I'm going to call our additional grading model. So right underneath it, I'll again make a messages list. I'll add in a user message. And then because we are getting back some JSON here, we need to once again make sure we extract that cleanly by using a pre-filled assistant message and a stop sequence. So we'll add a assistant message with backticks JSON. And then I'll get back some eval text. And we'll call chat with messages and a stop sequence or stop sequences of, once again, closing backticks. Now this eval text should be a JSON object with this kind of structure right here. So I'm going to parse that and just return it. So I'll return a json.loads with eval text. Okay, so that is our model grader. That's really all it takes to at least get started. So now we need to make sure we actually call this grader. To call the grader, I'll go down to our to-do right here. I'm going to replace score with model grade, and that's going to be coming from our grade by model function. And remember, we have to pass in the test case along with the output from actually running the prompt. And then from this, we're going to get a score from model grade. And I'm also going to extract from that dictionary that gets returned the reasoning behind the score. Inside of this model grade dictionary that we are returning, there is also going to be the strengths and weaknesses list. You could definitely extract those as well as you want, but I'm just going to keep our example a little bit more concise. I'm going to take the score and reasoning and put them into this final output dictionary. So I will add in some additional keys here of score. Oh, I already have score right there. My mistake, so I don't need that. But I do need reasoning. And that will be reasoning. Okay, so that looks good. I'm now going to make sure I run these cells. So I'm going to run that one, update run test case. And then I'm going to rerun my actual evaluation. That is going to take a while to complete. For me, it takes about 22 seconds this time around. And now if I print out those results, let's see what we get. So I've now got the generated output here. And if I scroll down a little bit, I can take a look at the score that was generated by the model and some reasoning behind that score. So in this case, I got an 8. That's not bad. And that's why I got the 8. And if I keep going down, the next one got a 7. And then finally, I got a 6. So the last thing we would probably want to do here is take all these scores, add them together, get an average, and print that out. So we get a final, very objective score to tell us how well our prompt is currently functioning. So to average all these scores out and print the results, I'm going to find the run eval function right here, and I will calculate the average score with a comprehension of result score for result in results. And I'm going to wrap that with a mean function call. And then I will import the mean function from the statistics package. Oh, one last step. Let's make sure we actually print out that average score. We'll do a print average score like so. All right, now I'm going to run this code just one more time to make sure everything is working as expected. And after it runs, I see that I do get, in fact, an average score of 7.33. And once again, this gives us finally an actual objective metric. Yeah, it's being graded by a model that might be a little bit capricious sometimes, and maybe we could give it better guidance on how to grade things, but at least we have a score that we can start to focus on and try to increase. Next up, we need to implement our code grader. So our code grader is going to take in some output from the model and make sure that we get back just plain Python, JSON, or regular expression without any kind of explanation. In addition, we should also make sure that we have valid syntax for whatever type of code we actually got. You might be kind of curious, how are we going to validate the syntax of, say, Python at all? Well, we use a little trick for this. We're going to define 3 helper functions. One will be called validate JSON, another validate Python, and another validate regex. Then inside of each of those, we're going to take whatever output we got from the model and try to either parse it as JSON, we'll try to parse it as a Python abstract syntax tree, or AST, or we'll try to compile it as a regular expression. And then for each of these, if we successfully parse or load or whatever else, we'll return a full score of 10. Otherwise, if we get an error during this parsing operation, we'll assume that we completely failed the syntax check and return a 0. There is one other thing to be aware of here. In order to know which of these different validators or these kind of grading functions to run, we need our test case dataset to include the expected format that we're going to get back for each output. So in other words, back here inside of our dataset, on our first task, for me at least, I was expecting to get back a Python function, and then JSON, and then a regex. So we need to update our dataset to include something like a format key that will say, hey, this output should probably be Python, this one should be JSON, and this one a regex. Now, of course, I could just edit this file manually, but instead we will update our prompt that is generating our dataset so that we can eventually generate really large datasets for testing purposes. Now, in total, to do all this stuff, couple of different steps we have to go through. So just to help you understand the code side of it and keep everything in line, I came up with this quick checklist of items that we're going to go through. So our first item, add in functions to validate JSON, Python, and regular expressions. For this, I'm going to flip back over to my notebook. I'm going to find the run test case cell. I'm going to add a new cell right above it. And then inside there, I'm going to add those 3 functions that you just saw inside that diagram. Once again, to save a little bit of time, I'm going to paste them in here. You can always copy the completed code out of the finished version of this notebook. So at the top of the cell, I'm importing these 2 helper modules. I've then got the 3 different validator functions that we just saw. And then at the bottom, I have kind of a general purpose function to figure out which of these different validators to use. So I've got great syntax right here that's going to take a look at the test case. It's going to look at the format in particular. So we need to make sure our test cases have that format property that I just mentioned a moment ago. And then depending upon that, we're going to call the appropriate format function. Okay, that is step 1. Now step 2, we need to update our dataset to make sure we include that format key. So for that, we'll scroll up a little bit and find our dataset. Here it is right here. So generate dataset, and I'm going to add on to the example output. On task, I'm going to add a comma at the very end, and I'll add in a format key. And inside of here, we'll say simply JSON or Python or regex. That's really all we have to do. So now if I rerun that cell and rerun the cell underneath it that actually generates the data set, there we go. Now I'll go back over to my dataset file and I'll see, yes, I did in fact get the format inside there. And it looks like it matches up with the task perfectly. So the first task is create a JSON configuration, got JSON, write Python, got Python, and then write a regular expression, and I got regex. Okay, on to step number 3. Now we're going to update our draft prompt template just to make sure that it's really clear that we only want JSON, Python, or regular expression. Because right now, our draft prompt just kind of says, yeah, try to solve the task. So inevitably, we're going to get back some non-JSON or non-Python content, and we'll always be failing the actual validation check. So we're just going to give our prompt a little help here, give it some work that we know that it needs. So for step 3, we'll go back down to our run prompt, which is where our draft prompt is. And I'm going to update the prompt just a little bit. I'm going to add in some notes, and I'll ask it to respond only with Python, JSON, or a plain regex. And do not add any comments or commentary or explanation. Next up, I'm going to make sure that we get back just that raw content that we really care about. And once again, to do so, we'll use a pre-filled assistant message along with a stop sequence. So I'll add in a assistant message right here. And my assistant message in this case, I can put in 3 backticks. And then usually, as we saw previously, we might put in something like JSON or Bash or Python right here. But in this particular case, we don't really know ahead of time the exact format that we expect to get back. We don't know if we're going to get back Python or JSON or regex. So one little cheat code here, one little workaround, we could just put in code, and that kind of pre-fills the assistant message and tells Claude, hey, you're going to put some code inside of here without us having to specifically say this is going to be Python or JSON or regex. I'm then going to add on the closing stop sequence with backticks like so. Lastly, we need to actually merge the scores from our model grader and the code grader together. So for that, back over here, I'm going to scroll down once again, and we will find our run test case function. So this is where we are running our model grader. Right underneath it, I'm going to put together the syntax grader or code grader, whichever you want to call it. So I'll say my syntax score is grade syntax. We need to pass in the output and our test case. And then finally, we're going to merge the syntax score together with the model score. I'm going to first rename score right here to model score, just to be clear. And I'm going to take the average of these 2 scores. So I'll say score is going to be model score plus syntax score divided by 2. And that should be it. So that's all it took to add in a little bit of code grading. So last thing to do is test this all out. To do so, we'll go down just a little bit here. So right underneath the run eval function is where we actually call run eval and calculate our overall average score. So I'm going to rerun this, and remember, it usually takes a decent number of seconds to complete. And after a short pause, I get a final score of 8.166. So now the question is this good or not? Well, the real answer to that is that we just don't know. The only way we're going to know is if we now try to change our prompt in some way and hopefully get a better score. So let's try out an exercise in the next video where we will try to change our prompt a little bit and hopefully improve our score. Let's try out an exercise to improve our prompt evaluation workflow. So here's the task I'm going to give you. I want to improve our model grader a little bit by providing it with more context on what a good solution should actually look like. Now, at first glance, that might sound a little bit challenging, but it turns out you only really have to go through 2 steps to add in this additional context. So in step 1, I would encourage you to go back to the prompt where we generate our data set. And inside that prompt, try asking it for some solution criteria to be included in every test case. So ideally, our test cases that get output should now have some additional solution criteria key, which might look like what you see right here. So it might say something about what a good solution would look like. Maybe say, well, a good solution would include this characteristic and this characteristic and this characteristic. Once we have this additional solution criteria, we can then insert that into our grade by model prompt. So you might find the existing area of that prompt where we put in our solution to evaluate, and then right after it, you might add in that newly generated solution criteria. And that's all it would really take to give our model grader a little bit better idea of what a good solution would actually look like. As usual, I would encourage you to pause the video right now and give this exercise a shot. Otherwise, we're going to go through a solution right now. So the solution really is just going to be these two separate steps. Should be pretty straightforward. To get started, back inside my notebook, I'm going to find our generate dataset function. And inside there, I'll find the really big prompt we put in. And then when we ask for each of these different test cases, I'm going to say, in addition to the task and the output format, I also want to get some solution criteria. And then I'll put in a string right here just to give our model an indication of what this key should actually be. So I'm going to ask for some key criteria for evaluating the solution. And that's pretty much it. So I'm going to rerun the cell. I'm going to go to the cell underneath it and regenerate the data set. Okay, just a couple of seconds, it should be done. There we go. So now we should have an updated dataset.json file. I'm going to open that file up. And I should now see some updated tasks in here, still with the format, but now I've also got some solution criteria. So the solution criteria, we can read over. Of course, yours is going to look different than mine, but it's going to give some idea on, again, what a good solution will actually look like. Next up is step number 2. We're going to find our grade by model function and specifically the prompt inside there. And we're going to include this newly generated solution criteria, again, just to tell the model grader what a good solution looks like. So for that, I will go back to the notebook. I will scroll down and find that grade by model function. Here it is right here. So I'm going to find the prompt. We are already putting in the original task, the output that was generated, and then right after that, I'm going to put in some note to the model and just say, here's some criteria that you should use to evaluate the solution. So criteria you should use to evaluate the solution. I'm going to put in some tags. And I'll tell you why we are adding in these tags very shortly as we start to discuss prompt engineering. And then I'm going to interpolate in from the test case our solution criteria. And that key right there, remember our test case is really these objects, each of these objects one by one. So we know because we see it right here inside this file, there is a key inside that dictionary of solution criteria. So we're taking that sentence right there and putting it right here. All right, so now time to run this cell. And we're going to rerun our pipeline and see how everything is working. So I'll go down to the run eval function, and then right after that is where we actually execute everything. So I'm going to run that, and then we get our updated score back. Now I want to print out the results really quickly, just so we can see how this is going to affect the actual output. So we'll do another print of JSON dumps results with an indent of 2. So now we can see the output from our model. So that's the actual produced output. Here's our test case. So we can take a look at the task and the solution criteria. Here's the score. In this case, it was 9. And now hopefully our reasoning section, which is produced by the model grader, is going to be a little bit more fleshed out than it was before because we are including that solution criteria. Now that we've got a handle on prompt evaluation, we're going to move on to the world of prompt engineering. Remember, prompt engineering is all about taking a prompt that we've written and improving it in some way to get more reliable outputs and higher quality outputs. To understand prompt engineering, we're going to go through a series of videos in this module, and I want to very quickly help you understand how the module is set up. In this video and the next, we're going to write out an initial prompt, and then in the coming videos, we're going to try to improve it step by step by implementing new prompt engineering techniques on that original prompt. So in short, in this video, we're going to set a goal, so something we want our prompt to do. We're then going to write an initial version of that prompt, so kind of like a really poor first attempt. We will then eval the prompt, and then we're going to see right away that we get a very poor evaluation score. And then, as I mentioned in the coming videos, we're going to learn about and apply some different prompt engineering techniques. And as we apply each of these, we're going to run our evaluation again and see that we are getting better performance with every single improvement we make. Now, to run these evals, we're going to use that same kind of eval pipeline that we put together in the previous module. Just one little twist here, something you really need to be aware of if you want to follow along and code with me. I took our original eval pipeline that we put together in the last module, and I made a couple of different improvements to it to make sure that it can work with just about any prompt, as opposed to the very specific prompt we were working on previously. So to get this updated notebook that has this more flexible evaluation pipeline, make sure you download the accompanying notebook named 001_prompting. Before you open up that notebook, however, I want to very quickly tell you about the goal of our prompt. So this initial prompt that we're going to write and exactly what it is intended to do. All right, so we're going to make a prompt that's going to hopefully generate a one-day meal plan for an athlete based upon their height, weight, some kind of physical goal that they might have, and any dietary restrictions they might have. So you can imagine that we are going to take in some kind of sample input that describes an athlete, maybe their height, weight, goal, and dietary restrictions. We're then going to interpolate all those inputs into our prompt, and then we're going to send that off to our model. And hopefully we'll get back some kind of output like what you see on the right-hand side. This is what we're really going for. This is our ideal output. In the first version of our prompt, we're going to get some output that looks nothing like what you see here on the right-hand side, but through a variety of different prompt engineering techniques, we're going to eventually refine the prompt and eventually hopefully get something that looks almost exactly like this. All right, so now that we understand our goal, let's open up that new notebook. So remember 001 prompting. I'm going to give you a very quick tour of it because a couple of things have changed compared to the last module, and just make sure everything inside there is super clear. We'll then use the notebook to generate our initial data set. All right, so I've opened up that notebook. Right away, you'll notice there are a couple of collapsed cells at the top. So this is a lot of different setup code. Just make sure you execute those cells at least one time. So I'm going to do so right away. Next up, you'll see that I'm creating an instance of something called a prompt evaluator. Prompt evaluator is a class I created that wraps up all the dataset generation, all the model grading, just about everything is wrapped up inside of this class. The class takes one argument, max concurrent tasks. So this class supports concurrency. We can make multiple API calls at the same time. The upside to this is that it's going to dramatically speed up our eval process and the dataset generation process as well. But I do need you to be aware that depending upon your service quota, you may or may not very quickly start to run into some rate limit errors. So if you see any rate limit errors at all as you go through this module, I would highly encourage you to change this value right here all the way down to the default of 1, which means no concurrency at all. For me personally, I have super high rate limits, so I'm going to dial this all the way up to a concurrency of 50. Chances are you are not going to be able to use 50. So don't try 50. I would really recommend maybe starting off at 3. And then if you see any rate limit errors, start to go down to 2 or 1. Again, I'm going to use 50 just so you can see some immediate feedback on my screen as I run all these different steps. Now I'm going to make sure I run that cell. And then let's get started on generating our actual data set. So to generate the data set, I've added this new generate dataset method for us. To use this method, we're going to describe the overall purpose of our prompt. So kind of what our prompt is supposed to do. For you and I, we're trying to work on a prompt that is going to write a compact, concise, one-day meal plan for a single athlete. And then inside of this prompt input spec, we're going to have a dictionary that's going to list out all the different inputs that our prompt requires. As we saw just a moment ago, our prompt is going to require a height, a weight, a goal, and some dietary restrictions. So these are some extra properties that are going to be generated as a part of the data set, and eventually we're going to take them test case by test case and interpolate them into our prompt. So I'm going to fill out all 4 of these different properties. My height is going to be the height in cm. And just to be clear, I'll put in athlete's height. And I'm going to duplicate that because it's going to be just about the same. We're going to do our weight in kilograms. My goal is going to be the goal of the athlete. And my restrictions will be dietary restrictions of the athlete. Now, last input for you to be aware of is number of test cases to generate. I would really recommend that you just leave this at 3 because it's going to allow you to get through this module way faster because the evals are going to run much more quickly. Just remember, as I mentioned many times, whenever we do an eval, in reality, we want to have a really solid, really large number of test cases. So I'm going to dial mine personally way up. I do not recommend you do this. I recommend you leave it at like 2 or 3, just to make sure all your evals run very quickly. But again, I'm going to dial mine all the way up to 50. Once I put this all together, I'm going to run the cell, and that's going to generate my data set. Once I have generated my data set, I can open up the dataset.json file, which should be created in the same directory. And we're going to see all these different individual data sets have been generated. So they have a pretty similar structure to what we were doing on our previous module when we were talking about prompt evals. I'm going to go back over to my notebook and then scroll down a little bit to the run prompt function. This is where we are going to write out our prompt and then eventually improve it over time. This function gets called one time for every test case that you generated. Whenever this function is called, it's going to receive your test case's prompt inputs as its only argument. So in other words, prompt inputs right there is going to be that dictionary. And then that function is going to be called again, and it will be that dictionary. And then again, and it will be that dictionary, and so on. So we're going to take this dictionary, and we're going to interpolate those inputs into this prompt that we're going to write out right here. Let's immediately write out a first version of our prompt, and it's going to be very simple, very naive. We're going to get a very bad eval score, but it will at least get us started. So I'm going to write in my initial starting prompt here, and I'm going to use a very bad prompt. I'll say, what should this person eat? And then I'm going to list out their height, their weight, their goal, and dietary restrictions. And then for each of these, I'm going to interpolate in a value from prompt inputs. So the first one will be the height, and I'm going to copy paste that just to save a little bit of time and update the keys on each one. So make sure you have first height, and then we want the weight, and then our goal, and then restrictions. All right, once we have our starter prompt in here, I'm going to run that cell, and then let's do our eval. So we can run our eval down here at the very bottom. Now, before we run our eval, I want you to know that this function that's going to actually kick off the evaluation process, it takes in one additional keyword argument that I'm not showing here. It's called extra criteria. It's going to be a string. This string is going to be used during the model grading process. This extra criteria thing just allows you and I as developers to put in some extra criteria that the model should consider whenever it's doing some grading. So I'm going to say specifically to make sure that the output should include a daily caloric total, a macro nutrient breakdown, and meals with exact foods, portions, and timing. Again, this is just going to add in a little bit of extra validation or a little bit of extra grading criteria. All right, so now let's run our evaluation for the first version of our prompt and see how we're doing. All right, we get a absolutely terrible score. I get a 2.32. Now, just so you know, you are probably going to end up getting a much better score than I get. The reason I have a very bad score here is that I'm using a model behind the scenes that is not super smart. So it's going to tend to give me really bad output unless I'm very specific in how I prompt it. I am using this very bad model just so you can see the increase in score over time as we go throughout this module and add in all these different prompt engineering techniques. So again, you are probably going to get a better score. That's totally fine. Now, before we move on, there's one last thing I want to mention really quickly. Whenever you run an evaluation, a file will be created in the same directory as your notebook called output.html. If you open up that file inside of your browser with a simple drag and drop, you're going to see a really nicely formatted report that gives you output on every single test case that was executed, along with the score, the reasoning, solution criteria, and so on. You could also see the actual output too. So I'm going to use this little dashboard quite a bit in order to take a look at the output of the eval and understand how I actually need to improve my prompt. All right, I apologize for the long video here, but now hopefully you have an idea of some of the setup that we're doing inside of this module. So now all we really have to do, as you can see, we have really bad score right now. All we have to do is start to improve our prompt. So let's start to take a look at our first prompt engineering technique in the next video. With a starting grade of 2.32, we can definitely only go up. So with that in mind, let's take a look at our first prompt engineering technique that we're going to use to improve our prompt. All right, so we're going to be discussing the idea of being clear and direct. These two rules are really talking about the very first line of your prompt. The first line of your prompt tends to be the most important. In that first line, you want to use simple and direct language and tell Claude with a kind of action verb exactly what its task is. So, for example, we might want to have a first line of a prompt be something like write 3 paragraphs about how solar panels work. That tells Claude that it's going to have a job. It needs to write or generate or create something. It also clarifies a little bit of information about the expected output and exactly what that output should contain. So we're really setting an action and providing a task in that very first line. Another great example would be identify 3 countries that use geothermal energy and for each include generation stats. Again, we are telling Claude to do something or giving it an immediate task and a little bit of information about the expected output. Let's take this idea of being clear and direct in the very first line of our prompt and see if we can't use it to improve the outcomes of our prompt that we're currently working on. Using that rule that we just learned, I might update this line to say something like, generate a 1-day meal plan for an athlete that meets their dietary restrictions. So again, I'm being direct by making use of a action verb at the very start, and then in very simple language, I'm providing a direct task for Claude to fulfill. Now let's rerun the cell to get our updated prompt, and then rerun the eval itself, and see if this does anything to improve our score. And I bet, as you can guess, yeah, we're probably going to do a little bit better than we did previously. So I think before I had a 2.32, now I'm up to a 3.92. Definitely an improvement, but still not great. So let's move on to the next video and take a look at our next prompt engineering topic in order to improve our prompt a little bit more. The next topic we're going to discuss in the world of prompt engineering is the idea of being specific. To be specific, we want our prompts to list out some sort of guidelines or steps to somehow direct our model in a particular direction. For example, consider the prompt I have on the left-hand side of the screen. In this prompt, I'm asking Claude to write out a short story about a character who discovers a hidden talent. If I just put that prompt by itself into Claude, Claude can go any of an infinite number of directions. It can decide to vary the story length significantly. It can decide to add in extra elements or remove elements from the story. It might have just one character. It might introduce 5 different characters. If I want to ensure that I'm going to get a particular kind of output, I might decide to put in a list of guidelines, as you see on the right-hand side. These guidelines will provide some high-level guidance or kind of direct Claude in a specific way when it starts generating the response. So for example, I might decide to add in some guidelines of keeping the story under 1,000 words, add in some rising actions, and including at least one supporting character. Now I've provided a little bit of guidance to direct Claude towards writing a particular kind of short story. Now, there are 2 kinds of guidelines you're going to see very often in prompts. Type A on the left-hand side is kind of like what I just showed you in the previous diagram. You might decide to put in a list of guidelines, and those are going to list out some qualities that you want your output to have. So you might try to control maybe the length of the output or the structure of the output, or maybe list out some different attributes that the output should have. On the right-hand side, the second type of guidelines that we can provide are to provide some actual steps that the model should follow, with the intent of making the model think about specific things or choose between different directions that would hopefully increase the quality of our output. So for example, we might instruct Claude to maybe first brainstorm 3 special talents that would be really interesting, and then pick the most interesting one. We might then ask Claude to try to outline or think about some kind of interesting scene that would reveal that talent, and then think about different kinds of supporting characters that could make the story a little bit more interesting. So on the left-hand side, we're really guiding attributes in the output. On the right-hand side, we're trying to be a little bit more specific in how Claude arrives at the final product. You can absolutely, and you're going to see this very often in professional prompts, you'll absolutely very often see these 2 techniques mixed together. So you might have a list of guidelines that intend to control some attributes of the output, and then a list of steps that the model should follow as well. Both of these are examples of being specific in your prompting. So now that we've seen some idea around what it means to be specific, let's go back over to our prompt in progress and see if we can incorporate this idea of being specific. All right, so back over here, I'm taking a look at my run prompt function. Now, just to save a little bit of time, I'm going to first paste in a list of guidelines. So this is kind of like that first type of being specific, where I include a list of attributes that I really want to see inside of the output. I'm going to run that cell. and then go down and run the eval again. And let's see what we get here. So after a quick pause, I'm going to get back a final score of 7.86. That is an incredible improvement over our previous 3.92, just by adding in a little bit of guidance and telling Claude precisely what things we want to see inside of the output. Now I'm going to try to put in a little variant of this, where I use that second variation of being specific. So I'm going to provide some steps that Claude should follow when deciding exactly how to build up this meal plan. So now in this scenario, I'm telling Claude to first do a calculation and then think about this and then do a bit of planning. You kind of get the idea. I'm providing some steps that Claude should go through. I'm going to run the cell again and then run down here. And I'm going to remember that score of 7.86. That is really, really high. Might be a little bit of a statistical anomaly. And now we get 7.3. So still a dramatic improvement, but not quite as good as listing out some attributes that we'd want to see inside the output. So for me, I'm going to revert and go back to listing out some guidelines. So when would you want to use one technique versus the other? Well, I would generally recommend almost always listing out qualities that the output should have, as I'm showing on the left-hand side, on just about any prompt you ever work on. And you will usually want to provide steps that the model should follow, as shown on the right-hand side, anytime you are asking Claude to work on a more complex problem, where you want to kind of force Claude to consider a wider view or some extra topics beyond what it naturally might want to consider. For example, consider the prompt on the right-hand side of the screen, where I ask Claude to figure out why a sales team's numbers have dropped in the last quarter. In this scenario, we might want to force Claude to consider some extra viewpoints or extra pieces of data that it might not otherwise immediately consider. All right, so now that we've got a better idea of what it really means to be specific and this idea of adding guidelines or steps as the situation warrants, let's take another break right here and then move on to our next prompt engineering topic in just a moment. The next topic we are going to examine is the idea of providing structure in your prompt by using XML tags. Now, let me give you a little bit of backstory on this. Very often, whenever we write out a prompt, we're going to interpolate some amount of content into it. And we've been doing that already. Inside of our example, we have been interpolating some height, weight, goal, and restrictions. Now, each of these values are rather small, but it's entirely possible that we might eventually write a prompt where we need to put in a lot of content into a prompt. For example, examine the prompt on the right-hand side. We might decide to paste in 20 pages of sales records and try to get Claude to analyze them in some way. Whenever we dump a lot of content into a prompt, it can be a little bit challenging for Claude to figure out exactly what text really means what, or how text is actually grouped together. One way that we can make the structure of our prompt a little bit more obvious is by wrapping different pieces of content in XML tags. So for example, I might provide a little bit more structure to this prompt on the right by wrapping the sales records right here with an XML tag of sales records, like so. Now, there is no official XML tag called specifically sales records. This is a name of a tag that I just made up that will probably give Claude a little bit of insight into the nature of the content that exists inside these tags. I could have just as well called this records, or perhaps even data. But of course, being a little bit more specific here is definitely better. So providing a tag of something like sales records would probably get us the best output. Now, I want to make sure it's really clear why XML tags like this are necessary. So let me show you a little exaggerated example. In the prompt on the left-hand side, I have a leading line of debug my code below using the provided documentation. So this kind of implies two things. It implies that underneath this header statement right here, I have some amount of code that was written by me that is buggy and some amount of documentation as well. And if you just look at the code that's listed out here, it's absolutely not very clear what content is the code and what content is the actual documentation. One way that we could clarify this to Claude would be to wrap each chunk of code with appropriate XML tags. For example, on the right-hand side, I might wrap my code with some XML tags that simply say my code, being very direct and obvious, and then the code that represents some amount of documentation in a docs tag, again, being very clear and obvious. Now it is much easier for Claude to understand what code it is trying to debug and which code provides some source of documentation. Let's take this idea of providing structure via XML tags and try to use it to improve our prompt that we are working on back inside of our notebook. Now, unfortunately, in this particular scenario, we don't really have a big blob of content that we really need to delineate in any way. All of our interpolated content, like the height, weight, goal, and restrictions, are sufficiently short that Claude is probably not going to be confused by them in any way. Regardless, we can still use some XML tags to make it really clear that this is some kind of external input or maybe some information about the athlete that should be considered when generating the meal plan. So we might decide to wrap this entire block right here with some XML tags that just make it really clear that this is information about the athlete. So I might put in tags like athlete information, and then a closing tag on the other side. Now let's try to measure and see whether or not this has any kind of impact on the quality of output. So I'm going to rerun the cell. I'll go down to my eval cell and run this one. And then you might recall that before adding in those XML tags, I had a score of 7.3. So let's see if we go up or down. And I end up going up quite a bit. Now, you probably are not going to see an improvement quite this large. As a reminder, I'm using a little bit more simple and basic model just so I get some exaggerated returns in these improvements to the prompt. So if you do not see quite a jump in quality, that is totally fine. I'm really excited about this next prompt engineering technique we're going to discuss because it is probably one of the most effective that you're going to find. It's the idea of providing examples inside of your prompt. This is often referred to as one-shot or multi-shot prompting, depending upon whether or not you are providing just one example or multiple examples. Understanding this concept is definitely easiest if you take a look at an example, so let's do that right away. Consider the prompt on the right-hand side. I'm asking Claude to categorize the sentiment of a tweet. Just be clear, when we say sentiment, we mean kind of, does this tweet seem kind of happy or positive in nature or unhappy or negative? In this particular instance, I provided an input tweet of, yeah, sure, that was the best movie I've ever seen since Plan 9 from Outer Space. Now, if you're not aware, Plan 9 from Outer Space is a famously bad movie. So if someone were to tweet something like this, they're actually probably being sarcastic and they probably did not like the movie they just watched at all. So we would probably want to classify this tweet as being negative. But Claude could potentially have some issue categorizing this. One way to solve the problem would be by using multi-shot prompting. So here's how we would fix this. We would take our starting prompt that we have on the left-hand side and add in some examples, which I've added in on the bottom half of the prompt right here. To add in an example, we will very directly tell Claude that we are about to give it some example input and an ideal perfect world kind of response. We'll almost always wrap these inputs and outputs inside of some XML tags just to better structure our prompt and make it super clear to Claude what the purpose of the input and output are. So in this particular example, I have given a sample input of great game tonight, which I would say is definitely positive in nature. So right after that, I would then put in an ideal output of simply positive. This gives Claude a concrete objective example of how to deal with some kind of input. So now Claude knows that if it ever sees some kind of input like this again in the future, well, it should probably label it as positive because that's how it was done in the past. We can make use of multi-shot prompting. That's where we provide multiple different examples whenever we want to handle corner cases. And dealing with sarcastic tweets like this is definitely a corner case that we kind of want to highlight to Claude. When adding examples that highlight corner cases, add in some context to Claude and tell it that it should be especially aware of certain scenarios. So for example, we might say, be especially careful with tweets that contain some sarcasm, and then provide an immediate example of that. So now in this case, I've got a example tweet or a sample input of, oh yeah, I really needed a flight delayed tonight, excellent. If you didn't understand the concept of sarcasm, this would seem like a positive sentiment tweet, but of course, we can probably understand that this is sarcasm, and so it probably is actually negative. Once again, Claude can take a look at this example when grading our provided input up here, the original input, and Claude will have a better chance of recognizing that, oh yeah, this looks like it's sarcasm too. This is also probably negative in nature. Now, multi-shot prompting like this can be used not only for capturing corner cases or giving a little bit more clarity to Claude, but also helping Claude understand more complex output formats. So if you ever need to generate a JSON object that is rather complex in nature, you might provide a sample input and an example output and show that kind of complex JSON structure to Claude. And now it will have a better idea of the exact structure of output that it is going for. Providing examples is especially effective whenever you are doing prompt evals, as we currently are. Remember, whenever you run a prompt eval using our little framework inside the notebook, it creates an HTML file inside the same directory. So we can hunt through this file until we find a perfect 10, or hopefully just a test case with a rather high score. If I scroll through, I will find a 10 right here. Now, you might not have any 10s inside of your output. If you don't, that's totally fine. Just try to find the record with the highest score. So this is an example of where we had some input and output that was gauged to be pretty much as good as we're going to get by our model grader. So we might decide to provide this as an example inside of our prompt, and hopefully that will guide Claude to producing output that looks like this a little bit more often. Let's try this out. I'm going to copy this input right here, go back over to my prompt. I'm going to scroll underneath the guidelines section, and I'm going to explicitly tell Claude that I'm about to provide it an example that's going to contain a sample input and an ideal output. So I'll say here is an example with a sample input and an ideal output. I'll then put in my sample input inside of XML tags and a ideal output. And inside those tags, I'm going to go back over and copy paste the output from right here. I'll then paste it in like so and fix some indentation. Before we rerun our eval, there's one last thing I want to show you. This last step is completely optional, but I personally have had great success with it. It's often very beneficial to help Claude understand exactly why this is ideal output. If we go back over to our report, remember we have this last column over here that explains exactly why the grader thought that this was some ideal output. So we can copy just the kind of first half of some message over here where it says or lists out why this is a good response. Take that back over, and then underneath the closing ideal output tag, we could paste in that reasoning. And then maybe update the grammar just a little bit to say, this example meal plan is well structured, blah, blah, blah. So now Claude has a better idea of exactly why this is considered to be ideal output. And it's going to better reinforce the idea that Claude needs to return a well-structured output that contains some detailed information on the food choices and quantities, and most importantly, matches the athlete's goals and restrictions. Okay, so let's now run that cell and then rerun our eval and see how we are doing. So I'm going to rerun this, and are we going to go up or down? We end up going up just a little bit to 7.96. Well, let's wrap things up. As a reminder, this technique is often referred to as one-shot or multi-shot prompting. One-shot is where you provide a single example. Multi-shot is where you provide multiple examples. And this is a technique you're going to very often use anytime you want to make sure Claude handles corner cases, or especially when you want Claude to make sure it matches some kind of complex output format. Let's test your knowledge of prompt engineering by going through a quick exercise. Now, for this exercise, I made a new notebook called 003_exercise. You do not have to download this one. All I did was replace the task description, the prompt input spec, and then adjusted some of the extra criteria down here. So if you want to, you could manually change all the stuff in the notebook you're working out of, or alternatively, just download this 003 exercise and get caught up with exactly where I am. Your goal in this exercise is to improve an existing prompt using all the prompt engineering topics we've learned about inside this module. The dataset you're going to be working with is going to create a series of passages of text from a scholarly article. The goal of your prompt is to take in that passage of text and extract all the topics from it into a JSON array of strings. And when I say topic, I really just mean, well, what does this article talk about? So if it's an article about, say, solar panels, I would want to get back a JSON array of strings that contains solar panels inside of it, along with any other topics mentioned inside that text. The only input to the prompt is going to be a content property. So that's going to be one paragraph of text. Now, in my notebook that I have open right now, I have already executed the cell and generated a dataset. I have already put together a starter prompt for you, and right now it's a very poor prompt that can definitely be improved quite a bit. So go ahead and play around with this prompt and use some of the different techniques we have learned about. In order to evaluate your progress, go ahead and run the cell down here. I've already included a couple of extra criteria to make sure that you're kind of achieving the correct result. Remember, whenever you run the evaluation, you can always open up that report.html file and get a better understanding of what's going on. By default, with that really simple prompt, I've got a average score of 2.8. And so I'm hoping we can at least get that average score over maybe 7 or so. As usual, I would encourage you to pause the video right here and go ahead and give this exercise a shot. Otherwise, if you want to stick around, I'm going to go over a solution right away. All right, so to solve this, we know without a doubt all the work we're going to be doing is focused on this variable right here. We need to improve this prompt in some way to get back some better output. The first thing we might do here is make sure you run the evaluation at least one time to generate that output.html file. And then once you have created that file, I would encourage you to open it up and take a look at some of the reasoning on why the output is being graded so poorly. You'll notice a common theme between each of these. The real common theme right away that we can see is that, well, it doesn't like the fact that we are not returning a JSON array of strings. To solve this problem, let's make use of that technique of being simple and direct inside of our prompt. If we expect to get back a JSON array of strings that contains all the topics out of this content, well, we need to be very simple and direct with Claude and tell it exactly what we want. So I'm going to update the first line of the prompt right here, and I'll say extract key topics mentioned from a passage of text from a scholarly journal into a JSON array of strings. As simple as I can phrase it and as direct as I can possibly make it. And right away, if I rerun the prompt with the evaluation, I will see that I get up to a kind of shocking 9.5 almost immediately. So I kind of didn't really expect it to go that well because there are still some other techniques we might want to try out here. But if we take a look at the report now, I'm definitely getting back this JSON containing all the different topics mentioned, and it looks like the model grader is extremely happy with this output. Now, I don't really want to leave it here. Obviously, there are some other techniques we can add in to make sure that we get the correct kind of output. So the next technique we might add in is structuring our prompt a little bit better by using some XML tags. Before and after the content that we're going to interpolate in right here, I'm going to add in some XML tags, and I'm going to give them the name of simply text. Now, in this case, I'm choosing to call these tags text because I earlier referred to some text inside of the first line of the prompt. So now we have just a little bit more clear connection between us talking about a passage of text right here and us providing the text right here. Another improvement that we might add in is to be very specific in what we want Claude to do. So I could put in a series of steps for Claude to follow. Let's try that out. I might say, follow these steps, and then list out exactly what I want Claude to do step by step. So we might say, closely examine the provided text, identify each topic mentioned, add each topic to a JSON array, and then finally respond with the JSON array. Do not provide any other text or commentary. Now, if you wanted to also add in an example using one-shot or multi-shot prompting, absolutely feel free to do so. But we already have some pretty good scores, so I think this is probably enough. I'm going to rerun this prompt. I'll then run the evaluation again, and I end up getting a 9.5 again. So I would say this is a pretty strong prompt, and I would definitely trust it to extract a list of topics from an article. In this module, we are going to discuss tool use. Tools allow Claude to access information from the outside world. Now, understanding tool use can be a little bit challenging, so in this video, I'm going to give you a really soft introduction. We are going to walk through the entire flow of tool use and understand what it's all about. I want to first begin by giving you an example of where Claude can, unfortunately, sometimes hit its limits. Remember, by default, Claude only has access to information that it was actually trained on. So in general, it doesn't really have any information about very recent current events. As an example of this, if we had a user making use of our chatbot ask a question of something like, what's the weather in San Francisco, California right now, and sent that off to Claude, we would probably get a response back of something like, I'm sorry, but I don't have access to up-to-date weather information like that. To fix this and give the user a better response, we can make use of tools. Let me show you a diagram that's going to break down tools with really simple terminology. And then I'll show you another one that's going to give you an example of how we would solve this specific weather problem. Okay, so here's the entire flow that we're going to eventually implement when we start to make use of tools. We're going to send off an initial request to Claude. We're going to ask a question or maybe give Claude a task. And along with that, we're going to include instructions on how Claude can get some extra data from the outside world. Claude will then take a look at whatever question it was asked or whatever task it was given, and it might decide that it needs to ask for some extra data. So it'll send a response back to us where it asks for some extra data, and it's going to give us some details on exactly what information it needs. Then on our server, we are going to run a little bit of code that will go and get the information that Claude asked for, and then respond with that on a follow-up request back to Claude. Now Claude has all the information it needs, in theory, to give us a response. So it will generate a final response that will be hopefully augmented or improved by that extra data. Now I'm going to show you the same exact flow, but I'm going to customize each of these little steps for this scenario where a user asks us for some current weather in a particular location. So here's what would happen. We would send an initial query off to Claude, and it would include a prompt where the user asks about the weather. And inside of that initial request, we're going to include details on specifically how to retrieve current weather data. Claude would take a look at the prompt and decide, hey, to answer this question, I need to get some current weather data. It'd send a response back to us, where we would then run some code that would reach out to some maybe third-party weather API and actually get some live details on what the current weather is for a particular location. Once we have those details from that outside API, we would then make a follow-up request to Claude with that current weather data. And now Claude has all the information it needs. It has the original prompt along with the up-to-date weather data, so it can generate a final response and send it back to us. Now, if this entire process seems really simple, that's fantastic. And if it seems really confusing, that's totally fine as well. As I mentioned earlier, understanding tool use can be a little bit challenging. And I think one of the reasons for that is that there's a really big disconnect between the order in which things actually occur, so like this diagram you see right here, and the actual code that we write to implement this process. You see, each of these different steps needs to be implemented with some actual code that you and I write. And it turns out that the way we actually often structure our code inside of real projects doesn't quite match this flow. So we end up kind of jumping all over the place. We very often start off by first writing a tool function, and then we go up to writing out the JSON schema spec, and then we might actually handle the actual tool use part and a tool result, and then actually go back and make sure that we include the original JSON schema spec with a request. So very often we end up jumping all around as we implement this stuff, and that tends to be a big reason on why this ends up being complicated. So in the coming videos, when we start to implement tool use ourselves in a Jupyter notebook, I'm going to do my best to come back to this diagram rather frequently and make sure it's really clear what piece of the puzzle we are currently implementing. All right, so with that in mind, let's come back in the next video and we're going to start to implement our own tool use pipeline. To learn more about tools, we are going to set ourselves a little goal. This is going to be a small project that we implement inside of a Jupyter notebook. We are going to try to teach Claude how to set reminders that occur at some point in time in the future. This is going to require us to implement several different tools. And for right now, we're just going to focus on one tool at a time, but just know that we're going to eventually have to deal with multiple tools. So I want to eventually be able to send a message to Claude of something like, set a reminder for my doctor's appointment. It's a week from Thursday. And I want Claude to respond with something like, okay, I will remind you at that point in time. When you first look at this task, you might think it seems really easy, but it turns out that there are actually several different challenges that we're going to need to tackle, and we're going to solve all of them through the use of tools. So in particular, Claude does know the current date. In other words, if you open up a prompt right now, you could ask it what the current date is, and it will give you an exactly correct answer. However, Claude doesn't always know the exact time of day. So if we were to ask Claude to do something like set a reminder for 24 hours from now, expecting it to be exactly 24 hours, Claude doesn't really know what 24 hours from now actually is because it doesn't know the current time. Secondly, Claude does not always perfectly handle time-based addition. So if I were to ask it, what is 379 days from January 13th, 1973, Claude will very often give you the correct answer, but sometimes it will get that addition incorrect. And finally, Claude just doesn't know what it means to set a reminder. It has no concept of it. It does know conceptually what setting a reminder is, but there's no mechanism inside of Claude whatsoever for setting reminders in the future. To solve each of these issues, we are going to make a dedicated tool. So we have 3 issues right here. We are going to make 3 separate tools, one at a time. Here's what each tool is going to do. We're going to have a very simple tool that we're going to get started with. It's going to help us understand what tool calling is all about. Its only job is to get the current date time. So that means the current date plus the time. The second tool we will make will add a duration to a date time. So this will allow us to say something like, take the current date and add 20 days to it, and what would the resulting day be? And then finally, we will make a reminder setting tool as well. The first tool that we are going to create and test is the get current date time tool. There are several different steps that go into making one of these tools, and I've listed them all out at the very top of this diagram. So we're on step 1 right now, writing out a tool function. If we go back over to this diagram we had looked at previously, we are currently in this step over here, where we are going to write out a function that will eventually be called on our server at some point in time. So for these tool functions, we're going to write out a plain Python function, and it will be called automatically at some point in time. There are several best practices around these functions that we will go into very shortly. But for right now, let's go over to our Jupyter notebook and get started on this get current date time function. And again, it's going to be really easy for us to put together. All right, so back over here, I am inside of a new notebook, and I've called it 001 Tools. It has a lot of very familiar code. I would really recommend you download this copy or the kind of the starter version of this notebook regardless, because I have added in a rather long function down here just to save us a whole lot of time. It's called add duration to date. This is going to be one of our critical functions later on. But as you can see, it has a lot of code for it, so I did not want you to have to write it all out yourself. So make sure you download this kind of starter version of the notebook. I'm going to add in a new cell, and we are going to immediately start to implement our tool function. So this is a function that will be called automatically at some point in time. I'm going to call it get current date time. I'm going to take in an argument of date format, and I will give this a default value of %, capital Y, %, lowercase m, %d, and then just a little bit more, %, capital H, %, capital M, %, S. Then inside of here, I'm going to return datetime.now, strf time, and I will put in that date format string. I'm then going to test this out very quickly by calling get current date time. And hey, sure enough, there we go. There is my date time. Whenever we write out these tool functions, there are a couple of best practices I really recommend you follow. First off, and by far the most important, I really recommend you use well-named and descriptive arguments. You're going to see later on that this step is really important. Secondly, if possible, validate the inputs that are passed into the function and raise an error if they fail validation. So in the case of this get weather example on the right-hand side, if we get a empty location, so just an empty string, well, that's probably a mistake. We can't really get weather for a unknown location, so we might want to immediately raise an error and just say, sorry, but the location can't be empty. In our particular case with the get current date time function, we could just validate the date format input to make sure that it is a string, but beyond that, technically we could put in any string here and everything's going to work out okay, and there are scenarios where you would want to allow strings like this. So I would be a little bit hesitant to try to strictly validate the input string in this particular case. Well, we've got our first tool function put together. Let's come back in just a moment and understand how to write out a JSON schema spec to describe this tool function. Once we have created our tool function, we're going to move on to the next step, which is to write a JSON schema. This JSON schema is going to be used to describe our tool function, or more specifically, the arguments that the function expects to receive. Now, the JSON schema is going to eventually be sent in our request off to Claude, and it's going to help Claude understand how to make use of the function we just wrote. Now, I know that when you look at all this configuration on the right-hand side, it looks really intimidating. And this probably is one of the most challenging aspects in general of tool use, because this just looks like a huge blob of configuration that you have to write out. So let me give you a couple of notes here to help you understand what this is really doing for us. The first thing to understand is that JSON schema is not just specific to tool use or LLMs. In other words, this was not something that was just invented yesterday just to facilitate tool use. JSON schema has been around for a very long time. It is a general purpose technique for data validation. There are two main areas to this big configuration object that I want to draw your attention to. At the top, there's the name and the description. We're going to come back to those in just a moment. For right now, I think the more confusing part is this JSON object right here. So I want to focus on this thing for just a little bit and make sure it's super clear how you put this thing together. The easiest way to understand this is to go through an example with a rather complex function. So let's imagine that we need to make one of these JSON schema specs for a function like this, process data. Now, process data takes in 4 different arguments: IDs, profile, primary ID, and value. And based upon the example call, each one is going to take in a different type of data. So to turn this into a JSON schema that we can use back inside of this larger structure, so basically whatever we want to put right here, here's exactly what we're going to do. I'm going to show you the simplest way of doing this. Step 1, we're going to take our function, and specifically the arguments, and we're going to write out a dictionary of all the keyword arguments with sample data for each one. So in this case, process data is going to take in IDs, profile, primary ID, and value. So I'm going to make a dictionary with exactly those keys, and I will provide some expected sample data for each of those different arguments. So IDs would presumably be listed numbers. I have a dictionary here, a string, and a number. In step 2, we're going to take that dictionary and convert it to JSON. Now, I know it already looks like JSON, but there's one very important distinction. This is a capital T true, which is used in Python. In JSON, it would be a lowercase t. So that's really the only conversion step you have to do, but it is important for the next step. So in step 3, go off to Google. No, I'm not kidding here. Go off to Google and search for JSON to JSON schema converter. There's a ton of different tools out there like this. These different tools allow you to paste in some JSON data, and based upon the values in that data, it will automatically generate a schema for you. So I'm going to paste in that dictionary that we just created and turned into JSON. Then I'm going to convert this thing, and now I've got exactly what I need to put into my tool schema. So this is the exact object I would want to use right here. With one exception, we do not need that $ schema statement. So I would delete that right there. Finally, step 4, we're going to take that output and we're going to add a description to each property. So inside of this properties object right here, I've got a property of ID, primary ID, and the other 2 that I'm just not listing on this particular diagram. For each of these, I'm going to add in a description to describe exactly what this property or this argument into the function is supposed to do. So for example, if we go back to the example of the get weather spec that I had over here, you'll notice that the JSON schema, which is that section right there, the function get weather is expected to receive a location argument. It has to be a string. And then we provide a very descriptive or very detailed description of exactly what this argument does and exactly how it fits into the overall tool use. When you are writing out these individual property descriptions and the overall description for the tool itself, there's a couple of best practices that you really should follow. First, in the overall tool description at the very top, be sure to explain exactly what the tool does, when Claude should use it, and what kind of data it returns. We want our tool descriptions to be 3 to 4 sentences long, ideally. If you can't think of enough text to write out, remember, you can always just take your function, so for example this right here, copy paste it directly into Claude, and ask it to write out a description for each of the arguments to the function for you. Now if you want to, go ahead and try to write out your own JSON schema for the getCurrentDateTime function. If you don't want to put this together, that's totally fine. I've already written out a schema for you in the cell right above. So if you expand that one and scroll down a little bit, you will see that there is a getCurrentDateTime schema. And if you want to, take a look at it to get a better idea of how I structure this thing and the description of the overall tool and some of the different arguments. All right, so that is our second step. We wrote out a JSON schema. So now the next thing we need to do is call Claude and include the schema with it, so Claude understands that this tool is available for use. Now that we have authored our JSON schema that describes how to call our tool, we're going to make a request off to Claude and include that JSON schema spec with the request. Let me show you how we do that. Back inside my notebook, I'm going to open up the cell that has our helper function of chat. Here it is right here. I'm going to add in another keyword argument to this function of tools, and I'll default it to be a value of none. I'm then going to add in another if statement very similar to the existing one for system. So I'll say if tools, then I want to add in an additional parameter of tool config. And that's going to be a dictionary with a key of tools. I'm going to assign the list of tools that we're going to provide to it. And then I'm going to put in another key inside of here of tool choice. And that's going to be a nested dictionary with auto set to an empty dictionary, like so. All right, so let me tell you first what this little option is all about, because it's just a little side topic that's going to eventually become really, really useful when you start developing your own tools and specifically want to test them. So a quick diagram over here, right here. All right, so that extra little dictionary is going to control how the model makes use of these tools. The option that we put in of auto is the default setting, and it just means, hey, Claude, if you want to use a tool, feel free to do so. So we are delegating the choice of whether or not to use a tool to Claude itself. The other two options we could put in here is a string of any. So that key right there goes from auto to any. This will force Claude to use a tool, and Claude can decide which one it wants to use. The other option we could put in is a nested dictionary inside there with tool of name and then the name of a tool that you want to force Claude to actually call. Option number 3 is really useful anytime you're doing testing. So if you want to specifically force Claude to call some specific tool, you'll probably want to use this configuration option. All right, so now we're going to leave the default setting here of auto. Technically, because it is a default, we don't have to provide it at all, but I'm going to leave it in there just as a reminder to us that this is an option that we can change if we want to. Now that we have updated the chat function, I'm going to rerun the cell, and let's test this thing out at the very bottom of our notebook. At the bottom, I'm going to add a new code cell. I'm going to create a list of messages. I will add a user message to it of what time is it. I'll then call chat with messages. And for right now, I'm just going to run this as is without including any tools whatsoever. And so if I run this, I'm going to get back a message from Claude that says something like, I'm sorry, but I don't know the current time. So now let's try adding in an extra tool here and tell Claude that there's some tool it can call in order to figure out what the current time is. To do so, we'll add on the tools keyword argument. That's going to be a list, and inside there, we'll provide the name of our get current date time schema. So I will add in here get current date time schema. I'm going to rerun this. And now let's take a look at what response we get back. Now it says, I can check the current date time for you. Let me retrieve that information. Well, what's really going on here? Let's go back up to the chat function. We're going to add in one additional line of code temporarily, and this is going to give us a better idea of what's going on behind the scenes. So I will expand up here again. I will find the chat function. And then after we get the response back, I'm going to print the response out. I'll make sure I rerun that cell and then go back down and try running this again. I would encourage you to take a look at this response, but I'll show you a diagram to help you understand what is different about it compared to other responses we have gotten in the past. Inside that response, you might notice that there is a key of stop reason. That key has always been there in all the responses that we've gotten previously, but now it has a lot more special meaning to us. Stop reason can be any of a number of different strings. These strings, which I've shown on the left-hand side of the table, tells us exactly why the model has stopped producing output. Whenever we are making use of tools, if the model decides to use a tool, it will have a stop reason of tool_use. That is an immediate and very clear sign to you and I as developers that the model has decided that it needs to call a tool. The next thing you might notice is the structure of the assistant message itself. So in the past, we would always get back an assistant message, and that assistant message, remember, has a content list inside of it. In the past, we've always had one single object inside of that list, and it was a text part. And we can kind of see that right here. Here's the text part. But now that we are making use of tools, we're going to get back a content list that has multiple parts inside of it. The first is a text part, and this is some helpful text provided by the model to kind of tell our user, yeah, I can help you with this, and I'm going to use some kind of tool to figure out what the current time actually is. We then get a second part, which we have not gotten previously. So now we have multiple parts here. The second part is a tool use part. So it's an actual dictionary where the key is tool use. This object right here is a message to you and I as developers saying that Claude wants to run one of the tools that we listed out inside of that tools list. In this particular case, it wants to run the get current date time tool. Now you will notice that there are 3 different keys inside this inner object. I want to very quickly clarify what each of them is doing. So the first one is the tool use ID. What this ID is used for in just a moment, so let's ignore that for just a little bit. The second key is the name. this is going to be the name of the tool that Claude wants to actually run. The exact name, or that string that is provided right there, is coming from the name inside of your JSON schema spec. So if we go back over and find where that JSON schema spec was defined, right here, I provided a name of get current date time. So it's specifically whatever you write right there that's going to show up as the name right there. Finally, the input key is going to be a dictionary containing the arguments that Claude wants you to pass into your tool function. Before we move on and actually run our tool, there's a little bit of housekeeping we need to take care of. And right now is really the best time to deal with it. So remember, we currently just received a tool use part. And now normally the next thing we would do is call a tool function that would generate a tool result part, and we would send that off to Claude. In this request right here, the expectation is very similar to all the other conversations that we've had with Claude in the past. So what I mean by that is that when we make this follow-up request right here to Claude, we are required to include the entire conversation that we've had with Claude up to this point. So that means that when we make that follow-up request, we need to send the original user message. We also need to send the assistant message that we just got. So the response that we just got, we need to include that in the follow-up request to Claude that we're going to make in a little bit when we eventually send the tool result part. We haven't discussed that last part just yet, so don't worry about that so much. My focus right now is just to say we need to make sure that we store this assistant message. Now, in the past, we have done this by just writing out something like text and then add assistant message and passed in the text like so. But now we cannot do that because remember, we have multiple parts to this message. And this text argument right here is going to be just that text and not anything about the entire tool use part. So we have to go through a little bit of a refactor here. We need to make sure that whenever we call chat, we get a list of all these message parts. And then when we add in the assistant message, we need to make sure that we can pass in not just a piece of text as we've done previously, but also support passing in a list of parts. So again, just a little bit of a refactor. Now let me show you how we're going to do this. To get started, I'm going to first go back up to our chat function. I will delete the response print statement right there. I'm then going to get the text out of the very first part, which we had done previously. And then I'm also going to extract all the different parts of the message, which is going to be everything up to content. And then I'm going to use multiple return to return both the text and the list of parts. So now we get back, whenever we call chat, a bit of text and a list of parts. So now we need to update our add user and add assistant messages because we need to support passing in either text or a list of parts. So let's refactor both these functions to be a little bit more flexible and allow them to receive either type. I'm going to first begin by renaming text to content, which is a little bit better descriptor. I'll then add in an if statement here. I'll say if is instance content string. So we're going to say if we just passed in a string, then I want to do the same thing that I did previously, where I make a new message. So the overall message is this entire thing right here. I add in a single content part that is just a text part. And I will update text right there to be content. And I'll add in an else case. And in this scenario, if content is not a string, I'm going to assume that it is a list of parts that I just want to throw in right here directly. So I'll put in content without any square brackets around it. And now we're going to repeat this process for the add assistant message function as well. So we'll change text to content, say if is instance content string. So in that scenario, we want to add in just the single text part. Otherwise, I'm going to put in content. And that's it. Now I'm going to, as usual, rerun this cell. And now let's test out these changes that we have made. So we will know that everything is working if we can do something kind of like what we have right here, just with a quick code update or two. And then if we print out our messages list, we should end up seeing pretty much exactly that part right there. We should see our original user message and the assistant message that has a text part and a tool use part. So let's test this out. Here's the updates we need to make. First, I'm going to get back text and parts when we call chat now. Then I'm going to rerun that cell. And on the next cell down, I will call add assistant message with messages and parts. And then I will print out messages. And now we can see, yes, it did in fact work. So now we have, firstly, our user message. So that was the original one we added right there. And then our second one that we added right there is the assistant message. It has a list of message parts with a text part right there and our tool use part right there. So now we have successfully updated these functions to manage our conversation history, even when our messages have multiple parts. So definitely a very solid change, and one that you definitely would need to implement on your own if you're ever implementing tool use on your own applications. All right, so now we have this great refactor done, and we have our tool use part, which tells us which tool we are going to need to run. We'll move on to our next step, which is to actually run a tool. On to the next step, where we are going to actually run a tool using a tool use part that was sent back to us. So in other words, when we get that initial response back that contains a list of parts, we're going to find all the different tool use parts. And based upon this criteria right here, we're going to run one of our different tool functions. Now there is just one little gotcha here that I want you to be aware of. You see, whenever Claude decides to respond back to us and send back a tool use part, there is a potential that Claude might decide to use multiple tools in parallel. So we need to write our code to be a little bit defensive here and assume that when Claude sends us back this tool use part, there might be more than one. So when we get that assistant message back, we might have a leading text part, and then there might be maybe one or two or potentially even more tool use parts in there as well. So again, we just want to make sure that we write code to handle this case as well. All right, let's go back over to our Jupyter notebook. We're going to write out some code that's going to extract all these different tool use parts and then run the appropriate tool for each one. Okay, so back over here, I'm going to make a new cell, and I'll write out a new function called run tools, and that's going to receive all the different parts that we get back from a chat request. So remember, whenever we call chat now, we're going to get back text and parts. All we have to do is take parts right there and feed it into this function. Then inside this function, we're going to iterate over that parts list and find all the different tool use requests inside there. So in other words, we want to extract this part and not extract the text part. To do so, I will say tool requests is going to be a comprehension with part for part in parts if tool use in part. So in other words, if the part object or that dictionary has the key tool use inside of it, that is a part that we care about. So we are grabbing all the objects that have that key right there specifically. Then after that, I'm going to make a list that we're going to build up over time of all the different results. We'll use that in a little bit. And then I will start to iterate over all these different tool requests. For tool request in tool requests, I'm going to extract out the tool use ID, the name, and the input to send into the tool. So I will get tool use ID from tool request, tool use ID. And to save a little time, I'm going to paste that down twice. The next one, I'm going to extract out the tool name, then update the key on the right-hand side. It's not tool name. That's not the key that we need to extract. So it's actually name. That's what the key is right there that we need to get out. So I will make sure I get name. And then finally, the last one we care about is the input. So tool input, and the key is simply input. Now, just to make sure that we are going down the right path, I'm going to add in a little print statement here really quickly. So I'm going to print out, I need to run this given tool name with these given arguments. Then I'm going to test this by calling down here run tools with parts. I'll make sure I rerun the cell above to get a list of parts, and then test this out. And I get, all right, I need to run the tool, get current date time, and here are the arguments that I want to pass into it. Well, that definitely looks good. Next up, I'm going to make a helper function, which is going to be responsible for actually running the tool. So right above run tools, I'm going to make a separate function called run tool. This will take in the name of the tool to run and the arguments to it as well. And then inside of here, I'll put in a very simple series of if statements, many different ways we can do this, but we'll keep it simple. I'll say if toolName is equal to our get current date time function. So if that is the function that Claude wants to run, then I will return get current date time, and I will pass in tool input with ** tool input. So little gotcha here, just something to be aware of. You're always going to get back an object containing all the different arguments that Claude wants to shove into your function. So you're going to take that dictionary and you're going to splat it in with ** into your tool function, as I'm showing right here. I'm going to also handle the case where Claude might mistakenly try to ask for a tool that doesn't exist. Now, Claude is probably not going to make a mistake here. It's actually much more likely that you are going to make a typo somewhere. For example, I might leave off the word time on here and put in just get current date. And this name needs to match up with our actual tool schema. So entirely possible that we're going to make a typo ourselves. And to handle that case, I'm just going to put in an else here. So if I fall into the else case and I don't find the tool to run, I will raise an exception with unknown tool name and then print out the tool name and make sure that I make that a F string. Okay, so now down here inside of our run tools function, I will replace the print statement and I'll say tool output is run tool with tool name and the input to it. And now once again, let's try to run the cell. Oh, we need to do a print first. Let's make sure we actually see the output. There we go. So now I'll run that. And all right, that looks good. So we got the current time. Right now, in real life for me, it is 12:24 roughly, in fact. So at this point, we have achieved this step right here. We have written out some code to call a tool function. So now we need to take the result of that function, whatever the output was, in our case, the current time, and we need to send it back to Claude inside of something called a tool result part. So let me show you how we create these tool result parts. Okay, the tool result part looks a little bit like the tool use parts we looked at previously. So these are dictionaries. They're going to have a tool result key and inside a couple of different properties. The first is the tool use ID, and I'm going to tell you about that in just a moment. The second is content. That's going to be simply the output that we got from running our tool, and we're going to serialize it as a string, just in case our tool function ended up returning something like a list or a dictionary. So we're going to make sure we turn that into a string and put it right there. Then we're going to also provide a status flag of either success or error. Now, it really is important to do error handling here because Claude is rather intelligent when it comes to calling tools. If Claude tries to call a tool and we end up returning an error to it, Claude might try to figure out what's going wrong and maybe it'll adjust the argument that it is providing and eventually figure out how to correctly use your tool. So we do want to make sure that we put in some reasonable error handling here and add in that status of either success or error. So now let me very briefly describe what this tool use ID is all about, because we saw this previously when we were looking at the tool use parts. So remember, these are kind of like our inputs. They had a tool use ID, and now the outputs, the tool result, have an ID as well. So here's what they are all about. Remember what I told you at the start of this video? Claude can potentially give us multiple tool use requests inside of a single message. So let's imagine a scenario in which we define a tool called calculator. Claude might decide that it needs to run that calculator twice in parallel to execute two different operations. Maybe one is evaluating 10 plus 10, and the second is 30 plus 30. So when we receive these two tool use requests, we're going to eventually have to send back two tool results. Now in this scenario, it would be kind of hard for Claude to figure out which of these two results match up with the two original requests. And that's where the ID comes in. So we need to make sure that the result of this operation of 10 plus 10, which might have an ID of AB3, has that same ID in the output as well with the appropriate output of, in this case, 20. And then the result of 30 plus 30 with an ID of PO9 might be right here, PO9, with an output of 60. So in short, the entire goal of this tool use ID key inside of here is just to help Claude identify which result is which. All right, let's go back over to our notebook. And for every tool use part we got, we are going to generate one of these different tool request parts that will eventually be sent back over to Claude. Back inside of my notebook, I'm going to remove the print statement and make a tool result part. That will be a dictionary that has a tool result key. And inside of here, we will add in tool use ID, content. That will be a list with a dictionary in there with a text of JSON dump string with the tool output. And I need to make sure I import JSON really quickly, which I will do at the top of this cell. And then finally, we need our status flag of success. Now, this is assuming that everything always goes perfectly, but it's entirely possible that one of our tool functions might fail in some way. So to really handle things correctly, we should wrap this block right here inside of a try except statement. So I'll put in a try except with an exception as E. And then if something does go wrong, if we end up down here, we're not just going to give up. We're going to send back a tool result to Claude that tells it that something went wrong when we tried to run the request. So I'm going to copy this right here, paste it right here. I'm going to change the status to error. And for text right here, I will remove the JSON dump string and replace it with a F string with error. And then I will print out whatever the error message was to kind of help Claude understand that, yes, something went wrong, and here was the error message. Now that we have made our tool result parts, either the success or error case, we're going to take those parts and add them into our big list of tool result parts. So down here, underneath the except statement, I will add a tool result parts, append tool result part. And then finally, outside of the for loop, I lost my parenthesis, there we go. Outside of the for loop, I'm going to return tool result parts. Okay, so now let's run this out, do a quick test, and see if we are generating a correct list of tool results. So I'm going to run it, and there we go. I've got my tool results with a tool use ID that maps back to the original tool use block, the content, so that's the output from running the tool, and the status in this case was success. So that looks good. Now, on to the last step. All we really have to do from here is take all these different tool result parts and send them off to Claude again, which is by far the easiest part. So we're almost at the end. On to the very last step. We are going to take that list of tool result parts that we just generated, add them all into a user message, and then take the entire conversation history and send it all off to Claude. So let's go back over to our notebooks and test this out really quickly. First, I'm going to scroll up to the cell right above. Now, right up here, we called chat and we got our list of parts, but we never actually added them into our message history. So in other words, right now, we do not have this part of the conversation inside of our list of messages. So I'm going to fix that really quickly. I will add in a add assistant message and put in the big list of parts. I'm then going to rerun that cell. Okay. Next up, I'm going to go down. In the cell that we were just working in a moment ago, we had a call to run tools. Now, it's totally fine to leave that in there, but I only have it in there for debug purposes. So I'm going to remove that call just to clean up my code in here. And then underneath, I'm going to take a look at messages and just verify that I do, in fact, have the original user message along with the follow-up assistant that has the tool use request. And there it is right there. So that definitely looks good. Next up, I'm going to add in a new code cell and call add user message. And to my list of messages, I'm going to pass in run tools with all the parts we got out of our initial response. So this is where we are going to run all those individual tools, and it's going to generate our list of tool result parts, and we're going to add those all into our conversation history inside of a user message. So once again, I'm going to run the cell and print out messages. So now I should see I've got my user, the assistant, and user. And inside the assistant, I have my tool use requests. And inside the user message, I have my tool result responses. So now the very last thing we have to do is just take this list of messages and send it all off to Claude. So I'm going to add one more cell down here. And I'll get text and parts from calling chat with messages. And when we do this follow-up, we do have to include all the original tool schemas as well. If we don't include those tool schemas, Claude will end up being really confused and say, hey, wait a minute, I tried to call some tool named getCurrentDateTime, but where's the actual definition for that? So we need to make sure that we include that same list of schemas. So in other words, this right here. I'm going to copy that and just make sure that I add it in. And then finally, I will print out text and run this, and we'll see what we get. And hey, it worked. So I was able to print out the current date and time. Now, as we said at the very start of this series of videos, well, Claude already knows the current date, but it doesn't know the time. And so this is evidence that our tool is working absolutely correctly. We are 100% getting our time in there. The next thing I want to show you is how to have a long-running conversation that includes tool use. You'll notice that I collapsed the cell that has our run tools implementation just to make things a little bit easier to read. And as we saw at the end of the last video, right now everything works just fine. But I want you to notice what happens if I change the original query right here. And if I instead say something like, what is 1 plus 1? So if I run that, I will get back a response really quickly. I'll then add in the result of running tools to messages and print out messages, and let's see what happens. So in this scenario, we got back a response from the assistant that did not include any tool use requests. So we kind of erroneously added in this completely empty message right here. In order to have a long-running conversation that includes tools, what we should really do is take a look at the stop reason that comes back inside a response. Remember, whenever we get a response back from Claude, it's going to include a stop reason. We should really consider the stop reason in deciding whether or not we need to process any tool use requests. So let's do a little refactor here. Back inside of my notebook, I'm going to first do a little bit of code cleanup. I'm going to find the example conversation we had right here. I'm going to delete that cell. I'm going to delete this example one right here and this one right here. Next up, I'm going to go up to the very top where we have our helper functions defined. Inside of here, we can find the chat function. Now remember, we did a refactor here just a little bit ago to always return text in parts. But now I also want to return the stop reason. And we could add in another multiple return element right here. So I could just put in stop reason if we wanted to, but that's starting to get a little bit challenging to work with. So I'm going to change the return structure of this chat function just a little bit. First, I'm going to delete text right there. I'm still going to keep parts. And now I'm going to return a dictionary that is going to have the list of parts. I'm going to return a stop reason, which will come from response stop reason with a capital R. And then I will still return text. And I'm going to do a little fix here on text at the same time. You see what we had previously, we always tried to access the first part of a message, and we always assumed it was a text part. That's not necessarily always going to be true. So to fix things up just a little bit, I'm going to scan through the list of parts. I'm going to find all the text parts and just join all the text together. So I'll put in a new line, and I'm going to join on a comprehension with P text for P in parts if text in P, like so. All right, so now we are getting a list of parts, we got the text, and our stop reason. We could at this point kind of just return the entire response object, but doing this pre-processing is just kind of a nice little thing to add in. Now I'm going to rerun that cell, and now let me show you how we are going to use that improved chat function. I'm going to add a new code block here at the bottom. And inside of here, we are going to make a new function that's going to handle a multi-turn conversation for us that involves tool use. So I'm going to make a new function called runConversation. It's going to take in a list of messages. And inside of here, I'll do a while true, and I'll say result will come from calling chat with the list of messages and my list of tools. Right now, we only have one tool schema, which is get current date time schema. Then I'm going to add assistant message to messages with result parts. So that's where we are taking all those tool use parts and potentially text parts and adding them into our message history as an assistant message. I'm then going to print out whatever result text we got back, just so we can kind of monitor the conversation. if the results stop reason is not equal to tool use, then I'm going to break out of the while loop. So in other words, if we're not asking for a tool, that means we must have hit some other reason to stop the conversation, and we don't need to continue inside this while loop anymore. Otherwise, if we continue, that means that we must have a need to run some tools. So I'm going to get my tool result parts by calling run tools and pass in those parts and add that as a user message to messages. And that's it. So now whenever we run this function, we'll pass in a list of messages. We're going to get back a result. If we have need of calling any tools, we will do so and continue inside of the while loop again until we finally get a response back that does not ask us to do any kind of tool use. At the very bottom here, outside the while loop, I will return messages. So now I'm going to run this and let's do a test. Down here, I'll ask, oh, we need to make our list of messages first, my mistake. I'll add a user message of what time is it and call run conversation with the messages. So now let's test this and see how we're doing. And we should see the conversation kind of progress as Claude figures out what is going on. Okay, so there we go. We've got first, I can help you figure out the current time. Let me use a tool to figure out the current time for you. I then get the current time, and then I see my entire log of messages right here. And you can absolutely go through this and just verify that we have the correct ordering of messages. We've got our original user, we've got the tool use request, we've got the tool result being sent back to Claude, and then a final assistant message coming back that does not ask for any tools. So the nice thing about this approach is it should very easily also support questions that don't require tool use at all. So if I ask, what is 1 + 1? We should just about immediately see a response back. And yes, there we go. All right, so this is excellent. The last thing we really have to do to finish up this section is go through adding in multiple tools, because right now we just have one, just adds in the current time, not super useful. So we're going to add in those last little pieces in just a moment. You might recall that the original goal of this project was to add in 3 separate tools, and right now we have only done one, just the get current date time. So now in this video, we're going to add in those 2 remaining tools, add duration to date time, and set a reminder. Now I have already provided implementations of these other 2 functions for you, along with JSON schema specs, just to save us a lot of time with a lot of typing that we would need. So let's take a look at how we would wire up these additional functions along with their accompanying JSON schema specs. Now, as a reminder, I've already got these implemented inside of one of the earlier code cells. So right here is add duration to date time. And then if you scroll down a little bit, there is set reminder. All it does is print out the timestamp and some content. So there's not an actual reminder system here, but you can kind of imagine a couple of different ways in which we might implement that. And then underneath that, the existing schema, here is the add duration to date time schema. And then finally, the set reminder schema. So again, all we really have to do is touch a couple of places to add in these schemas and wire the actual tool functions up to our run tools function. So let's get to it. Step 1, I'm going to find the run conversation function. Here it is right here. And I'm going to add in those 2 additional schema that we just saw. So I have add duration to date time schema and set reminder schema. Then in the cell right above it, which is where we have all the tool running code, I will find the run tool function, and we need to add in 2 additional cases to this if statement to handle the case where Claude asked to use those 2 additional functions that we were just looking at. So one will be elif tool name is set reminder, and if that's the case, then I'm going to return a call to set reminder. And then elif tool name, add duration to date time. And if that's the case, we will call the appropriate function. And that should be it. So now I'm going to make sure I rerun this cell. I will scroll down. I'll make sure I rerun run conversation. And now we should be able to test out the entire process of setting a reminder. So I'm going to say, set a reminder to go to the doctor. The appointment is in 100 days. And run it. Now, I might run into a rate limit here rather quickly because at present I have a rather low service quota, but I should at least be able to see a couple of steps here. Notice how right away Claude is giving us a great plan of what it needs to do. So it's going to try to get today's date, and that kind of like happens in between these two messages. We don't see it printed, but it does happen. Then Claude says, I need to add 100 days. So it's going to use the add duration to date time. And then finally, it calls the set reminder function as well. And so we see correctly right here, setting the following reminder for 100 days from my current date, go to the doctor appointment. And that's it. So as you can see, once we write out all that kind of base code for implementing tool use, adding additional tools is really, really easy and straightforward. It's just that first little bit is a little bit challenging, and I hope you didn't lose your patience with me earlier on inside this module when we had to go over all that different message and part handling stuff. In this video, we're going to take a look at how we can parallelize tool calls by implementing something called a batch tool. Now, I first want to begin by reminding you something I told you about earlier on inside this module. Whenever Claude sends us back some tool use parts inside of a message, so essentially tool requests, there can potentially be more than one tool use part inside of one single message. So take this example I have on the right-hand side really quickly. If I sent in an initial query of something like, what is March 12th plus 50 days? Also, what is March 12th plus 100 days? Then Claude, in theory, could send us back two separate tool use parts inside of one single message. The first one might try to calculate March 12th plus 50 days, and the second one, March 12th plus 100. These are two operations or two tool calls that are absolutely parallelizable. They can be executed at the same time without any issue whatsoever. Now, Claude sometimes will try to do this in parallel, but it turns out that some versions of Claude don't try to call tools in parallel quite as much as you might wish. So there's a way that we can kind of trick Claude, and that is by implementing another tool called the batch tool. This is another tool that will be implemented in the exact same way as the others. That means that we still have to write out a tool spec, and we also have to make some kind of function to handle whenever that tool gets called. Now, the easiest way to understand the batch tool is to just walk through the implementation, so let's do that right away. The first thing I want to do is show you what happens if we put in that exact query that I just wrote out inside of that diagram. So what happens if we put in that March 12th plus 50 and plus 100? If I run this, I sometimes might see two parallel calls, but almost always I'm going to see two separate calls. So when I get some output back, if I scroll down a little bit and look at the message log, I will see, in fact, that I've got role of assistant right here. So this contains one tool use request where it put in March 12th plus 50 days. I then sent back a tool result. And then right underneath that is a separate second call for the same tool, this time with 100 days. So very clear that Claude did not try to parallelize these calls, even though it absolutely could. All right, so now that we've seen that, yeah, it doesn't always work quite as expected, let's take a look at how we implement that batch tool. So first thing we would need is a spec. Once again, I have provided a spec for you inside of an earlier code cell. So if you scroll way up to that code cell that starts off with the date time imports, expand that thing, and then go all the way down to the bottom. And here's the spec for the batch tool. Again, I'm providing these for you because it would just be a ton of typing if we were to walk through it together. So this tool is super simple in nature. It just tells Claude that it can run other tool calls simultaneously. And the input arguments to it is a list called invocations. Inside this list, there will be a variety of different objects, and each object is going to have the name of some other tool to invoke and the arguments to pass to it. So we need to take each of these different invocation objects, we need to loop through it, we need to find each of the listed tools and call each one with the provided arguments. One other thing to notice here, the arguments are encoded as a JSON string, so we will have to do a little bit of JSON parsing as well. Once we call each of these different tools, we'll then assemble all the results and pass it back as though it were a single call to a single tool called the batch tool. So let me show you how we implement that. All right, so to get started, I'm going to go to the very bottom of the notebook once again and scroll up a little bit and find where we put together all the run tools code. At the top of the cell, I'm going to find the run tool function, and I'm going to add in another case here. I'll say if tool name is batch tool, then I want to return the result of calling run batch, and I'm going to pass in the tool input. And this time I'm not going to use the splat, so I'm not going to put in the star star. I'm just going to pass in the tool input directly. I'm then going to define this new run batch function right above run tool. And this will receive that tool input argument. Then inside of here, we're going to loop over all the different invocations. So for invocation in tool input, invocations. Now remember, invocation, we just saw the structure of this object, or what this thing should really be inside of our tool spec. So inside of there, we should have a tool name, which will be the name property, and some list of arguments, which should be invocation arguments. And remember what I told you just a moment ago, arguments is designated inside of that JSON spec as being a JSON encoded string. So we need to parse that with a JSON load string. So now we have everything we need to run the correct tool with the appropriate arguments. We can do so by just reusing the run tool function. So watch how we're going to do this. It's going to be surprisingly simple. We'll say tool output, and that will be run tool, and we will pass in the tool name that we want to run and the arguments for it. And then finally, we need to collect all these different tool outputs. So I'm going to make a list up here. I'll call it batch output. And I'm going to append into that. And we will add in tool name with the tool name and the output that we got from it. And then finally down here at the bottom, I will return batch output like so. Okay, so that should be it. We've now got a function to run a bunch of other tools by just delegating to the function we already had, so it was not that hard to implement. And now I'm going to rerun the cell. And let's go back down to our test function. So run conversation right here. We just need to make sure that we add in the run batch schema. So it's actually called batch tool schema, I believe. There we go. And now it's time for us to do a test. And now if we take a look at the message log output, hopefully we're going to see one single tool request. And in fact, we do. So take a look at this. It really is quite interesting. We've got the initial user message. We then have our assistant message where it asks to use a tool. And in this case, it asks to use the batch tool. And the invocations that it wants to run, so kind of the subtools, is going to be a call to add duration to date time and add duration to date time. The first one has the duration of 50, second has 100. So by just adding in this tool, we've kind of tricked Claude into calling multiple tools in parallel. So this is a technique that I highly recommend you keep in mind anytime that you need to run multiple tools at the same time. Earlier on inside this course, we spoke about how to get structured output from Claude by using some clever techniques. In particular, we discussed using a message prefill and stop sequences, along with a carefully structured prompt in order to get some JSON out of Claude. Now, this definitely worked well, and it was very easy to set up, but we can get some more reliable output by a very clever use of tools. So we're going to take a look at how we can implement structured output using tools alone, without having to worry about any message prefilling or stop sequences. Now, I anticipate one of your very first questions is going to be, why did we learn about this style of structured output when we could have just used tools all along? Well, the answer is very simple. Using tools for structured output is a lot more setup. There's a lot more complexity. So having both these abilities of getting structured data at your disposal is really valuable because in some scenarios, you might want to just make use of this prompt-based structured output. In other scenarios, you might want to make use of tools. All right, so let's take a look at how we can make use of tools to generate structured data. Now, as I just mentioned, this is an alternate method of extracting structured data, primarily JSON, out of some data source. This is more reliable than past techniques we took a look at, but again, much more complex to set up. The general idea here is that we are going to write out a JSON schema spec for a tool, whose inputs are going to be the structure of data that we are looking for. So back over here a moment ago, when we looked at this prompt, we can imagine that we were asking Claude to take a look at a financial statement and extract a balance that was an integer and a list of key insights that was going to be a list of strings. So if we wanted to approach this using tool-based structured output, we would write out a JSON schema spec where the inputs would be a balance that's going to be an integer and key insights that's going to be a list of strings. Then we're going to feed this JSON schema spec into Claude along with the financial data that we might want to get some information out of. Now at this point, let me show you a diagram of the flow because it's a lot easier to understand in diagram format. Okay, so just as before, we are going to write out a reasonable prompt for Claude. So we might say, analyze the following financial statement and then call some provided tool. Along with this prompt, with all the statement data inside of it, we will also provide that schema. So that's going to go off to Claude. Claude is going to take a look at the prompt. It's going to see the tool that is available to it, and it's going to say, fantastic. I will call this financial analysis tool, and I'll make sure that I provide arguments that match this structure right here. So Claude is then going to respond back to us with an assistant message that presumably will have just one tool use part. And it will say, I want to call the financial analysis tool, and here is the input to it. And the input will be the extracted JSON that we are looking for. So it's going to be exactly these arguments right here. Our balance, that's a number, and the key insights, that is a string. So once we get that assistant message, this part is the worst part because I honestly feel bad for Claude. We basically take that JSON data right there and we just say to Claude, hey, thanks for the data. We're out. We got what we were looking for. And we don't continue the message from beyond that point. Because at this point, we got the data we were looking for. We got those arguments. We got that extracted data. And so there's no need for us to do any follow-up in this conversation at all. We can just take the data and use it for whatever purpose we have. So that is the general idea behind using tools for generating structured data. Now, again, best way to really understand this is to take a look at an example. So I would encourage you to download another notebook here. Its name is 003 Structured Data in the current module. I've got a lot of setup code in here, some example tool schemas, and I've got a little example of a very simple data generation. So I'm asking Claude right now to write out a one-paragraph article about computer science, and I ask it to include a title and an author name. So this is some data. Now let's just imagine that this data was not generated by Claude. Let's imagine that maybe we have this article from some other source and we want to extract information from it. Maybe we want to extract specifically the title right here, the author, and then maybe some primary topics that are mentioned inside of the article. And we want to extract all this as JSON. So we could use the old technique we saw, where we write out a prompt, we do the message pre-filling and some stop sequences, and we write out the structure of JSON that we are looking for. But another way we could do this is by making use of tool-based data extraction. So let me show you how we would do that. Step one, we would write out our tool schema. Now, again, just to save us a whole bunch of time, I have already authored a tool schema for you. It's inside this tool schema section. So it's called Article Details Schema. And you can take a look at the description. But the primary part that we really care about here is the fact that we are asking for input to this kind of fake tool here of a title, an author, and a list of topics. So now that we have this tool schema, we're going to make a request to Claude. We are going to ask it to take this text right here, extract the key data, and call that tool that you just saw with all the data that has been extracted. So let me show you how we'd write out the code for that. First, I'm going to make a new list of messages. I'm going to add in a user message, and I'm going to make it a multi-line F string. There we go. And I'm going to ask Claude to analyze the article below and extract key data. Then call the article details tool. And then I'll use some XML tags and I'll put in my article text. And that's going to come from our variable up here, result text. So I'm going to assume you ran the cell. Result text should contain all the article text that was generated. So I'm going to refer to result text right there. All right, so that is our user message as a part of a brand new conversation that we are starting. So now we are going to call chat, pass in our messages, and list out the different tools we want to include. And in this case, we want to include that article details schema. Now, when Claude sees this, we really want to make sure that Claude makes use of this tool. So this would be a really good place to make use of that setting that we discussed a little bit ago, specifically the tool choice setting. Remember, by default, Claude is going to decide if it needs to use a tool or not. But if we want to, we can force Claude to make use of a specific tool by adding in something like this inside of our request parameters. So we'll put in tool choice, inside there a dictionary with tool name, and then the name of the tool to call. So this would be a perfect scenario of making use of this option, because we're going to force Claude to make use of this provided tool. Now to add in this option, I have already done a little bit of work on the chat function for us. Let me show you what I did. If we scroll up to the implementation of the chat function, here it is right here. So I added in a new keyword argument of tool_choice. And by default, it is set to auto. Then down here, you will find some code that makes use of that argument. Now, I would encourage you to read over this code closely. Essentially, the way it works is if you pass in a string of auto, it will set the appropriate auto option. If you pass in any, it will set the any option. And if you pass in as tool choice right here, the name of a specific tool, it will go to this style of input right here. So it will automatically make this little dictionary and put in your provided tool name as the name. So in short, to make use of this thing, let me show you how. Back down here at the very bottom chat call that we just added in, I'm going to put in a tool choice, and I'm going to set that to our article details tool. All right, so let's test this out. I'm going to assign the result of this to JSON result and print that thing out afterwards. I'll run this, and let's see how we do. All right, very good. There is my JSON output. Now, very quickly, if you saw a result of something like unknown or something like that, make sure that you ran the cell above that actually generates some text to use, because result text might be empty if you just open up the notebook and you did not run that cell. So now we can take a look at this output right here. So we can see that we have an input to this tool that's going to be this JSON object that has the exact properties that we were looking for. It has the author of the article, the title, and then a list of mentioned topics. And that's the entire process. So once we have this input right here, really for us, it's output, so to speak, that's all we wanted. And we're not going to do any additional follow-up with that because we have our JSON data and then we can just walk away and use it for whatever purpose we have. Without a doubt, the number one downside to making use of tools for structured data extraction is having to write and manage these really big JSON schemas. So in this video, I'm going to show you a little trick to alleviate that pain. So here's what we're going to do. We are going to make one single schema with the name of something like to.json, and then we will tell Claude that the inputs to it is going to be an object that has as many properties as Claude wants to add. Then inside of our prompt, we will write out the actual structure that we want, so the actual listing of different properties that we expect and the different types. And then we will tell Claude to call this tool and pass in some argument that follows the structure that we listed out in our prompt. Now, yet again, this is another scenario where taking a look at an example is the easiest way to understand what's going on. So let's go through a quick example. All right, so back over here, I want to again scroll up a little bit and find that section with tool schemas. Inside of here is the article detail schema, which we already used. And if you scroll down, you will find to.json schema, which has all the same properties and description as what you just saw in that diagram a moment ago. So we're going to make use of this schema as a flexible way of getting any kind of structure of data out of Claude. All right, so I will once again go down to the very bottom of the file, and we're going to start in a brand new cell. I will then make my list of messages, add a user message, and to save time, as usual, I'm going to do a little bit of copy pasting from the cell above. So I'll go just right here and take that F string, go back down, and put it right there. I'm then going to update the prompt to tell Claude to call the to.json tool. And then underneath article text, I'm going to be very clear with Claude and tell it exactly how to call that tool. So I'll say something to the effect of, when you call to JSON, pass in the following structure. And then I will list out all the different properties that we need. Now, notice we are in an F string here, so we need to use escaped curly braces, which means we just need to double them up. And then I will list out the title. And I'll put in a little comment here, so I'll say it should be a string, and this is going to be the title of the article. I'll copy that and replace it with author. And then topics will be a list of strings and say a list of topics mentioned in the article. Okay, so there is our user message. So now we are going to call Claude. We will get some flexible result, just to distinguish from our earlier result variables we declared early inside of this file. We'll call chat, pass in our messages, and then we do need to provide our list of tools. Don't forget about that. So we want to use our toJSON schema. And we want to force a tool use here. So we'll pass in a tool choice. And we want to use the tool that is named toJSON. All right, let's run this and see how we do. So I'll print out flexible result. And now once again, there's our results. So we've got our input with a title, author, and then our list of topics. And so you can see right away that life is a lot easier when we are making use of this style of tool-based extraction, because now if we need to change the structure of data coming out, all we have to do is make a very simple edit inside of this prompt. So if I also want to get maybe the number topics, about just num topics. Let's make that an integer and say number of topics mentioned. And that's all we have to do. So I'd rerun that. Once it's done, we can print out flexible result again. And now we should see number of topics listed as well. All right, so again, this is a much more easy way of specifying the exact structure of the data that you want when you are making use of tool-based extraction. The one downside here is that your results in general are not going to be quite as good as writing out a dedicated schema, but you're still going to get JSON, and it's still going to be high quality JSON. Just at some extreme levels, you might notice that you're not getting quite as nice a structure as you might expect. So if you are writing a very critical data extraction task, you might want to go with the more hard-coded structure, which we saw back over here, where you specifically list out all the different properties you expect to see inside of a schema like this. As we saw earlier on inside this module, usually you and I as developers author all the different tools that we want to pass off to Claude. But there is one tool that Claude has access to by default. This is called the text editor tool, and it is built directly into Claude. This tool gives Claude a wide variety of abilities related to just about everything you can do inside of a standard text editor. So for example, this tool gives Claude the ability to open up files or directories and read the contents. It can take a look at specific ranges of text inside of a file. It can add or replace text inside of a file. It can make new files. It can do undo, essentially everything you would do inside of a normal text editor. So this dramatically expands Claude's abilities and almost right out of the gate kind of gives Claude the ability to act as a software engineer. Now, understanding the text editor tool is just a little bit confusing, so I want to walk you through a couple of different diagrams and clarify what this tool does for you and what you and I have to do to actually make use of it inside of a project. So the first thing to understand here is that only the JSON schema part is actually built into Claude. And let me clarify what I mean by that. Remember that when we want to make use of tools, we really have to author two separate things. First, on the left-hand side, we have to write out that JSON schema spec. This gets provided off to Claude and tells Claude about some tool that it can make use of and all the different arguments that the tool requires. And then on the right-hand side, you and I had to write out a tool function implementation to pair up with that JSON schema. These were actual functions implemented inside of our codebase that would be called at some point in time when Claude wanted to use our tool. So we really had to write both sides here. We had to do both the JSON schema and the tool function implementation. So when we make use of the text editor tool, the only thing that is actually kind of provided for us or built into Claude is the JSON schema, that set of instructions that tells Claude how to make use of this tool. You and I have to provide an actual implementation to handle all of Claude's requests to use the text editor tool. that does not exist. It is something that you and I have to write out inside of our code base. So in other words, whenever Claude decides to say, maybe create a new file, and it sends back a tool use part to us that says, I want to create a new file, we have to provide an actual function that will actually make a new file somewhere on our hard drive. So using the text editor tool is not free, so to speak. It requires a little bit of effort on our side because we have to write out a couple of different functions. Now let's go over to a Jupyter notebook and we're going to demo the use of this tool and take a look at how we would write out some of these different functions. All right, so back inside my editor, I have opened up a new notebook. This one is called 005 Text Editor Tool. Inside of the first cell, I have some of our usual setup code. Now to use the text editor tool, there is just a little bit of tricky setup here. Remember, we need to eventually provide the name of some different tools that we want to allow Claude to use. In order to use the text editor tool, we must provide very specific string IDs when we make our request off to AWS Bedrock. So there are different tool names for this text editor depending upon the exact model version you are using. So if you are using Claude 3.7, you want the text editor variable to be set to exactly that string right there. If you're using Claude 3.5, then you're going to comment that line out and uncomment the other one. If you are using a newer version of Claude than the two that I am showing right here, that's totally fine. Hopefully I will be able to update this notebook for you. Otherwise, you can do a quick search in the AWS Bedrock documentation to find this new string that you should be using here. Now for me, I'm using Claude 3.7, so I'm going to comment out that one and uncomment that one like so. And then I will run the cell. In the next cell down are some of the same helper functions that we've been working with throughout this entire course. So stuff like add user message, add assistant message. I have modified the chat function just a little bit to accept in a new text editor keyword. So that's going to be the name or that ID of the text editor that we were just looking at a moment ago. If one is provided, then some extra configuration is included inside of a additional model request fields inside of the params that we're sending off to the converse method. In the next cell down, there is a class called text editor tool. This class includes all the different methods that are required to use the text editor tool. So in other words, this class provides this piece of the puzzle over here. So remember, I just told you, usually we have to write out some code to handle all of Claude's requests to actually use the text editor tool. I wrote out that code for you inside of this notebook. So there are methods inside this class to do things like, if I scroll down a little bit, view the contents of a file or a directory. There are methods inside of here to replace a string inside of a file, to create a file, and so on. So everything has already been put together for you inside of this cell. Now, without further ado, I would like to give you a demonstration of how this tool works. So I'm going to open up my folder explorer on the left-hand side. I'm going to find the directory that my current notebook is in. And then inside of that same directory, I'm going to make a new file called main.py. And inside there, I'm going to write out a very simple function. I'll say def hello, and inside there, print out hi there. I'm then going to save that file. I'll go back over to my notebook, and in the final cell down here, I'm going to add in a starting user message. Inside of that, I'm going to add a prompt of write a one-sentence description of the code in the /main.py file. I'm then going to run the cell, and let's see what kind of response we now get out of Claude. In this response, it is very clear that it successfully opened up the contents of that file and read the code that was inside of there, because it says very plainly, I open up that file, and it looks like there is a function called hello that prints the greeting hi there. Now, to really understand what's going on behind the scenes, I would encourage you to read the message log down here. So the back and forth between Claude and our notebook. Let's take a look at a diagram to better understand what is really being exchanged here. So we send off that initial prompt to Claude, asking it to write a one-sentence description of the code inside that file. Claude is then going to immediately realize that it needs to read the contents of the file. Claude is then going to respond with an assistant message that has a tool use part with this kind of structure inside of it. So it will be a dictionary that has a command of view and a path of /main.py. The code running inside of our notebook is going to automatically take that little structure right there and realize that Claude wants to view the contents of the main.py file. So the code inside of our notebook is going to use that class that I just showed you, the text editor tool class, and a specific method in there called the view method to open up that file and read its contents. Once it reads the contents, we're then going to send back a user message that includes a tool result part that looks like this. So it'll have some text that includes the exact text out of that file. That gets sent off to Claude, and now Claude has everything it needs in order to answer our original prompt, which was write a one-sentence description of the code inside that file. So Claude will then send back some follow-up assistant message like this with a single text part inside of it. Now we can very easily verify this is what happens by taking a look at the message log. So right here, there's the immediate follow-up assistant message with the tool use asking for a command of view and a path of /main.py. We then respond with the tool result part that contains the contents of that file. And then here's the final assistant message that says, based upon this file, here's what the contents does. Now, the thing that I really want to focus on here is this command structure. So what exactly is command? Well, as a part of implementing this function right here to implement everything that is required by the text editor tool, there are a series of different commands that we need to be able to respond to. So in total, there are 5 different commands that the text editor tool might send back to our application. So again, we need to write out code to handle each of these different cases. And you can very easily find the code that I wrote for that in an earlier cell here inside of process tool call requests. This contains a lot of the same code that we wrote out previously around tool use. So here's the run tools function. We wrote that previously. And then above it is the run tool function, which we also wrote out previously. So inside of here, if the tool that we want to run is the string editor or string replace editor, that's the name of the editor tool in this case, then we're going to take a look at the command that is specifically being asked for and then run the appropriate method on that class instance. So the view method or string replace or create, insert, and so on. So once again, in total, there are 5 different commands that we need to be able to respond to. View, to view the contents of a file or a directory. String replace, to replace a specific string inside of a file. Create, in order to make a file and also possibly a directory. Insert, to insert text at a specific line. And undo edit, to undo an edit that is made to a file. So now the last thing I want to do is give you an example of why the text editor tool can be really, really helpful. I'm sure by this point, you might have used a really nice code editor that might have some integrated AI functionality inside of it, where you can just ask it to maybe refactor a particular file or create a new feature inside your code base or whatever else. It turns out that we can largely replicate that feature by just making use of this text editor tool. So let me show you how. I'm going to update this prompt right here. I'm going to say in the main.py file, write out a function to calculate pi to the 5th digit, then make a test.py file to test out that function. And I'm going to run this and we'll see how Claude does. After a little bit of time, we can see a whole bunch of output right here. So this is going to walk through the entire process, everything that Claude did in order to actually implement what we just asked for. So it's going to check and see if the main.py file exists. It's then going to implement the function we asked for inside there. It's going to see if the test.py file exists. And because it did not, it's going to create that file for us and write out some code inside there to test out the pi calculation function. And then finally, it will write out a full summary of what it did. Now we can open up the newly created main.py file right here, or I should say freshly edited in this case. So here's our original hello function that we put together. Here's the function I just asked for. And then there is also the test.py function right here that was created in order to test out the function. So we got some different test cases to make sure that everything was done correctly. So once again, as you can kind of imagine, we could expand this quite a bit to really make everything that a modern code editor has, and interface directly with Claude and ask it to make modifications to our code base. In this module, we are going to discuss a tremendous amount about a technique referred to as retrieval augmented generation, or RAG for short. In this video in particular, I want to give you a really solid idea of what RAG is all about. To help you understand RAG, we're going to walk through a very quick example. So I want you to imagine that you have a very large financial document, like the one seen on the right-hand side. There might be a tremendous amount of text in this. It might have anywhere from, who knows, 100 to 1,000 pages. And we might want to ask Claude very specific questions about very specific areas of the document. For example, we might want to ask a question like, what risk factors does this company have? Now, presumably, this document might have some relevant information inside of it. So we need to solve a very fundamental issue here. How do we get some information out of this document and into Claude so it can help us answer our question? I want to show you two possible ways that we could solve this problem. So option number one, we could take all of the text out of this document and just place it directly into a prompt, like the one you see on the right-hand side. So we might ask Claude to answer a user's question. We'll then put in the user question and then take all the text out of the document and put it into the prompt as well. Now, this is perhaps not the best solution. It might work, it also might not. Just so you know, there is a hard limit on how much text we can feed into Claude. So if this document is really, really long and we take all the text out of it and feed all that text into Claude, we might immediately end up getting an error, which means just right out the gate, this solution would not work if our document is really, really long. The second problem with this approach is that Claude gets a little bit less effective as your prompt gets longer. So if you start putting a tremendous amount of text into a prompt, Claude is going to have just a harder time understanding exactly what you want and answering your question because there's just a tremendous amount of information inside the prompt. And then finally, larger prompts cost more money to process and take longer to process. So there's a financial burden here as well and a user experience burden because they just have to wait around longer to get back some kind of answer. So option number one might work in some scenarios. In other scenarios, it might fail entirely. So with that in mind, let's take a look at option number two. Option number two is a little bit more complex. So option number two has two separate steps. In step one, we'll take all the text out of the document and break it up into small chunks. Then whenever a user asks a question, we're going to take their question and put it into the prompt as before. But we're also going to go through an extra little step. We're going to examine the user's question very closely, and we're going to find a chunk of text that seems most relevant to the user's question. In this case, if a user asks us, what risk does this company face? And we have a chunk of text right here that seems to be about risk factors, we would then take that chunk of text and include it inside of the prompt. So now we are focusing all of Claude's attention on just this very small snippet of the overall financial document. And hopefully Claude can do a much better job of answering the user's question than before when we were just putting all of the text of the document into the prompt. So option number two has a distinct set of upsides and downsides. The upsides here are that Claude can focus on just the relevant content. Secondly, this can scale up to really, really large documents with a tremendous number of pages. And it also works if we have multiple documents. We can take all these different documents, separate them all into chunks, and then once again, only include chunks relevant to a user's question inside of a prompt. This technique also generally leads to much smaller prompts, which means it's going to take less time to run and it's going to cost us a lot less. But there are some big downsides to this approach as well. First off, there's just naturally a lot more complexity. This requires a pre-processing step where we take all the text out of the document and split it into chunks. We also have to figure out some way of searching through all these chunks to find the ones that are most relevant to the user's question, and we even need to define what it means to be relevant to the user's question. When we do find some relevant chunks and include them in the prompt, there's really no guarantee that they will contain all the context that Claude needs to actually answer the question. If a user asks, what risk does this company face, and we include only the risk factors section, that might include some other important area of the document, maybe strategy outlook, where some of those risks get addressed in some way. And then finally, there are many different ways in which we can split the text up. So we could just take all the text of the document and divide it into equal portions. Or we could go through the document and find all these different headers and say for every header, we're going to make a new chunk. So we might have chunk 1, and then 2, and then 3 somewhere down here. There are many different ways in which we can define what a chunk is, and so we have to do a little bit of evaluation and decide which technique is the best for our particular application. So as you might guess, option number 2 is RAG. It is Retrieval Augmented Generation. As we just discussed, RAG has many big upsides and many big downsides as well. There's a lot of technical challenges around it. It requires a pre-processing step. We also have to figure out some kind of searching mechanism to find those relevant chunks. We have to chunk documents. All in all, there's just a lot more work than option number 1. So whenever we are considering implementing RAG inside of an application, we really have to analyze all these different steps and figure out whether or not it is right for our particular use case. All right, so now we have kind of a very, very high level understanding of what RAG is all about. Let's start to take a look at the actual implementation of this process in just a moment. Inside of this video and the next couple of videos, we're going to start to implement our own custom RAG workflow inside of a series of different notebooks. We're going to first focus on just making the most simple, basic RAG setup we can possibly make, and then we're going to add in some additional steps over time. Now, as a reminder, a typical RAG pipeline looks a little bit like this to really simplify things. We're going to take a source document, break it up into chunks of text. Then whenever a user asks us a question, we're going to find some relevant chunk of text, put it into a prompt, and that's pretty much the entire thing. So step one of this entire flow is to take a source document and break it up into chunks of text. Now, believe it or not, this process of taking a document and breaking it up into separate chunks is one of the more complex steps of the entire RAG pipeline, simply because how we chunk our document up has a huge output on the quality of our RAG pipeline. And I want to give you an example right away to help you understand why that's the case. So take a look at this source document. It's just a couple of little lines, and it's supposed to kind of represent some kind of report from a company or something like that. And just reading through it really quickly, we can see that there's really three general areas. We have a header, we have a section about medical research, and then a section about software engineering. Now, there are many ways in which we could divide this thing up into separate chunks, but I'm just going to suggest one way. I'm going to say for every kind of distinct line inside this document, we're going to make a separate chunk. So we'd end up with about 5 separate chunks like the ones you see right here. If you consider each of these different chunks now, you will notice something really interesting. The third chunk of text right here is all about medical research. That's what this text is about. It was inside of the medical research section, but it contains the word bug. So at kind of a high level, if you just glanced at this paragraph alone, it is almost like it's kind of about software engineering, just because it contains the word bug. And then likewise, down here, we have the software engineering section, and inside of it is the word infection vectors. Infection vectors is a little bit more of a medical term. So once again, we have a section that is about software engineering, but the language inside of it is kind of about medical research. So now I want you to think about what would happen if we took these chunks and we add them into our RAG pipeline. Let's imagine that a user asked a question of something like, how many bugs did engineers fix this year? So now our job as a part of the RAG pipeline would be to find the chunks of text we have that are most relevant for the user's question. Well, the user said something about bugs. So, well, at first glance, this chunk of text right here seems relevant just because it contains the word bug. So we might decide to take this chunk of text and add it as context into the overall prompt. And as you can tell right away, this is a huge error. The user wants to understand something about software engineering from the report. So we definitely wanted this section, but we erroneously got something about medical research instead. So this is an example where a chunking strategy can easily introduce huge errors and very bad context inserts into your prompt. So to solve this problem, we're going to spend a lot of time thinking about how we're going to take our original source document and break it up into different chunks of text. In this video, we're going to cover 3 different chunking strategies or methods to divide our document into separate chunks of text, each of which have some feature or some technique meant to address the problem that we just saw. So we are going to discuss size-based chunking, structure-based, and semantic-based. The first one we're going to cover is size-based chunking. This is where we take our big old document, so a big chunk of text, and we just divide it into a number of strings of equal length. This is by far the easiest technique to implement, and it's also probably the one you're going to see most often in production implementations. So let's take a look at how size-based chunking is done. With size-based chunking, we're going to take our original document and divide it into some number of strings of more or less equal length. In our particular case, we have a source document with about 325 characters. So we could decide just completely arbitrarily to divide that into 3 separate chunks. And that means each chunk would have about 108 characters or so. So we might take the first 108 characters, put them into chunk 1, the next 108, put them into chunk 2, and just repeat for the entire document. Now, very simple technique, but right away it has a big downside. And that is that each chunk is probably going to end up with some number of cutoff words inside of it. You can see right away, the first chunk has the word significant cut off. So it's just signifique, in the first chunk, and then it ends the word in the next one. In addition, each chunk ends up lacking context. So for example, the third chunk down here, unfortunately does not really include the section header that was right above it. And this section header would have provided a lot of context on what this text right here is really talking about. So to solve this problem that starts to come up right away if you use size-based chunking, we can implement a overlap strategy. An overlap strategy is where we are still going to do size-based chunking, but we're also going to include a little bit of overlap from the neighboring chunks. So for example, we have the original chunk 1 right here, but we might decide to include just a number of characters from the next chunk down. So in this case, we might include the rest of the word significant plus the end of that entire sentence. So we would end up with a chunk that looks like this that just has a little bit more meaning to it. And then for chunk 2, we would still have the body be this area right here, but we'd include an overlap of some number of characters from before the chunk and after the chunk. So with this strategy, we are going to end up with a decent amount of duplicated text. For example, in this case, we have section 1 medical research inside the second chunk, and that was also included inside the first one as well. So there is duplication of text, but the upside here is that each chunk of text has, in general, a little bit more context provided for it. The next kind of strategy that you're going to see is structure-based chunking. This is where we are going to divide up the text based upon the overall structure of our document. So we might try to find headers or paragraphs or general sections and use those as our dividing lines for each chunk. Implementing this strategy of chunking with our document would be really easy because our document is written with Markdown syntax. We know that because it has the little pounds right here, the double hashes for each section. So we might look for these little pound symbols and then say that every time we see this kind of symbol, that means we must be starting a brand new section. So we could very easily write out some code to programmatically split on the double hash characters, and we would end up with some pretty well-formed sections, like what you see right here. Now, this might sound like a fantastic strategy, but unfortunately, reality just doesn't favor it quite so often. In many cases, you are going to be trying to ingest documents that are not formatted with Markdown syntax at all. They might be plain PDF documents that just contain plain text, in which case you will not get these very clearly delineated sections. So again, even though this seems like a great technique, implementing it can be really challenging, especially if you do not have any guarantees around the structure of your different documents. The last chunking strategy that we are going to discuss is semantic-based chunking. This is where you might take all of your text, divide it up into sentences or sections, and then use some kind of natural language processing technique to figure out how related each consecutive sentence is. You'll then build up your chunks out of groups of these somehow related sentences or sections. Now, as you can tell just by the description, this is by far definitely a more advanced technique, so we're not going to look too closely into the actual implementation. The only reason I mention it at all is just to make it clear that there's really no set finite fixed number of chunking strategies. There's really an infinite number of ways in which we can decide to divide up our text. And so deciding upon which method you use really comes down to your particular use case and what guarantees you have around the documents that you are trying to ingest. Now, before we move on, I want to go over a very quick example with you. So I've got a Jupyter notebook put together with 3 different chunking strategies implemented inside of it. So I would encourage you to find the notebook called 001 Chunking. Also make sure that you download the accompanying report.md file and place it inside the same directory as that notebook. This report.md file has a little sample kind of fictional report inside of it that we're going to use for testing purposes as we learn about how to implement a RAG pipeline. So inside of here, you'll find a couple of different cells. The first one contains a sample implementation of a chunk by character. So this is an implementation based upon the size-based strategy, where we are going to divide up our text into strings of equal length that also have some amount of overlap on them. You'll notice that the arguments are going to be the text, the size of each chunk, and then some amount of chunk overlap. So again, that is the number of characters we want to have on either side of the chunk. The next cell shows how we might chunk by sentence. So very similar idea, but now I'm using a regular expression to split the text up into individual sentences, and then each chunk will be formed out of some number of sentences with optionally a little bit of overlap on each side. And then finally, if we have really strong guarantees around the structure of our document and its exact contents, we might try to use a chunk by section, which would be an example of structure-based chunking. So in this example, it's going to look for a new line character, and then 2 pound signs, and then a space. And that is going to be our separation criteria. So we would get kind of Executive summary would be the first chunk. Well, technically the second one. This would be the first chunk up here, but then we would get everything inside the executive summary all the way down to the table of contents. That would start off our second chunk. And then the next chunk would be the methodology and then section 1 and so on. This will give us the best formatting for each chunk because each chunk will consist of exactly one section, but it really only works because we have a guarantee around the structure of the document. We know it is Markdown, and we know that we're only going to see that new line, pound, pound space in the case that we have a new section beginning. Now let's test each of these really quickly. So back inside my notebook, I'm going to go down to the bottom cell, and I'm going to first try out the chunk by character. So I'm opening up the file, getting all the text out of it. I'm going to chunk by character and then just print out each chunk with a little separator between each one. So I'll run that, and now we'll see that we get our first chunk right here, second, and so on. And right away, you can see that the default settings do not produce very good chunks. So the default settings are a chunk length of 150 with an overlap of 20. So in this case, each chunk doesn't really provide a whole lot of meaning. Like, what does this sentence right here really do for us? And can we really use it to answer any user question? I don't know, maybe not. So we might decide to dramatically change our default settings here. Maybe I want a chunk length of 500 with a overlap of 150. Let's see if that gives us something a little bit better. Okay, that's a little bit better than what we had before. So now I can start to see the formation of actual individual sections here that give us a little bit of information. You'll also very quickly start to notice the overlaps. So I can see addressing complex challenges. Well, it turns out that exact phrase is included inside of the chunk right above. So that's an example of the overlapping that we get. All right, next up, let's try our second strategy, which is chunk by sentence. And again, I'm going to use the default arguments. And this one actually looks like it's pretty strong. So this should give us 5 sentences by default in each chunk with 1 sentence of overlap. And we are using a regular expression to split up each sentence. So there might be cases where it doesn't split a sentence correctly, but at first glance, yeah, I'd say this looks pretty good. Each chunk appears to give us a solid amount of information. And then finally, we can try out chunk by section. Now run that. And now we can see that the first chunk is not going to contain a lot of useful information, but everything after that is really, really strong because we are getting exactly a single section each time. I get just the executive summary, and then the table of contents, and then section 1, section 2, section 3, and so on. So once again, which strategy you use entirely comes down to the nature of your document and what guarantees you have around its structure. For us, chunk by section looks fantastic. But if we are expecting to receive user-provided documents where there are no guarantees around the formatting of each document, then using chunk by section is probably not going to work out in the long run. In that case, we might fall back to chunk by sentence. But even this might not work out pretty well. Imagine that we are trying to chunk user-provided code, for example. Well, if we try to split code up into individual sentences, we are probably going to get a lot of unexpected results because code tends to have periods in very unexpected places. So that might mean that we just fall back to the old reliable standard, which is chunk by character. Chunk by character is not guaranteed to give you the best results, but it's going to work vast majority of the time, and it's going to work out reasonably well. After extracting some number of text chunks out of a source document, the next step inside of our RAG pipeline is to wait for a user to submit a question or a query or something like that. And whenever that occurs, we need to take a look at all of our different text chunks and find some number that seem to be somehow related to the user's question, so that we can add them as context into our prompt. Now, this process of finding some number of text chunks that are related to the user's question, there's a lot of complexity hidden there. But when we really think about it, this truly is a search problem. We want to take the user's question and search through all of our different chunks until we find some related content, and then surface those in some way. The most common way of implementing this inside of a RAG pipeline is by implementing a system known as semantic search. Semantic search utilizes something called text embeddings to better understand what each chunk of text is all about and somehow find the chunk of text most related to the user's question. Now, we're going to spend a decent amount of time now to focus on text embeddings and really understand what they are doing for us. So let's take a look at a couple of diagrams. A text embedding is a numerical representation of the meaning contained in some text. These text embeddings are generated by something called an embedding model. We feed text into an embedding model, such as "I'm very happy today," and the embedding model is going to spit out a long list of numbers. That long list of numbers is our actual embedding. The numbers inside the embedding can range from -1 up to +1. So now the question is, what do these numbers really mean? Each number inside of an embedding represents a score of some quality of the input text. Now, this is where things get a little confusing because I'm showing two conflicting ideas in this diagram. Let me break this down for you and just be super clear. In reality, we do not know what quality each number inside the embedding is actually tied to. So when I label that first number and say, this is a score of how happy the text is, that's not entirely accurate. We simply don't know what that first number truly represents. Nonetheless, it is very helpful to think of these numbers in that way. It is helpful to imagine that the first number might be one score of how happy the text is, and the second is how much the text is talking about fruit, etc. Again, these labels are completely made up by me, and we don't actually know what each number represents, but it's extremely helpful to think about embeddings in this way. So that's how you really want to picture each of these numbers. They are kind of like scores of some different qualities of the input text. Now that we have a vague idea of what embeddings are all about, let's go back over to our notebook. We're going to try to create an embedding and get a better handle on what they are going to do for us. All right, so back over here, I've opened up a new notebook called 002_embeddings. Make sure you open up that notebook as well. Inside of here, at the very top, I am creating a Bedrock client, just as we've done many times previously. And then a little bit further down, I've made a function called generate embedding. So this is a function that we can call. We'll pass in a bit of text. It's going to reach out to AWS Bedrock and generate an embedding for us. To use it, I'm going to go down to the bottom. And down here, the first thing I want to point out is that you do need to specify a embedding model ID. As I mentioned a moment ago, there are different embedding models out there. So we want to use a very particular one in this case. It is Titan Embed Text v2. Now, you might not have default access to this model. If you don't, that's totally fine. You can hop onto the Bedrock console and request access for it. And if you still can't even do that, you can always use version 1. That is totally fine as well. For our purposes, it will work just as well as version 2. Then inside the rest of the notebook, I'm going to open up the file, report.md once again. I'm going to chunk it by section, and then I'm going to pass in the first chunk to the generate embedding function. Let's run that and see what we get back. So we get back a huge list of numbers. So these are our individual embedding values. If you scroll down a little bit, you can see the list goes on for quite a while. By default, you're going to get back a list of embeddings that is 1024 elements long. So as you can see, generating embeddings is super easy and straightforward. There's truly not a lot of complexity here. So the real question that we need to understand is not really so much how do we generate an embedding, so much as it is what do embeddings do for us and how are they useful during the RAG pipeline. Remember, we got into this entire topic when we started talking about semantic search. So we're going to take a quick pause right here. We're going to come back in just a moment, and we're going to outline the entire RAG pipeline in greater detail, and I'm going to show you where embeddings really fit into the entire process and why this idea of having a mathematical or numerical representation of some chunk of text is useful at all. At this point in the module, I've given you a high-level overview of how the RAG pipeline works. We've spoken a little bit about text chunking, and we've got just a taste of text embeddings. So now we're going to take these three different topics, our high-level overview of the RAG process, text embeddings, and text chunking, and we're going to merge them all together and really understand the entire RAG pipeline. So we're going to go through a complete RAG example and go through a lot of detail and really understand everything step by step. So let's get to it. Step number 1, just as before, we're going to take some source document and chunk it into separate pieces of text. So for this example, I'm going to assume I just have 2 pieces of text here, just section 1, medical research, and section 2, software engineering. Step 2, we're going to generate embeddings for each of these different chunks of text. Now in this example, we're going to pretend that we have this imaginary super perfect embedding model. And this embedding model has 2 very important characteristics. First, we're going to assume that it always returns embeddings of length 2, so just 2 separate numbers. And we're going to also assume that we know exactly what each number is really scoring about the source text. Remember, in reality, that is not the case. But in this scenario, we're going to imagine we know exactly what each number is really talking about. So we're going to say that the first number is how much the text is talking about the medical field, and the second is how much the text is talking about software engineering. So for the first chunk of text, when we embed it, this thing is definitely talking about medical research. So I would give it maybe a score of 0.97 to say, yes, absolutely, this is very much talking about the medical field. And then it also uses the term bug, which has a slight software engineering connotation. In addition, medical itself is pretty heavy on software engineering, so I'm going to give it a score of 3.4 for software engineering. Then for the second piece of text here, well, it's definitely talking about software engineering, so I'm going to give it a score of 0.97 for that. And then it also mentions infection vectors, which has that connotation of medicine, so I'll give it a slightly higher medicine score as well of 0.3. Now that we have generated these embeddings, we're going to go through an extra little step of mathematics here, something referred to as normalization. Now, you do not really have to understand normalization that much. This is already going to be done for you in the vast majority of cases by the embedding API that you are using. This normalization step is going to scale the magnitude of each of these pairs of vectors to 1.0. And if you don't understand that terminology, totally fine. Don't sweat it too much. Just understand that we're going to do a slight little adjustment to the actual magnitude of each number. Once we have generated these embeddings and normalized them, we can kind of visualize them on a plot like this. So on this plot, I've drawn a unit circle, and each of our points representing both those embeddings will lie exactly on the circle because we have normalized their lengths to exactly 1. So we've got the software engineering section up here, and here's medical research over here. So now that we have these embeddings, we're going to move on to the next step. In this step, we are going to take these embeddings and store them inside of something called a vector database. This is a database that has been optimized for storing, comparing, and looking up long lists of numbers, exactly like what our embeddings are. Now, at this point in time, we kind of pause, we take a break, because this has all been pre-processing work that we did ahead of time. So at this point, we kind of just sit around and wait for a user to actually submit a query to our application. So we will imagine that at some point in time, finally, a user will come to our app and maybe type into a chatbot or something like that, their question or their query. Maybe in this case, their question is going to be something like, I'm curious about the company, in particular, what did the software engineering department do this year? Now, at this point in time, we're going to take that user's question and we're going to run it through the exact same imaginary embedding model. In this scenario, because the user's question is asking specifically about software engineering, I'll give it a score of 0.89. And then because it's also talking about company, and again, software engineering is kind of tied up in the medical field, I'll give it a very slight medical score as well of 0.1. Now that we have this embedding, we're going to go through that normalization step again. And then finally, we're going to make use of our vector database. We're going to take the user's query, we're going to feed it into the vector database and say, please search through all the vectors we have stored inside of you and give us the vector that is closest in nature to this one. So in our case, I would kind of expect to get back section 2 software engineering because that's kind of what the user asked about over here. But let me tell you exactly what is happening inside of the vector database that is able to give us this very closely related result. Okay, so a little bit of math here. Don't worry, it won't be too much. So when we take the user's query and add it onto this chart, we can see right away that visually, the user's query is just really close to software engineering. So you and I as humans, we could look at this chart and say, oh yeah, clearly these two things are very close. The user's query is very similar to software engineering. So obviously, if we want to find some chunks inside the vector database related to the user query, this would be the one that we want. But of course, we are using computers here, and our computer doesn't actually just make a chart like this and then look at it. There's some actual calculation going on behind the scenes. So let's examine exactly what that calculation is. And it's kind of important for you to know it because eventually when you start using vector databases, they're going to use a lot of terminology that's related to this kind of math going on behind the scenes. And to actually interface well with the vector database, you kind of need to have at least a very basic understanding of the math. So that's why I want you to understand it. All right, here's a high-level look at the math that is being done inside of your vector database. To find which embeddings are most similar to the user's query, we want to calculate something called the cosine similarity. This is the cosine of the angle between the user's query and each of the other embeddings stored in the database. So we'd want to find the angle A right here and take the cosine of it, an angle B right here, and take the cosine of it. The math for this is shown on the right-hand side. The result of this calculation will be a number between -1 and 1. If we get a result close to 1, as we did right here, then that means that we have found an embedding very similar to the user's query. Results closer to -1 mean we have found an embedding that are not at all similar to the user's query. In our case, the cosine similarity between our user query and the software engineering chunk is 0.983, meaning that these two embeddings are very similar. So this is a sign to us that we would want to take the software engineering chunk of text and include it in our prompt with the user's question. Now, before we move on, one other quick thing that's going to be a little confusing right now, but it's going to be very, very helpful to know later on when you start working with vector databases. In a lot of vector database documentation, you're going to see something referred to as a cosine distance. This is different than the cosine similarity. It is calculated as 1 minus the cosine similarity. This adjustment is often done just to give us an easier to interpret number. With the cosine distance, values close to 0 mean you have a large similarity, and larger values than that mean we have less similarity. Again, this is something you're going to see very often in vector database documentation, so just be aware of it whenever you see the term cosine distance and cosine similarity. So now that we understand some of this math at a very high level, let's get back on track. Once we have found a text chunk with a high similarity to the user's question, we're going to take the user's question, add it into our prompt, and the text chunk that we found that's most relevant and put that into our prompt as well. We then take that prompt and send it off to Claude. And that's the entire process in great detail. So now that we understand everything from start to finish with all the kind of tech behind the scenes going on and even some of the math, let's start to implement this inside of a notebook in just a moment. Now that we understand the entire RAG flow, we're going to walk through an example inside of another notebook called 003 Vector DB. So in this notebook, I provided a sample implementation of a vector database, and I've called it class vector index right here. If you want to, feel free to take a glance at it, but I'll walk through everything you need to understand about it. Now in this notebook, we're going to walk through the entire RAG flow by implementing 5 different steps, the same 5 steps we just spoke about in the last video. So let's get to it. Step number 1, I have already opened up the file and read the text from it, specifically our report.md file, which should be in the same directory as this notebook. So in step 1, we're going to chunk the text by section. I've already added in a function to help with that, so the same chunk by section function we had previously. So to do our chunking process, I'll say chunks is chunk by section and pass in all that text. And now just to test things out and make sure I've got everything working correctly, I'll try printing out chunks at, how about 2? And I should see a printout of the table of contents. And then if I go to 3, I should see the next section down, and then the next section, and so on. Next up, let's take care of step 2. So in step 2, we're going to loop through all the different chunks that we just created and generate an embedding for each one. So for that, I'll say embeddings is generate embedding, and I'll pass in the chunk for chunk in chunks. We already saw the generate embedding function a moment ago. All that function is going to do is take in a little bit of text and generate an embedding for it. So if I run this, it's going to take a little bit to actually execute because we are making an API request for each chunk of text. And if I wanted to, I could, of course, also print out embeddings at 0 just to verify that, yes, we did in fact get the embeddings. Yep, there they are right there. Now in step 3, we're going to create our vector store and store all these different embeddings inside of it. So I'm going to make an instance of the vector index, like so. After that, I'm going to loop through all the embeddings that we just created and add each of them one by one to this store. So we'll say for embedding and chunk, and I'm going to zip together embeddings and chunks. And then for each of those, I'm going to add a vector of the embedding and then a dictionary with content of chunk. So let me explain why I'm doing this exactly. Why are we doing the zip operation? Why are we including this extra dictionary on here? As we just discussed, eventually at some point in time, we're going to reach out to our vector database and get back a list of all the different related embeddings to the input. Now, when we get back this list right here, just getting the number by itself, just getting the embedding is not really useful to us because the embedding, it doesn't really have a lot of meaning to you and I as developers. What we really care about is the text associated with that embedding. So usually, whenever you store these different embeddings inside of your vector database, you're also going to include either the text from the chunk that the embedding was generated from, or at least the ID of the chunk, something to at least point you back to the original chunk text. So in this case, I'm going to include the original chunk text along with each embedding. Again, just so when we do the lookup later on, and I get back the most similar chunks, I've got the actual text that I'm looking for. All right, I'm going to run that, and it should take just a moment. And now step 4, so this would be sometime later, eventually a user is going to ask a question. So now we want to generate an embedding for it. So we'll say user embedding will be generate embedding. And my question here, I'm going to pass in as a plain string. I'll say something like, what did the software engineering dev do last year? So I'll run that, get the embedding. And now finally, here's where we go and find our relevant documents. So I want to search the store with the embedding, and I want to find the 2 most relevant chunks, not just the most relevant. I want to get the 2 chunks that seem to be most relevant to this question right here. So for that, I'll do a results store.search. I'm going to pass in the user embedding. And I'm going to pass in another argument here of 2 because I want to find the 2 most relevant chunks. And then I will print out for doc and distance in results. I'm going to print out the distance, a new line, and then the document's content. And because each chunk here is really, really large, I'm going to print out just the first 200 characters and then another new line like so. And I'll run this, and there's our result. So we get back section 2 as our best result. We also see the cosine distance here, so it's 0.71. And the next closest chunk is at 0.72, and that was the methodology section. So these were the 2 chunks that were found most relevant for the user query that we just submitted. All right, so that is our entire RAG workflow. Now, all this works, but there is 1 or 2 scenarios where everything doesn't quite work as expected. So there are still a couple of improvements that we could add into our workflow, and let's start to discuss those in just a moment. We've got the first iteration of our RAG pipeline put together, and everything looks good right now, but we're going to very quickly realize that, well, maybe we are not getting the best search results. Let me show you an example. If you open up the report.md file and scroll down just a little bit to the software engineering section, here it is right here, you'll notice that it has the statement of INC, which is short for incident, 2023 Q4 011. And it looks like that search term occurs 3 times inside of this paragraph. So here's 1 right here, 2 right there, 3 right here. And if I continue searching throughout the document, I'll see that it is also mentioned down here inside of section 10, cybersecurity analysis. It's mentioned inside the header and then 1 time inside the actual paragraph itself right there. Now, I want to try searching for this term, this incident 2023 Q4011, and we're just going to see what happens. In other words, what search results do we actually get back using semantic search? So back inside of my notebook, I'm going to update the user query right here to be what happened with incident 2023. Then I'm going to rerun all cells, and we'll see what result we get. All right, so take a look at this. It's a little bit surprising result. We get section 10, which is good. That's definitely the result we would want to see first in the list, because section 10 is all about this incident. But then very surprisingly, the next result is section 3, financial analysis. Well, if you open up section 3 right here, you'll notice that nowhere inside of section 3 is that incident ever mentioned. So we are getting some output from our semantic search that is a little bit surprising here. What we really wanted to get back was section 10 and then section 2, but what we got was section 10 and then unfortunately section 3. And section 3 appears to be completely irrelevant when it comes to investigating this incident. So even though the semantic search technique we put together is really fantastic and it's going to work well a lot of the time, there are these corner cases where it really just doesn't quite work as expected. So let's take a look at a technique we can use to improve our search results and hopefully get the results we want, which is section 10 and then section 2. All right, so here's the general strategy we are going to use. Whenever a user asks a question, we're going to feed that question into our semantic search side of the equation, which is generating those embeddings and using the vector database. But then in parallel, at the same time, we're also going to implement a separate lexical search system. Now, lexical search is more like classic text search, where we are going to break down the user's question into individual words and then trying to find chunks of text that seem to include those words. Once we go through the search process in both different systems, we'll get two sets of results, and then we will merge the results together. And the hope here is that we'll get a little bit better balance of search results, where we get both the kind of semantic aspect and the plain text search aspect included in one result set. So hopefully we will eventually get a result that looks like this over here. Now, to implement this lexical search, there are a tremendous number of methods for implementing text search, but a very common method that you're going to see used in RAG pipelines, like the one we are building right now, is a technique referred to as BM25. Now, this is short for Best Match 25. In the rest of this video, I'm going to give you a high-level overview of how this algorithm works, and we're going to take a look at a notebook that actually implements BM25. So we'll be able to play around with it directly and see what kind of search results we get. So here's the general idea behind the BM25 algorithm. Now, again, I'm going to give you a high-level overview, and I'm going to leave out a couple of smaller steps just to simplify things and make it easier to understand. Everything is going to begin with us receiving a user's query. And let's imagine in this case, they put in a search string like this right here, just A, so the word A, and then incident 2023 Q4011. In step 1, we're going to tokenize the user's query. And that means we're going to break it up into separate chunks. There are different ways in which we can tokenize a user's query, but for right now, we're going to use a very simple method, which is to just remove punctuation and break up the all terms based upon spaces. So in this case, I would end up with separate search query terms of A and then incident 2023. Next, we're going to see how often each of these different search terms occurs across all of our different documents, or in our case, really text chunks. So let's imagine that we only have 2 text chunks in this scenario. So we're going to see how often the word A and the word incident blah, blah, blah occurs across each of these chunks. And it looks like this first chunk right here has A right there, and then the second one has A. So in total, I would count all those up and I would have 5 A's. And then I would see how often I have incident 2023. It looks like there's only 1 right here. So I'd end up with a frequency of 1. Next up, we're going to assign a relative importance to each term based upon its usage frequency. So in the case of the word A, it was used 5 times. And because it was used rather often, we're going to say this term is not super important because it is used all the place across all of our different documents, or in our case, our text chunks. But incident 2023, that was used very infrequently, which means it is probably going to be of greater search importance. Then finally, in the last step, we're going to find the text chunk that uses the higher weighted terms more often. So in this case, the first text chunk right here, it only has 2 A's, whereas the second one has 3 A's. But A's are not super important because they're used rather frequently across all of our different chunks. However, text chunk 1 uses incident 2023 1 time, and that is a highly weighted term. It's a really important term. So in this case, we would say this is probably our best text chunk, and we would want to return this as a prime search result. Now again, to see all this in action, let's take a look at a quick Jupyter notebook. So back inside of my editor, I'm going to find a new notebook. This one is called 004_BM25. Again, at the top, I've got some code relating to chunking by section. I then got a basic implementation of BM25 in the form of this class called BM25index. So I'm going to collapse that cell, make sure I run it. I'm then going to read the contents of our report file, and then we're going to go through 3 separate steps here. We're going to first chunk the text by section. We're going to create a BM25 index store, and we're going to add each text chunk to it, and then we're going to attempt to search the store. And once again, our hope here is that we're going to maybe get some search results that look a little bit closer to this. Maybe not exactly these results, but I definitely want to see the sections that use incident 2023 before I ever see some results that don't include that search term at all. So let's see how we do. Okay, let's take care of step 1 here. We need to chunk the text by section. So we've gone over this a couple times now. We'll say chunks is chunk by section with text. Next up, I'm going to create a store, and I'm going to loop over all my chunks and add them in as documents to the store. So I'll say for chunk in chunks, store, add document, and I'll pass in a dictionary with a content of chunk. I'm going to run that. And now finally, I'm going to search over the store. I'll say store search, and I'll use that same term that I used in the previous notebook that did not give us the very good result. So I'll ask, what happened with incident 2023 Q4011? And I'm going to ask for the first 3 search results. And then I'm going to print up the results very nicely just so we can interpret them really well. Let's say for doc distance in results, and I'll print out the distance, a new line, doc with content. And again, I'm only going to print out the first 200 lines. And then how about a new line, a couple of separators, and another new line. I'm going to run this and we'll see what we get. All right, so that's a much better search result than what we had before. Now we're going to see software engineering first, and then cybersecurity after that, and then methodology down here. So now I am actually prioritizing the sections that use the most important search term inside of my query, which was the incident 2023. And you'll notice that I don't really have quite as much importance around the other terms like what happened with. Those aren't quite as important terms, and they might be used several times inside of the original report, so I would not weigh those as heavily in the output results. But this incident 2023, that's a very rare term inside of a report, so it should definitely have a much higher weighting. And we can see that reflected very clearly inside of our search results. All right, so now, at this point in time, we have 2 separate search systems. We have semantic search put together, and we have this kind of more lexical, a little bit more classic text search system. And you might notice that in the implementation of these 2 stores, back up here in the cell right here, I put them together with a rather similar API. They both have a add document function, and they both have a search function down here as well. So now that we have these 2 separate search systems, one which implements semantic search and one which implements lexical search, we're going to come back in the next video and we're going to merge these 2 search systems together. Whenever a user submits a query, we're going to forward it off to both of these different search systems. We're going to get back a set of results from both, and we're going to merge those results together. And hopefully we'll have all the best outcomes of semantic search along with some of the more classic results of lexical search as well. We now have an implementation for semantic search and an implementation for lexical search. So now we need to wire these things up together. Let me show you how we're going to do that. The first thing to notice is that the implementation for both these searching functionalities have the almost exact same public API. So we have a vector index class on the left-hand side that has methods like add document and search, and we have almost identical methods inside of our BM25 index as well. So to connect these 2 things together into a single search pipeline, we're going to wrap them up inside of a new class that we will call retriever. This retriever is going to receive a user's question and then forward it on to the search methods of vector index and BM25 index. The retriever will then receive the results from both of them and figure out some way of actually merging the results together. Now, it turns out that the merge operation is actually a little bit tricky, so I want to go into a little bit of detail on how you can merge results that are coming out of these different search methodologies. To combine the results together, we're going to use a technique known as reciprocal rank fusion. The easiest way to understand this technique is to go through an example, so let's do that right now. Let's imagine that we run a search on the vector index and we get outputs of section 2, 7, and then 6. And then we do the same exact search on BM25 and we get 6, 2, and 7. So now we need to take these 2 lists of results and combine them together in some way. To do so, I'm going to take all the search results and put them together on a single table, like so. So now I've got text chunk 2, 7, and 6, and I've recorded the rank from the vector index output and the rank from the BM25 index output. And to be clear, when I'm talking about rank, I just mean kind of search output position. So rank 1, 2, 3, rank 1, 2, 3. I'm just kind of putting those same exact numbers on this chart down here. Once I have all those ranks in place, I'm then going to apply a formula Here's the exact formula right here, and I know it looks really terrible, but don't worry, it's not as complicated as it looks. Here's how it works. For every rank column we have, so like that column right there and that column right there, we're going to write out a separate term. So here's the term for the first column, here's the term for the second column. In the first term, we're going to write out 1 over 1 plus whatever number is right there. So we end up with 1 over 1 plus 1. And then the second term will be 1 over 1 plus whatever number is right there. So 1 over 1 plus 2. Once we have calculated the score for each text chunk, we're then going to sort the table based upon the score from greatest to least. So we'd end up with something like this. So we'd end up with text chunk for section 2 as being the most relevant search result. Section 6 would be the second most, and section 7 would be the least relevant. And this kind of makes sense. We can kind of visually confirm that these outputs make sense if you just look at the individual rank outputs from each search methodology. So section 2 was rank 1 and 2. That means, hey, in general, it's trending up towards the top. Section 6 is 1 and 3. That's kind of like in the middle. It has a good score and a bad score. And then section 7 is 2 and 3. And so it trends down towards the bottom. So with a visual inspection, the results, I think, do make a decent amount of sense. All right, so now that we understand how we're going to combine the results together, let's go back over to our Jupyter Notebook, and we're going to take a look at a sample implementation of a retriever class and a sample implementation of merging the results. Okay, so back over here, I move on to the next notebook, which is 005 hybrid. Once again, there's a lot of setup up here. So I've got the vector database implementation, the BM25 implementation, and now I've added in a implementation for the retriever class as well. The retriever has method of add document, and if you call add document, it's just going to take whatever document you pass in and pass it off to each of the different indexes that are contained inside the retriever. So in our case, our indexes are the vector index and the BM25 index. Then the retriever also has a search function. If you pass in some query text to it, that query text will be passed off to each of the different indexes that are contained inside the retriever. We then take all the results that come back and combine them together. So here's the merge logic that implements that reciprocal rank fusion. All right, so time to do a little test here. Now, I want you to recall what led us down this entire path was back on our vector database implementation. So this notebook over here, we found that if we search for something like what happened with incident 2023, we got back some unexpected results where we had section 10, which was good as the first result, and then section 3 was the second result, and that was really unexpected. We want that second result to be software engineering. So when we now run this hybrid approach that combines together multiple different indexes, my hope is that we're going to get first section 10, and then whatever section the software engineering one is. I think it's section 2. So let's test this out inside of our new notebook. I'm going to go down to the bottom, and I'll do a results is retriever search what happened with incident 2023 Q4011. And I'm going to get the first 3 search results. And then once again, I'm going to print them all out like so. And I'll do the score, a new line, the content of the document with just the first 200 lines, and then just a little separator between each chunk. So I'm going to run this, and now we get, hey, some much better search results than what we had before. So I've got section 10, and then section 2, exactly what we wanted. And then section 5, but that one's not super relevant here. So we now have a much better output by combining together these 2 different search techniques. And the nice thing about this is we were able to author each of these indexes kind of in isolation. They're their own separate classes. And because we made each implementation have the same exact API with that search function and the add document function, we were able to easily wrap them up into this larger retriever class. So if we wanted to, we could absolutely add in some additional search index here that maybe implements some other completely different searching functionality. And as long as it has that search function and the add document function, we can very easily add it, have it generate some results, and then merge the results along with the results coming from the other search methodologies as well. Okay, so let's say this is a good success, but we're not quite done yet. There's still some other techniques that we're going to go over to improve the accuracy of our RAG pipeline. The hybrid-based retrieval approach that we have implemented is working pretty well. So as we saw at the end of the last video, if we search for what happened with this incident, we're going to get first the cybersecurity and then software engineering. However, there are still some weak points inside our retrieval process. Let me show you an example. I'm going to update the query here to be, what did the engineering team, and notice I put in not engineering, but just an abbreviation of ENG. What did the engineering team do with incident 2023? So now that I am asking specifically about the engineering team and the incident, I would kind of expect to see section 2 pop up a little bit. Because remember, section 2 is about software engineering and the software engineering team. And inside of the body of this section, there is mention of this incident. So now this query, in my mind, personally, I think this really is the most relevant section. But if I rerun this, we're going to see that we still end up getting section 10 and then section 2. So it's clear that even though we have added in a lot of complexity, well, again, still a couple of rough edges. So in this video, we're going to take a look at yet another technique that we can add in to improve our retrieval accuracy. This technique is referred to as re-ranking, and the idea behind this is super simple. After going through everything that we just covered in the last video, so we're going to still run our vector index and the BM25 index and merge the results, we're then going to add in another post-processing step, something called a re-ranker. The re-ranker is going to take some number of our search results and pass them off to Claude inside of a prompt. So here's a sample prompt that we might use for a re-ranker. We are going to ask Claude to take a look at the user's question, specifically what happened with incident so-and-so, and then we're going to provide all the different documents that we have currently found that seem to be somehow related to the user's question. And then we're going to give Claude a very simple task. We're going to ask Claude to return the 3 most relevant, and it doesn't have to be 3, it's just going to be some number of the most relevant documents in order of decreasing relevance. So in other words, go through all the supposedly relevant documents and just reorder them or re-rank them so that the most relevant document is at the top. So Claude is going to take in the instructions, and of course, it's going to execute the task perfectly and send us back a reordered list of relevant documents. To understand how this really works, let's take a look at a notebook where I have implemented this re-ranking strategy. So back over here, I've opened up a new notebook called 006_re-ranking. There is a ton of setup code inside of here, and then eventually we get to the implementation of a function called reranker_fn. This function is going to be called automatically by the retriever after we have ran the initial search process with the vector index and the BM25 index. So we've already gotten back the initial results, we've already merged them, and now we're going to take these merged results and pass them into this reranker function. So we are going to iterate over all those documents that we found. We're going to print them up in a nicely formatted XML structure. We're then going to insert that list into a larger prompt, the one you see right here. This prompt is asking Claude to take a look at the user's question and take a look at the documents that we have found already. We are then going to ask Claude to return a list of documents in order of decreasing relevance. So the first documents that we get back should be the most relevant results. Then, as usual, we're going to go ahead and use a assistant message prefill and a stop sequence just to ensure that we get back some well-formatted JSON. Remember, we could use tools here to ensure that we get back well-structured JSON, but in this case, it would be a lot of extra work just to get some structured data back, and I think using this prefill with the stop sequence is definitely appropriate. Now, before I say anything else, there's something I want to clarify that might be a little confusing. You'll notice that in this prompt, I'm referring to some document IDs all over the place, but in the diagram I showed you just a moment ago, there is no mention of any IDs whatsoever. So what are these document IDs exactly? Well, it really comes down to efficiency. If we use the prompt I showed you in that diagram just a moment ago and asked Claude to just give us back the most relevant documents or text chunks, we're essentially asking Claude to send us back the full text of every single text chunk. This would be extremely inefficient because we would just be sitting around and waiting for Claude to copy the text out of each individual chunk. So a better solution would be to generate some random IDs ahead of time and assign them to each document or essentially text chunk, and then ask Claude to just return those IDs. This will be significantly more efficient because Claude can return just a very simple little bit of text that's going to tell us the exact order of chunks that we should be making use of. Well, now that we understand how everything is working, let's actually run the notebook and see if we get some reasonable results. Now, I've already ran all the different cells inside of here. Make sure you run all the cells as well. I'll go down a little bit, and get down to the very bottom here where I'm going to ask that same question as before, what happened with incident 2023? So I'll run that and I'll get back same results we had previously, back when we had the just hybrid approach. So I got section 10 and then section 2, so nothing bad. But now I'm going to update the query to the one that gave us just a little bit of trouble a moment ago with the hybrid approach. So what did the engineering team do with incident 2023? And again, my expectation here, my real hope is to see section 2 pop up to the top. And there's no guarantee that's going to happen. You might get different results than I, but that's personally what I'm going to hope for. So I'm going to run this. And then sure enough, we do in fact get software engineering popped up to the top. So that's definitely a good result. Claude has noticed that the user query here really cared about specifically the software engineering team and their relationship to this incident. Well, adding in this re-ranker was definitely a success. On the downside, it increases the latency of our search pipeline because now we have to wait for a call to Claude to resolve. But on the plus side, it also, without a doubt, increases the accuracy of our search pipeline.
Hi there, welcome to this course on getting up and running with Anthropic and AWS. My name is Ellie Shopik, I'm the head of technical training here at Anthropic, and later on we're going to be joined by my colleague Colt Steele to cover quite a bit on Anthropic and AWS. So what are we going to be doing here? We're going to provide a high-level overview of the course, we're going to highlight what you should know before starting the course, and then we're going to ensure that you're set up for success in this course. To give you a bit of an overview of this course, we're going to start by covering some of the research at Anthropic, an overview of our models. We're then going to continue talking about some key concepts in generative AI and how models are actually built from scratch. We're then going to talk about how to work with Anthropic using Amazon Bedrock. And then we'll move on to prompt engineering, tool use and computer use, evaluations, RAG, fine-tuning, and much more. We've got quite a lot to cover here. Before you start this course, we want to make sure that there's some things that you do know and are comfortable with. This includes things like Python fundamentals. This course is entirely in Python, so we're going to assume that you have a baseline knowledge of Python fundamentals, like data types, conditionals, loops, functions, and so on. We're also going to want to make sure that you know how to make an API request using the Bedrock SDK. We're going to talk about this in a bit of review later on, but we want to make sure that this course is not the first time that you have ever come across Amazon Bedrock or made an API request using Bedrock. We also want to make sure you know how to get AWS credentials and work with Python notebook files. To be successful in this course, really take your time. There's a lot of content here, so don't try to learn it all at once. As you're learning, and you're not totally sure what something is, use tools like Claude to help you as you learn. We won't have a tremendous amount of code examples in this course, but we do encourage you to build things on your own. We'll show you how to make requests with Bedrock's SDK, we'll show you how to prompt, we'll show you quite a bit around fine-tuning and RAG, but we really encourage you to take that knowledge and keep building off of it. At the same time, with the examples we have, make sure you run them and get a sense of how these concepts work in practice. As I'm sure you know, the best way to learn this stuff is get your hands on the keyboard. So without further ado, let's get started.
Let's examine one of Claude's more advanced features, known as extended thinking. Extended thinking gives Claude time to reason about the user's query before generating a final response. In many chat UIs, this will be displayed as a separate thinking process, which the user can optionally look at to get a better idea of how Claude is approaching their problem. Now, in general, enabling extended thinking will allow Claude to tackle more complex tasks with greater accuracy, but there are some big trade-offs here. You are charged for tokens generated by Claude during the thinking phase, and the phase itself takes some amount of time to complete. So with increased intelligence comes increased cost, and there's increased latency as well. Now, a common issue around extended thinking is deciding when to enable it. And the answer to this is really simple. You're going to rely on your prompt evals. So you're going to write out a prompt, you're going to run an eval on it, and if the accuracy is not where you want it to be, and you've already spent some good amount of effort on improving your prompt in the first place, that is when you would want to consider enabling extended thinking. Now, the use of extended thinking is really straightforward. Remember, when we normally use Claude, we send over a user message that might contain a text part, and then we're going to get back an assistant message that contains a text part as well. When we start to enable extended thinking, the response we get back is going to contain a new part type, one we have not seen before. It's called the reasoning content part. Inside of this part is going to be the text that was generated while Claude was thinking. There's something really interesting about this reasoning content part that I want to show you right away because you're going to see it really quickly as soon as you start writing out some code and making requests with extended thinking. So this kind of interesting thing is the signature. So on the right-hand side, I've got an example of an assistant message that includes a reasoning content part and a text part as well. Inside the reasoning content part, you'll notice that there is something called a signature. The signature is a cryptographic token. Here's what the signature does. If you want to take this message and send it back to Claude as part of the conversation in the future, Claude wants to make sure that you did not modify the text in the reasoning content block in any way. The signature is used to make sure that you did not change that text. Claude doesn't want you changing that text at all because it is used very heavily during response generation. And if developers were allowed to modify that text, they could possibly steer Claude in a unsafe direction. There's one other aspect of reasoning content parts kind of related to this idea. So in some cases, you might get back a reasoning content part that only has a field of redacted content. This occurs whenever Claude generates some thinking text that gets flagged by some internal safety system. The redacted content is the actual thinking text, but in a fully encrypted form. It is provided to you so you can give this full message back to Claude in the future as part of a conversation without Claude losing any context on its previous thinking. To really understand extended thinking, we need to write out a little bit of code. So let's go back over to a Jupyter notebook. I've made a new notebook called 001 Thinking. Inside of here, the first thing we need to do is update our chat helper function that we have put together previously. So I'm going to find the chat function right here, and I'm going to begin by updating it to add in some additional keyword arguments. I'm going to pass in a thinking argument, and by default, it will be false, and a thinking underscore budget of 1024. This thinking budget is the number of tokens that we want to allow Claude to spend on generating its thinking portion of the response. So 1024 means Claude can spend at most 1024 tokens on generating some thinking thoughts ahead of time before it will be forced to finally respond to us in some way. 1024 is the minimum, so this will serve as our default, and if we ever want to give Claude a little bit more allowance and allow it to think longer, we might bump this value up a little bit. The optimal value right here, again, it comes down to your evals. There's really no rule of thumb where I can just say to you, oh yeah, 1024 is perfect. You have to rely upon your evals to decide upon a budget that is right for your particular application. So now that we have added in these keyword arguments, we're going to do a little bit more refactoring, a little bit lower. I'm going to find the if statement of if text editor. So you might recall previously, we added in the ability for Claude to use that text editor tool. And to enable it, we had to create this additional parameter of additional model request fields. To enable thinking, we have to place an additional parameter on this dictionary. So we're going to do a little bit of a refactor here, just so it's easier to use the text editor and thinking separately. Here's what we're going to do. Right above the if statement, I'll make a new dictionary called additional model fields, and we'll start off as empty. Then inside the if statement, I'm going to delete everything from the colon right there of tools to the start of the line. And I'll say additional model request, or just no request fields. There we go. And then I will index into this with tools, and I'll set that to the list, like so. So we should have additional model fields. We're looking up tools inside there, and we're going to set that to be this whole list. Then underneath that, I'm going to place a new if statement, and I'll say if we are enabling thinking, then I want to add into the additional model fields a thinking property that's going to be a dictionary with a type of enabled and budget tokens of our thinking budget. And then finally, I'm going to add into this params that we're going to send off to the converse function. I'll say params additional model request fields, and that's going to be the additional model fields dictionary that we just created a moment ago. And that should do it. So now I'm going to make sure I run that cell. And then if we scroll down a little bit, I already put together a cell for us, a little template here where you can very easily test out thinking. I'm going to add in a query to Claude, and I'll ask it to maybe write a 1-paragraph guide to recursion. And I want to enable thinking. So I'll put in a thinking of true. I'll then run this, print out all the parts, and we'll see what we end up getting. Well, before long, I get my response, and we can very easily see that it does, in fact, have two separate parts. So here's part one right here. That is our reasoning content part. Inside of it is going to be the thinking text. So that is giving us a clue as to what Claude is thinking about here. And then we've got our signature, which is going to make sure that we never try to tamper with or change this text right here in case we ever decide to send this part of the message back to Claude to follow up our conversation. And then we've got the final text, or the real guide that was generated down here a little bit lower. Now, in some cases, you might want to test out your application and make sure that the code you wrote to handle these responses can handle a reasoning content that has the actual text. And you also want to make sure that it can handle getting a response that has the redacted content as well. So there actually is a way that we can force Claude to give us back a redacted content field just if we want to test out our application and make sure that we can handle this redacted content stuff. To force Claude to give us back some redacted content, we can update our prompt that we're sending in right here to include a very special string, one that I have already written out ahead of time inside of this notebook. So if you scroll up to the very top inside of client setup, you'll notice I put in there thinking test string right here. So that is the magic string. It's even labeled as magic string. If you include this exact string right here inside of your user message, Claude is guaranteed to give you back one of these redacted content blocks. And again, this is just for testing purposes. I'm going to take this string. I'm going to go back down to my user message. And I'm going to send off just that string as the body of my user message. Okay, we'll send this. And then my response will contain the redacted content field. And once again, I'm going to repeat this for a third time. The only reason we do this is to make sure that our application code can correctly handle a redacted content type message. All right, so that is it on extended thinking. Now, the most important thing to really understand here is one of the points that I repeated more than once, and that is whether or not we use extended thinking really comes down to our evals. That's the only way we can really decide if extended thinking is right for our particular use case. So this is yet another sign that's really pointing us to understanding that evals are really critical to implement in any application that we put together. The next advanced capability of Claude that we are going to investigate is Claude's vision capabilities. Whenever we send a user message off to Claude, we can optionally include images inside of the message. We can then ask Claude to do just about anything you can possibly imagine with those images. So we can ask Claude to tell us what is contained inside the image. We can ask Claude to compare different images. We can ask Claude to count different objects. Really, there's a lot of different possibilities here. The first thing I want you to understand around image handling is some of the different restrictions or requirements. So we can send up to 20 images across all the messages inside of a single request. There are some limitations around the size of each image and the height and width of each as well. And then finally, you need to understand that whenever we send an image off to Claude, that is going to count as some number of tokens that we are going to be charged for. And there is an equation you can use to roughly calculate how many tokens you'll be charged for based upon the height and the width of your image in pixels. Now, to include an image itself, this is just yet another type of message part. So inside of our list of parts that we might add into a user message, we're going to add in a new type of image. We are going to include one image part for every image that we want to send to Claude inside of a message. So let me show you what I mean by that. If we want to include just one single image, that means we'll send a user message with one image part. And if we want to send a message off that has two separate images, those will be two separate image parts. We're just going to keep adding them to that list of parts inside of the user message. So now that we understand some of the technical limitations here and how we send an image off, there's something really important that I want to address right away. Whenever an engineer starts making use of images with Claude, well, I notice very often they start using prompts that are very simple, even kind of like the prompt I've got in this example right here. The number one way to get good results out of Claude when you are making use of images is to continue to have a strong focus on prompting techniques. So if you just throw an image off to Claude and then put in a very simple prompt, very often you are not going to get back a good result. For example, consider the conversation on the right-hand side. I put in an image with 12 marbles. I actually tested this, by the way, and I asked it very simply, how many marbles are in this image? And sure enough, I got back an incorrect count of 13. We can dramatically increase Claude's accuracy when working with images by using the same kind of prompting techniques that we've already learned earlier on inside this course. So techniques like providing guidelines, providing analysis steps, or by using one-shot or even multi-shot examples. So let me show you two ways in which we could very easily enhance this prompt and actually get back the correct result. And again, I actually tested this out and made sure that these examples, at least for me, worked as expected. So the first thing we might do is provide a series of steps for Claude to go through in analyzing the image. Now, of course, this is only really going to work if we kind of already understand the content of the image that we're feeding into Claude. So in this scenario, I might ask Claude to first take a look and try to identify each individual marble and just count each of them one by one, and then ask it to recount a second time to verify the initial count and provide it a different mechanism or different strategy for counting the number of marbles. And then finally at the bottom, I ask, okay, now let's kind of compare those two different counts and figure out what the correct answer is. So by providing a more sophisticated prompt, I was able to get a result with a correct count of 12 marbles. Another technique we might use here is one-shot or multi-shot prompting. So here's how that would work. Inside of my user message, I can alternate the presence of an image part and a text part. So in this scenario, I have an image part up here, a text part underneath it, and then another image, and then a text part. In the initial pair, I provide an image with 11 marbles and then say very plainly, the image above has 11 marbles inside of it. Providing an example like this can easily improve Claude's accuracy when it goes to tackle your image later on. As usual, I would like to test out this feature in Claude inside of a Jupyter notebook. But this time around, we're going to have a little bit more complicated example, and I want you to understand the scenario that we're going to walk through here inside of our notebook ahead of time by showing you a quick diagram. All right, so here is a sample use case of how we might use Claude's image support capability. So in case you're not aware, in many parts of the United States, we have really bad wildfire problems where wildfire will begin, sweep through an area, and burn down a ton of houses. And because this is a very common risk, a lot of people want fire insurance to insure their home in case it gets burned down. But these insurers are very much aware that a house can absolutely be burned down tomorrow or next year or very shortly. So these insurers will very often require a homeowner who wants to insure their home to trim trees or even cut trees down entirely around their house. Now, the insurer needs to actually verify and make sure that the homeowner is taking care of the trees appropriately. But to verify that, they might have to send out a person to inspect each property and probably do that inspection maybe once every year or once every 2 years. That would become expensive really, really quickly. So one way that we could automate this process is by getting high resolution, up-to-date satellite imagery, and then feed it into Claude and ask Claude for a fire risk assessment. We might ask Claude in particular to try to detect the main residence on the property. So in other words, inside of a satellite image of a property, find the main home that is presumably insured, and then take a look for maybe tree branches that are overhanging the residence, which is a very common risk of fire. Maybe try to gauge how difficult it is for fire services to actually access the residence. So make sure, in other words, there's kind of a clear path to get to the home. And also take a look at the trees around the home and make sure that they are not too closely or tightly packed, which in its own right could be a fire risk as well. All right, so let's go over to Notebook and see how we could implement this. I'm inside of a new notebook called 002 Images. Inside of here, I have already put together a starter prompt for us. Now, notice that this prompt is highly detailed and walks Claude through different points or different ideas that I want analyzed inside the image. I could have written out a very simple prompt of something like provide a fire risk score based upon the satellite image of this property and just left it there. But I can almost guarantee you I would not get a good result. So instead, I applied some of the different prompt engineering techniques we've learned about previously, and I provided a series of different analysis steps for Claude to go through. Step 1, first, find the actual primary residence inside of the satellite photo. Step 2, take a look at the tree density. Then take a look at the ability for fire services to actually access the property. Take a look at how many trees or specifically branches are overhanging the roof, which is a very common fire risk. And then finally, assign a fire risk rating based upon all these different qualities. And I provide some criteria on helping it decide whether it should be a 1, 2, 3, or 4. And then finally, at the very bottom, write a 1-sentence summary for each with a final score. So that's our prompt. I'm going to make sure I run that cell. And then let's go down here to the bottom, and we're going to write out some code to read in a sample image and feed it into Claude with that prompt and see what kind of result we get. One other quick item. in the same directory as this 002 images notebook, you should find a images directory. And inside there, I have 7 different PNG files that are each a satellite photo image of a house that has some trees around it. So we should have 1, 2 has very low fire risk here, and then 3, very, very low fire risk. And then we could go through and see some different examples. I think 7 is pretty bad. So I would expect to see a very poor fire rating score on number 7, but let's test everything out and see if it works or not. All right, so inside of our cell down here, I'm going to first open up one of those image files and read it as a series of bytes. So I'm going to get the raw image data. I'll say with open images, and I'll start off with property 7, just because as we saw, that one is particularly egregious. I'm going to read the contents of that file into an image bytes variable. I'll then make my list of messages. I'll add a user message. And in this case, I'm going to add in one single image. So I'll put in an image part with a format of PNG and a source bytes image bytes. Now there's several nested dictionaries inside of here, so make sure that you've got 1 dictionary, 2, and 3. Then I'm going to provide the prompt written above as a separate text part. So I'll put in text with prompt. Then I'll get my response from calling chat with messages and just print out the text response. Let's see how we do. All right, so here is my response. And if I scroll down, yes, as expected, I got a severe risk here. And if we want to, we could, of course, read over all the reasoning behind this. I would like to try this out with one of the other properties. So let's do property 3, which does not have a lot of stuff around it. So hopefully we'll get a good result there. I'm going to update the image to prop3.png and rerun this. And with that hopefully better property, we've got a now moderate risk. So let's see, the reason it didn't like it was it does have clusters of trees around the perimeter. I think that this is a prompt issue. I think Claude is being a little bit cautious here and saying, hey, there's kind of these groupings of trees like over here. I don't know. Okay, let's be honest here. I don't know anything about fire risk analysis, but presumably this is kind of okay. There's a big setback from the house. So we might want to relax the requirements in the prompt a little bit and make it a little bit more clear that, hey, maybe if the trees are away from the house, then this would qualify as a 1. So here's a scenario where we might adjust the prompt, but at any rate, it's very clear that Claude is very easily understanding the image, even though it is quite grainy and kind of hard to figure out what's actually exactly going on inside of it. Before we move on, there is one more thing I want to repeat very quickly. Whenever you are making use of images with Claude, you do not want to fall into the trap of using very simple and basic prompts. Instead, you want to remember all those different prompt engineering techniques we learned about earlier on inside the course, because providing a strong prompt is going to dramatically increase Claude's ability to read and understand your images. Besides reading images, Claude can also very easily read the contents of a PDF document as well. Let me show you a quick example of this. First, attached to this lecture, you'll find a PDF file named earth.pdf. This is a printout of the first 3 pages of the Wikipedia article on Earth. So it just has a couple of different facts around Earth and our entire planet and whatnot. Make sure you download this attachment and put it in the same directory as your notebook. So if my notebook is inside of this directory right here, I should see earth.pdf right next to it. Then, to read the contents of that PDF and chat with it, all we have to do is change a couple of different properties in this exact same code that we have right here. So first, rather than opening up that image, I'm going to instead open up /earth.pdf. Then, just to kind of do things right here, we shouldn't really call this image bytes anymore. I'm going to rename it to be file bytes. And I'll make sure that I update the name down here as well. Now, here's the only tricky part. We need to make a couple of updates to this structure right here, specifically the image part. So I'm going to first change image to document. I'm going to change the format to PDF. And then right after the format PDF, I'm going to add in another key value pair with a name of Earth. So the idea here is that this is supposed to be the name of the file that you are attaching, but without any extension. So there should not be a earth.pdf, it's just Earth by itself. Then we can update our prompt I'm going to put in a hard-coded string right here. I'll ask Claude to summarize this document in one sentence. Then I'm going to run this, and we'll see what we get. All right, so clearly Claude was able to read that PDF, take a look at all the content inside of it, and give us some reasonable response. Reading the contents of a PDF can be incredibly useful, especially when you combine it with another feature that we'll take a look at in just a moment called Citations. Now that we've got a simple example of Claude's PDF reading ability, let me show you one additional feature that's going to give you a better understanding of why giving Claude a PDF is really useful. You see, a common problem around consuming information from a PDF is that users often have to take it on faith that the model is correctly interpreting the contents of the document. Now, Claude has a feature known as Citations that directly addresses this issue. So let me show you how it works. We're going to first go through just a little bit of setup. So the first thing I want to do is open up our earth.pdf document again. I'm going to go down to the very bottom page. And the last page here, you'll notice, is all about the formation of the Earth. So the formation of the Earth itself and its atmosphere. Next, I'm going to go back over to my editor. I'm going to update the text I'm sending off to Claude. I'm going to change my query to how were Earth's atmosphere and oceans formed. Then on the document dictionary, I'm going to add in an additional field of citations enabled true. And finally, down at the very bottom, rather than just printing out the response text, I'm going to print out the entire response. I'm going to run this, and let's see what we get back. The response we get back is going to have many different parts inside of it. The first part that we see is one that we've seen many times before. It is a text part that contains plain text. But after that, we get a part that we haven't seen previously, called citations content. Let me help you understand what this new part is all about. The best way to understand this is to look at a quick demonstration. So I took that response you saw inside my editor just a moment ago, and I reformatted it using Claude into this nicely formatted document. All the plain text you see in here is all coming from the different text parts inside the response I just got back. But in addition, you'll notice I also have little numbers scattered throughout. These are serving as citations, and they are represented inside the response by those citation parts we just saw. If I mouse over one, I'll get some information about why Claude decided to make this statement. So specifically, why it decided to say that statement right there. In short, Claude is citing a source and telling us exactly where from this source PDF it is pulling the information that is supporting that statement. So in this case, Claude is saying that it looked into the earth.pdf file, and on page 4 in particular, it found some text to support this statement. We have many different citations inside of this example. So in my case, I got 7 in total. The reason that this citations feature is so useful is that it gives your users confidence in the answers that Claude is generating. If a user wants to, they can go back to the source PDF and verify the information that led Claude to making particular statements. The next feature that we are going to focus on is prompt caching. Prompt caching is used to speed up Claude's response and decrease the cost of text generation. To help you understand how prompt caching works, we're going to walk through what happens inside of Claude during a typical request that we make without any kind of prompt caching enabled at all. So again, this is just a normal request. Now we've already spoken a little bit about normal requests and the entire flow, but don't worry, this time I'm going to add in a little bit of detail on what happens inside of Claude itself. As usual, everything begins with us sending a message off to Claude. And when Claude receives this message, before actually generating any output text at all, it does a tremendous amount of work on the input message. In other words, Claude is going to internally create a tremendous number of internal data structures and do a tremendous number of calculations solely on the input text. It will then eventually generate the output text using all that earlier work it did, and then send a response back to us in the form of some assistant message. After the response is sent off to us, Claude is going to then take the output text and the result of all those earlier calculations that were done on the input message and just throw them all into the trash. Away it all goes. We see all that work kind of go up in smoke entirely. Once Claude has gone through all that cleanup, it declares to the world, I am ready to process the next request. Now, let's imagine for a moment that after making this initial request, we then make a follow-up request. And in this follow-up request, let's just imagine that we are continuing this conversation. So we're going to attach a list of messages. The first one will be the exact same message we had sent in a moment ago. and then the assistant message response we got back, and then some new user message that we're going to attach just to further the conversation along. So we're going to take all these messages and send them into Claude. And internally, Claude is probably going to be a little bit frustrated when it sees that first message. Because Claude is going to see that first message and think to itself, of course, this isn't quite what happens. We can imagine this is kind of what's going on behind the scenes. Claude is going to see that first message and say, I just saw this message. I just did so much work to process it. And then I threw away all those calculations. And Claude is going to think to itself, I really wish I could reuse all that work that I did just 10 seconds ago and threw away. If Claude had saved that work that it threw away just a moment ago, it would probably be able to send us back a response much more quickly because it doesn't have to repeat all that work. So now that we have seen this problem, let's think of some possible way to solve it. Well, here's one possible way that we could handle this problem. Maybe we could say that whenever we make an initial request off to Claude, and Claude goes through all that initial work on our user message that we are sending in, rather than taking the result of all that analysis and throwing it into the trash, maybe we could instead cache all that work or put it into some temporary data store. Then, if we ever make a follow-up request and we include the exact same input user message, Claude could go into its cache and say, hey, I just saw this exact same message a moment ago, and I saved the work of all the analysis around that particular message. So rather than reanalyze the message again, it could reuse all the work that it did previously. And hopefully, this would dramatically speed up the process of generating some amount of text because, again, we are reusing some work that we had already done. This idea of saving some work from a request to be used later on is exactly what prompt caching is all about. So let's come back in just a moment, and we're going to walk through some of the implementation details of prompt caching and really understand how it is implemented by Claude. Now that we understand the theory, we are going to explore how prompt caching Claude actually works. The core idea of prompt caching is identical to what we discussed in the last video. We will make an initial request off to Claude. Claude is going to do some processing on that initial message, and then Claude is going to save all that work into a temporary cache. Then, if we make a follow-up request at some future point in time and include the identical exact same message, rather than processing that message all over again, Claude is going to instead look into the cache, find the work that it had already saved, and load it up. Just to be clear, the work that we saved to the cache does not persist forever. It is only stored there for 5 minutes. You're going to find prompt caching is most useful anytime that you are repeatedly sending the same content over to Claude again and again and again, because it really is this kind of two-phase process. We have to make that initial request to write some data into the cache, and then only the follow-up requests are going to be able to take advantage of that work that was done ahead of time. To enable and control prompt caching, we are going to make use of a new type of message part called a cache point. So by default, there is no prompt caching enabled with Claude. We have to add in these additional new types of parts into our different messages. You might recall that we have other types of parts we've already discussed, like a text part and an image part and so on. So this is just yet another type of message part that we're going to need to understand. When we include a cache point inside of a message, we are telling Claude that we want to cache all the work that is done for all the text up to that point inside of our message. Now that's really confusing to hear in just plain words, so let me, as usual, show you a quick diagram here. All right, so let's imagine that we have an initial request that we send off to Claude. We have a text part, then a cache point, and then another text part. As usual, because this is an initial request, Claude is going to go through some amount of work that is done to process the first text part and the second text part. And we're going to visualize that with this box right here and this box right here. Because we put the cache point in between these two parts, everything before this cache point is going to be cached. So in other words, this work right here, it's going to be cached. But everything after the cache point, in other words, this right here, is not going to be stored in cache. If we then make a follow-up request where that initial text part is identical to the one we had sent previously, so here's that same exact text part right here that is above the cache point, rather than trying to process that chunk of text again, Claude is going to see if it already has something stored inside of the cache. In this case, it does. So it's going to reuse this bit right here. Claude is not going to look into the cache to see if it has already processed these other text parts previously because they are all listed after this cache point. Now, a key point to understand here is that the caching system is only going to work if everything before the cache point is identical. So in this case, Before the cache point, I have one text part that says exactly summarize this long text and then whatever text we want to summarize. If we instead made a follow-up request where the text part was slightly different, if it said something like, please summarize this long text, well, this text part is now different. So Claude would not attempt to use this cached work that it had previously generated. Instead, Claude is going to ignore the cache and generate a new analysis or go through all the work once again on this brand new text part that it has not seen previously. The next thing to understand is that cache points are not limited to just one single message or one single text part. They can be used to store work that is done on multiple different messages, multiple different parts, even assistant messages. For example, if we make an initial request like the one you see right here, where we have our cache point all the way down here at the bottom, Claude is going to process all the different text parts across all the messages before it. We're going to get some intermediate work like what you see, and then Claude is going to cache all that over here. Then if we make another follow-up message with the exact same text parts across all the different user message, assistant message, user message, we're going to reuse this cache. So here's our follow-up request. Again, we have everything identical before the cache point. We're going to reuse all that work that we had done ahead of time. Before we move on, there are two other very quick ideas I want to share with you around prompt caching. First, there is a minimum amount of content required for Claude to cache its work. There must be at least 1,024 tokens worth of content before a cache point in order for Claude to actually cache its work. So in the first example up here, the only content that we have before the cache point is a single text message of hi there. That is definitely not 1,024 tokens long. So in this case, we are not going to write anything to cache. But down here, if I've got hi there, hi there, hi there repeated 500 times or so, that is probably going to be greater than 1,024 tokens worth of content. So all the different text parts right here, the result of processing all of them is going to be cached, and we can make use of that cache on follow-up requests. The other big item that I want you to be aware of around prompt caching is that we are not limited to just caching message parts. We can also put in cache points on tool definition lists, so the actual list of schemas that we pass in, and we can also provide cache points on system prompts as well. So, for example, when we pass in a list of tools, the actual tool specs, where we write out all that JSON, can end up being rather long, and they count towards our token budget for any given request. So when we pass in our list of tools, we might put in all of our different JSON schema specs and then a cache point right after it. The same thing can be done for a system message as well. We can pass in a text part that includes the actual system prompt that we want to cache, and then right after that, a cache point. Now, even though I'm tossing this idea of caching the tool schemas and system prompts towards the end of this video, this actually ends up being one of the more common locations where you are going to implement prompt caching. Because in reality, it's rather rare that we are going to change our list of tools or even the system prompt between requests. So because we are going to very often make the same request with the same exact list of tools and system prompt, you're very often going to want to put in cache points. All right, so now that we understand all this theory around prompt caching, it's time to actually get our hands dirty by writing out some code. Let's come back in the next video and test out prompt caching inside of a Jupyter notebook. Let's get our hands dirty with prompt caching and just write out a little bit of code to play around with it and understand how it works. I'm inside of a new notebook called 003_caching. I have a lot of the very same setup code that we've used several times before, but I've added in two new sections here. First, I've added in a cell with a rather long prompt. It's got about 6,000 tokens inside of it. I've also got a set of tool schemas. These are the same schemas we worked on earlier on inside the course. So I've got add duration to date time, the set reminder schema, and the get current datetime schema as well. In total, all of those schemas put together are about 1,200 tokens. So both the prompt and the schemas total up to definitely being above the minimum threshold for prompt caching, which again is 1,024. The first thing I want to do to change this notebook is open up our helper functions, and I want to make a change to our chat function. In particular, I want to enable caching by default for our system prompt. So if we ever pass in a system prompt, I just want to cache it no matter what, because again, we usually don't change the system prompt too often, and it's usually consistent between requests. And then for a similar reason, I always want to cache the list of tools as well, or specifically the tool schemas. And then finally, on our return statement down here, I want to include the usage field from the response object that we get back whenever we make our request. This usage object that we're going to include in here returns some information related to prompt caching, so we can use it to inspect and figure out whether or not we are successfully caching input that we're feeding into Claude or not. All right, so let's get to it. We'll start off first by making sure that we always cache our system prompt. So to do so, all we have to do is expand this list of parts, and we're going to add in a new part here, our cache point part. And that's going to have a type of default. And that's pretty much it for the first to do. So I'm going to mark that one as complete. Second, for caching our list of tools, I'm going to make a new variable here, tools with cache, and that's going to be our list of tools. And I'm going to concatenate in a new part of cache point type default. And then I'll make sure that I pass off tools with cache as our list of tools. So make sure we update that right there. Okay, that's all we have to do to enable caching for our tool list. And then finally, down here at the bottom with my response, I'm going to add in a new usage. That will be just this plain exact usage property from the response. So we're just going to essentially pass that right through. Okay, so that's really it for enabling prompt caching across a huge part of our application. So now both our system prompt and our list of tools are going to be cached. So I'm going to rerun that cell. And then we'll go down here to the bottom. And then after I get back a response, I'm going to print out the responses usage. Next up, I'm going to provide a system prompt right here. I'm going to use the prompt that I had included on that earlier cell. So code prompt, I want to include that as my system prompt. So I'll pass that in like so. And then I will put in a very simple text message here. So I'm just going to say something like, summarize the design spec in one sentence. So the intent here is to just pretty much summarize everything that's inside of that giant code prompt. I don't really care about the text prompt here at all. All I really care about right now is demonstrating prompt caching to you. So again, I just really care about the usage field here. Okay, I'm going to run this, and we're going to see something interesting. The usage field is going to have a cache read input tokens and a cache write input tokens. Because this is our very first request where we have never submitted this particular system message before, we are going to write some information to the cache. So Claude did a lot of work to analyze all the text inside this giant system prompt right here that we are providing. And then it stored the result of all that work into the cache, and it took up 6,322 tokens. So if we now make a follow-up request within the next 5 minutes, my expectation would be that we're not going to see a cache write. And instead, we're going to see a cache read, because now we're going to try to use all that work that we already did ahead of time in analyzing that system message. Okay, so I'm going to run this. And again, hopefully we're going to see a cache read because we are consuming something out of the cache. And sure enough, there we go. Now we're going to continue to see something from cache read right here, as long as we do not change our system message, so the content before our cache point, and as long as we don't go for a gap of 5 minutes, because as soon as we go over 5 minutes without making a request, that cache entry is going to be automatically cleared. So now the next thing I would like to do is just try changing our input text right here really quick. So I'm going to say, summarize the design spec in one sentence, period. It's the only change I'm going to make. Now at this point in time, the system message occurs semantically above this text part right here. So even though I changed the text part, the cache point that we have for our system message is above this piece of text. So I should continue to see a cache read, even though I changed part of this user message, because I am reading the cache version of the system prompt. And there we go. Next up, if we go and change our system prompt in some way, so maybe I come up to this very first line right here and just put a period at the end. Now I have a very different system prompt in the eyes of Claude. So if I run this, and then run the bottom cell again, now that I am feeding in different content for the system prompt, no more cache read, instead it turns into a cache write, because that content has changed. If I run it again, now we're going to have a cache read, because we cached the changed version of that prompt. Now, I know this is going really quickly, and I'm using a lot of terms here in very quick succession, but I think if you personally play around with the caching system a little bit, you're going to get a sense of what's going on really quickly. Now, the last thing I want to show you is caching tool use. So with the change we made to our chat function, all we really have to do is add in a list of tools. And remember, we have some of those different schemas like add duration to date time schema. We have set reminder schema and get current date time schema. So once again, if we send this off, now we're going to see an even larger cache write because now we are caching both our schemas and the system prompt as well. All right, so that is prompt caching. Again, we are going to very often want to cache our system prompt and our tool schemas because they are very often going to be longer than that 1024 token cutoff. And by enabling prompt caching, we're going to pay less for our generation, and the text generation is most often going to run a little bit faster. In this module, we are going to focus on Model Context Protocol. MCP is a communication layer designed to provide Claude with context and tools without requiring you, the developer, to write a bunch of tedious code. When you first get started with MCP, you will see diagrams that look like this very often. It shows two major elements of MCP, namely the client and the server. The server often contains a number of internal components, named tools, resources, and prompts. Now, there's a lot of terminology here, so to help you understand all of this, we're going to imagine that we are building a small app and see how MCP fits into it. Our sample app is going to be another chat interface. It's going to allow a user to chat with Claude about their GitHub data. So if a user asks a question like, what open pull requests do I have across all my different repositories? The expectation is that Claude is probably going to make use of a tool to reach out to GitHub, access the user's account, and see what open pull requests they have, maybe open repositories or whatever else. The point here is that we would implement this probably by using a set of tools. Now, one thing I want to mention really quickly is that GitHub has a tremendous amount of functionality. There are repositories, pull requests, issues, projects, and tons of other things. So to have a complete GitHub chatbot, we would really have to author a tremendous number of tools. If we wanted to build that sample app, we would be on the hook for authoring all these schemas and all these functions. And this is all code that you and I, as developers, would have to write, test, and maintain. That's a lot of effort, a lot of burden being placed on us. This challenge of making developers maintain a big set of integrations is one of the primary difficulties that Model Context aims to solve. MCP shifts the burden of defining and running tools from your server to something else called an MCP server. So no longer would you and I have to author this tool right here. Instead, it would be authored and executed somewhere else inside of this MCP server. These MCP servers can really be thought of as like an interface to some outside service. So I might have a GitHub MCP server that provides access to data and functionality provided by specifically GitHub. We're essentially wrapping up a ton of functionality around GitHub and placing it into this MCP server in the form of a set of tools. So at this point, we have a very basic understanding of what a MCP server is. It gives us access to a set of tools that exposes functionality related to some outside service. And the benefit here is that you and I do not have to author all these different tool schemas and functions and so on. Now that we have this basic understanding, I want to address some very common questions that a lot of people have when they first learn about MCP servers. So 3 common questions that seem to always come up. The first common question is, who authors these MCP servers? And the answer is anyone. Anyone can make an MCP server implementation. But very often, you will find that service providers make their own official implementation. So for example, AWS might decide to release their own official MCP server implementation, and inside of it, it might have a wide variety of different tools available for you to use. The second common question is, how is using a MCP server different than just calling a services API directly? Well, as we just saw, if we wanted to call a API directly, such as GitHub, then we would have to author this tool ourselves. And now we can call GitHub directly. So what did we gain here? Well, all that really changed was we are now having to author the schema ourselves and the function implementation ourselves. So simply by adding in the MCP server, we are saving ourselves a little bit of time. The final common question is more of a common criticism that you're going to see people have around MCP. And this criticism is most often coming from people who don't quite understand what MCP is all about. So very often you will see people saying MCP and tool use are the same thing. Well, as I have just laid out to you, MCP servers and tool use, they are complementary. They are different things, but they are complementary. The idea behind MCP is that you do not have to author the tool function and the tool schema. That is something that's done for you by someone else and is being wrapped up inside of this MCP server. So at some level, yeah, they're kind of similar because we are talking about tool use in both cases, but MCP servers are really talking about who is doing the actual work. So if you ever see this criticism, again, it's usually because people don't quite understand what MCP is all about. The next portion of Model Context Protocol that we're going to investigate is the client. The purpose of the client is to provide a means of communication between your server and a MCP server. This client is going to be your access point to all the tools implemented by that server. Now, MCP is transport agnostic. This is a fancy term that just says that the client and the server can communicate over a variety of different protocols. A very common way to run a MCP server right now is on the same physical machine as the MCP client. And if these two things are running on the same machine, then they can communicate over standard input-output. And that's what we are going to be setting up later on inside this section. There are, however, other ways we can connect the MCP client with the MCP server. So they can also connect over HTTP or WebSockets or any of a number of other varieties or techniques. Once a connection has been formed between the client and the server, they communicate by exchanging messages. The exact messages that are allowed are all defined inside of the MCP spec. Some of the message types that you and I are going to be focusing are the list tools request and the list tools result. As you guessed, list tools request is sent from the client to the server, and it asks the server to list out all the different tools that it provides. The server would then respond with a list tools result message, which contains a list of all the different tools that it can provide. Two other common message types that you and I are going to see are the call tool request and call tool result. The first will ask the server to run a tool with some particular arguments, and the second will contain the result of the tool run. Now, at this point in time, we've got this idea of a server and a client, but I suspect it's probably not really clear how all this stuff really works together. So here's what we're going to do in the remainder of this video. We are going to walk through an example call between a lot of different things. So this will be kind of an involved process, but we're going to imagine the communication that goes on between a user, our server that we're putting together, a MCP client, a MCP server, GitHub as some provider that we're trying to access some data from, and Claude. So let's get to it, again, step by step. First thing we would expect to happen is a user to submit some kind of query or question to our server, like what repositories do I have? At this point, it would be up to our server to make a request off to Claude. But in that request, we want to list out all the different tools that Claude has access to. So before our server can make the request off to Claude, it's first going to go through a little side detour through the MCP client and the server. So here's what happens. The server is going to realize that it needs to see a list of tools to send off to Claude along with the user's query. So it's going to ask the MCP client to get a list of tools. The MCP client, in turn, is going to send a list tools request off to the server, and the server will respond with a list tools result. Now that our MCP client has a list of the tools, it will give that list of tools back to the server. And now our server has everything it needs to make an initial request off to Claude. It has both the original message from the user and a list of tools to include. So our server can make a request off to Claude with that query and the set of tools. Claude is going to take a look at the tools and realize, you know what, in order to answer the user's original question right here, I really want to call a tool. So Claude would respond with some tool use message part. At this point, our server is going to realize that Claude wants to run a tool. But our server is no longer really in charge of executing any tools. Instead, our tools are going to be executed by the MCP server. So in order to run the tool that Claude is asking for, our server is going to ask the MCP client to run a tool with some particular arguments that were provided by Claude. The MCP client, however, doesn't actually run the tool. It's going to send a call tool request off to the MCP server. The MCP server will receive that request and make a follow-up request off to GitHub. So this is where we would actually be getting a list of repositories that belong to this particular user. GitHub would respond with that list of repositories. Then the MCP server would wrap up that data inside of a call tool result and send that back to the MCP client. Then the MCP client in turn would hand the result off to our server. Now our server has the list of repositories and it can make a follow-up request to Claude with the tool result part inside of a user message. So this tool result would include the list of repositories that Claude was asking for. And now Claude has all the information it needs to formulate a final response. So it'll write out some text of something like your repositories are, and then send that back to our server, and our server would send it on back to our user. All right, so this flow, yes, it is rather complicated. The reason I want to show you this is that we are going to see all these different pieces as you and I start to implement our own custom MCP client and MCP server a little bit later on. To better understand some aspects of MCP, we are going to start to implement our own CLI-based chatbot. This is going to give us a better idea of how clients and servers actually work together. In this video, I want to do a little bit of project setup and just help you understand exactly what we're going to make. I've got a lot of product description over here of what we're going to build. We're going to go through all this over time. For right now, I just want you to get a high-level understanding. So as I mentioned, it's going to be a CLI-based chatbot. We're going to allow users to work with a collection of documents. These are going to be fake documents. They're just going to be stored in memory. We're going to build out a small MCP client that is going to connect to our own custom MCP server. For right now, this server is going to have two tools implemented inside of it. One tool to read the contents of a document, and one tool to update the contents of a document. Now again, these documents are here on the right-hand side. They're all fake, so they are going to be persisted only in memory. That's it. Now, before we go any further, there is a very important note, something I really want you to understand around this entire process. And that is that on a normal project, typically we would be implementing either a client or an MCP server. So on a real project, we might be authoring just an MCP server to distribute to the world and allow developers to access some service that we have built up. Alternatively, we might be building a project where we make only a MCP client. And the intent here would be that we would be connecting to some outside MCP servers that have already been implemented by some other engineers. So in this project, we are making both a client and a server. And we're just doing that in one project so you get a better understanding of how this stuff actually works together. All right, now that we have this disclaimer out of the way, let's go through just a little bit of setup. Attached to this video, you should find a file named cliproject.zip. Inside there is some starter code for our project. Make sure you download that zip file, extract it, and then open up your code editor inside of that project directory. Just to save a little bit of time, I have already done so. So I've already got my code editor open inside of that small project. Inside this project, I would encourage you to take a look at the README document. I put in some setup directions inside of here, and it's really critical that you go through these setup. You're going to do a little bit of environment variable configuration by specifying the Bedrock region and a model ID. The region and the model ID can be the exact same one that you used previously inside of all of our different Jupyter notebooks. And then after that, you're going to go through a little bit of dependency installation. So all you have to do is set up a Python environment, install a couple of packages, and that's it. Once you have gone through all this setup, you can then run the starter project right away. To do so, inside of your terminal, make sure that you are inside of your project directory. So I called my project MCP, and inside there, I've got all my different project files and folders. To run the project, we will run uv run main.py if you're making use of uv. If you are not making use of uv, then it'll be just python main.py. Now I'm making use of uv, so I'm going to do a uv run main.py. And then when I run that, I should see a chat prompt appear. And if I ask what's 1 plus 1, I should see a response rather quickly. That is it for our setup. So now we can start to focus on adding in some new features to this application. Let's start to make an MCP server for our CLI chatbot. As you saw, the CLI itself already works, and we can already chat with Claude, but there's no additional functionality around an MCP server tied to it just yet. So we're going to work on adding in this MCP server that is going to have two tools in it for right now. It's going to have one tool to read a document and one tool to update the contents of a document. The implementation of this server is going to be placed into the mcp server.py file inside of the root project directory. Inside of here, I've already gone through a little bit of work to set up a basic MCP server. And then I defined a collection of documents that are going to exist only in memory. And then finally, I put together some different to-do items. So these are different tasks that you and I are going to complete inside of this file. For right now, as I just mentioned, we're going to be working only on these first two items, writing out two tools. Now we have authored tools in the past, and we saw that Well, there's a lot of syntax there. Those big JSON schemas. But I got good news for you here. In this project, we're making use of the official MCP Python SDK. So that's what this MCP package is that we're making use inside of here. This MCP package is going to create our MCP server for us with just one line of code, like what you see right there. This SDK also makes it really easy to define tools. To define a tool, all we have to do is write out what you see on the right-hand side over here. This will make a tool named addIntegers with this description and two arguments that are going to be required to be passed into it. Once we write out a tool definition like this, behind the scenes, MCP is going to generate a tool JSON schema for us, which we can then take and then pass off to Bedrock. So right away, as you can see, it starts to get a lot easier to do some basic things like define tools. Now, as I mentioned, our first task is going to be to implement these two different tools. So let's go back over to our MCP server.py file right away, and we're going to start to implement the first tool of reading a document. So the only goal here is to take in the name of some document and return the contents of it. All of our documents are already placed inside of this docs dictionary. The keys are the IDs, or essentially names of a document, and the value is the document's contents. So our tool is really simple. We're going to take in one of these strings, look up the appropriate value inside this docs dictionary, and then return it. That's all we need to do. So to implement this, I'm going to find the first to-do, and right underneath it, I'm going to define a new tool by writing out @mcp.tool. I'm going to give this tool a name of read_doc_contents and a description of read the contents of a document and return it as a string. Now remember, in a perfect world, we would put in a really fleshed out description right here to make sure it's super clear to Claude exactly when to use this tool. But for right now, just as usual, to save a little bit of time and keep you from having to type out a bunch of text here, I'm just going to leave in a very simple description. Then I will define my actual tool function. So this is the function to run whenever we decide to run this tool. I will call it read document. It's going to take in an argument of doc ID that is going to be a string. I'm going to set that to a field with a description of ID of the document to read. And then we need to make sure that we import this field class at the top. So I'm going to go up to the top and add an import from Pydantic import field. Then back down here, inside of the function body, I'm going to put in my actual implementation. So the first thing I'm going to do is just make sure I handle the case in which Claude asks for a document that doesn't actually exist. So I'll say if doc ID not in docs. So in other words, if the provided document ID is not found as a key inside of this dictionary, then I'm going to raise a value error with a f string of doc with ID, doc ID not found. And then if we get past that check, I'll go ahead and return the actual document. So I'll return docs at doc ID. And that's it. That's all it takes to define a tool. So we've specified the name of the tool, its description, the argument that is expected, its type, and a description for that argument as well. All these different decorators and field types and whatnot are all going to be taken together by this Python MCP SDK, and it's going to generate a JSON schema for us. Now that we've implemented this first tool, I'm going to remove the to-do right there, and then we will implement our other tool, the one to edit a document. So we're going to repeat the exact same process. I'll say mcp.tool. I'll give it a name of edit document with a description of edit a document by replacing a string in the document's content with a new string. Then for the implementation, I'll call this function edit doc. Actually, we'll be consistent, call it edit document. And then we're going to take in a couple of different arguments here. First is going to be a document ID, and then a old string to find, and then a new string to replace the old string with. So let's write this all out. We're going to have a doc ID that will be a string with a description of ID of the document that will be edited. Old string will be a string with a description of the text to replace must match exactly, including white space. and then our new string, the new text to insert in place of the old text. So our document editing here is just a very simple find and replace. That's it. Once again, inside of here, I'm going to make sure that Claude is asking for a document that actually exists. So if doc ID not in docs, raise value error with a f string of doc with ID not found. And then if we do find the correct document, here's how we will do our edit. We'll say docs at doc ID is docs at doc ID, replace old string with the new string. And that's it. All right, so just like that, we have put together 2 tool implementations really, really quickly. I can't repeat it enough. Defining tools with this MCP Python SDK is a lot easier than writing out the schema definition manually. Now that we've got both tools put together, I'm going to delete the to-do right there. Okay, so this is a good start. We have put together our MCP server and we've implemented 2 tools inside of it. We have put together some functionality inside of our MCP server, but we have no idea if it works. So it'd be really great if we could test this out somehow. It turns out that by using this Python SDK, we automatically get access to a in-browser debugger, so we can make sure that this server is working as expected. Let me show you how to use it really quickly. Back inside my terminal, I'm going to make sure that I have my Python environment activated. Remember, the README document goes into detail on the exact command to run to make sure that you have activated that environment. Once you are sure that it is activated, we'll run mcp dev and then the name of the file that contains our server. In this case, it is mcp server.py. Once I run that, I'll then be told that I have a server listening on port 6277, and I'll be given a direct address to actually access it. I'm going to open up that address inside my browser. And once you go there, you'll see something that looks like this. This is the MCP inspector. Now, right away, there's something important I want you to understand here. This inspector is in active development. So by the time you are watching this video, what you see on the screen right now might be very, very different than what I am showing. Nonetheless, it's probably still going to have some very similar functionality. On the left-hand side, you'll see a connect button. That is going to start up your MCP server. So that file that we just edited. I'm going to click on connect, and then right away, we'll see a couple of different things on the screen appear. I first want you to notice the top menu bar up here. It lists out resources, prompts, tools, and some other stuff. Again, the UI might change by the time you watch this video, so if you do not see this menu bar up here, all we are really looking for here is some tools section. Once I click on tools, I will click on list tools, and we'll see the name of the tools that we just put together. If I click on one, the right-hand panel is then going to change. And I can use this panel over here to manually invoke one of my tools to make sure that it is working as expected. So this is how we can do some live development on our MCP server without actually having to wire it up to a real application. In order to use the read doc contents tool, all we have to do is put in a document ID. If I go back over to my editor and go up to the docs dictionary right here, I can copy one of these document IDs. So I will take out deposition.md. I will put it in as the doc ID and then click on Run Tool. I should then see Run Tool of success with the contents of the document. And that is it right there. I can verify it. It's the same exact string as what I see right there. We can use this same exact technique to test out the other tool as well. So I will change over to the Edit Document tool. Now I'll put in my document ID. My old string that I want to replace, how about we replace the word deposition? Actually, how about an easier word to type out? How about just this? That'll be a little bit easier. So my old string is this. Remember, that is going to be capital sensitive, and I'm going to replace it with a report. And if I run the tool, I'll then be given a success. Remember, that tool does not actually return the document's contents. It just edits the document. So now to verify that the edit was done correctly, I can go back over to the read doc contents tool, run that one again with the same document ID, and I should see a report deposition, and then blah, blah, blah. All right, so as you can see, this MCP inspector allows us to very easily debug a MCP server that we are implementing without actually having to wire the server up to an actual application. As you start building your own MCP servers, I expect you'll be using this inspector tool quite a bit. And we'll probably use it a little bit more inside of this module just to make sure that our server development is going along pretty well. Now that our server is in a good place, we're going to shift gears a little bit and start working on our MCP client. The client can be found inside the MCP client.py file inside the root project directory. Now, before we do anything inside this file, I just want to give you a very quick reminder here. Remember what I told you about earlier. Usually in a typical project, we are either making use of a client or we are implementing a server. It's just in this one particular project that we're working on that we are doing both. Again, just so you can see both sides of the puzzle. Now, the MCP client itself inside of this file is consisting of a single class. You'll notice there's a lot of code inside of here, and it doesn't look quite as pretty as some of the code we just wrote out inside of the server. So let me tell you exactly what's going on inside this file and exactly why it is so large. Okay, so inside this file, we are making the MCP client class. This class is going to wrap up something called a client session. The client session is the actual connection to our MCP server. This client session is a part of the MCP Python SDK. So again, this session is what gives us this connection to the outside server. The session itself requires a little bit of resource cleanup. In other words, whenever we close down our program or decide that we don't need the server anymore, we have to go through a little bit of a cleanup process. And I have already written out a lot of that cleanup code inside of the MCP client class. So that's really why this class exists at all, just to make that cleanup a little bit easier. You can see some of that cleanup code inside of the connect function and down a little bit lower at the cleanup, async enter, and async exit functions as well. So it's very common practice to not just make use of this client session directly. Instead, very common to wrap it up inside of a larger class that's going to manage some of this different resource stuff for you. The next thing I want to clarify is why this client exists at all. So in other words, what is the client really doing for us here? Well, remember this flow that we looked at a little bit ago. So we had our code right here, and at certain points in time, we needed, say, a list of tools to send off to Claude. And then later on after that, we also needed to run a tool that was requested by Claude. In order to reach out to our MCP server and get this list of tools or to run a tool, that's where we are making use of the MCP client. So we can imagine that this client is exposing some functionality that belongs to the server to the rest of our codebase. So inside of our codebase, inside this project, specifically inside of the core directory, there is a lot of code already inside there that I put together that is making use of this class. So there's some other code that's going to call some of the different functions you see inside of here, like list tools, call tool, list prompts, get prompt, and so on. For right now, in this video, we're going to focus on implementing two functions, list tools and call tool. So as you just saw in the diagram we looked at a moment ago, these two functions are going to be used in different parts of our code base to get a list of tools to provide off to Claude, and then eventually call a tool whenever Claude requests to call a tool. Implementing these two functions is going to be really simple and straightforward. So let me show you how we're going to do it. We'll first begin with list tools. I'm going to remove the to-do inside there and replace it with result is await self.session. I'm going to call that like a function. List underscore tools, and then I will return result.tools. And that's it. So this is going to get access to our session, which is our actual connection to the MCP server. It's going to call a built-in function to get a definition or a list of all the different tools that are implemented by that server. I'm going to get back result and then just return the tools, and that's it. Then we can implement call tool right here in a very similar fashion. So this will be return await self.session, call tool, tool name, and tool input. Once again, getting access to the session, that is our connection to the server, and I'm going to attempt to call a very specific tool. The name of the tool will be passed in along with the input parameters or input arguments to it that were provided by Claude. Now at this point in time, I would like to test out these two functions really quickly. To do so, we're going to go down to the bottom of this file where I put together a very small testing harness for us. So down here, you'll notice I put together this testing block. So we can run this MCP client.py file directly. And if we do so, we're going to form a connection to our MCP server, and then we can just run some commands against it and just see what we get back. Notice that in your version of the code, there's a comment in there about changing the command in args right here in case you are not making use of UV. So if you're not using UV, make sure you take a look at that comment. Inside of this with block, I'm going to add in a little bit of testing code. So I'll say result is await underscore client list tools, and then I'm going to just print out the result that we get back. So this should start up a copy of our MCP server, then attempt to get a list of all the different tools that are defined by it, and then just print out the result. To test this out, I will flip back over to my terminal and do a uv run mcp underscore client.py. And as usual, if you are not making use of uv, you'll just do a python mcp client.py. Okay, so I'll run that, and there is our list of tool definitions. So I can see inside of here that I have the read doc contents tool, which we put together a little bit ago, and our edit document tool as well. Each one has a description and a input schema as well. So this is our tool definition, which will eventually be passed off to Claude. Now there's one very small gotcha here that you're probably going to run into when you start working on your own project. When you take a look at input schema, you might notice that the structure of it, if you've got a really careful eye, it doesn't really look exactly like what a Bedrock JSON schema is expected to look like. In other words, the structure here is just a little bit different. So again, this is a gotcha. It's a little bit of a trap that you just need to be aware of. The MCP spec has its own definition of what a tool looks like, and that is slightly different than what Bedrock considers a tool definition to look like. So somewhere inside of our code, we really have to take this tool definition right here and convert it into the exact structure that is expected by Bedrock. I have already written out the code to do that for us. So back inside of our editor, if you open up the core directory and then bedrock.py, inside of here, this is all of our code related to running Bedrock and communicating with messages and so on. And if you scroll down towards the bottom, you will notice that there is a function inside of here called toBedrockTools. So this will take in that list of tools that we just saw printed out, and then for each tool, it's going to convert it into the structure that is expected by Bedrock. Once again, this is just a little bit of a gotcha, just something you need to be aware of. This conversion process is already being done automatically somewhere else in the code base for us. So we don't have to worry about calling toBedrockTools inside of the code that you and I are writing right now. I just want you to be aware that yes, we do have to go through this little bit of a translation step. Now, before we move on, there's one other thing I want to test. Remember, we just implemented the function that's going to allow us to list out some tools and pass them off to Claude, and the function that's going to allow us to call a tool that is implemented by the MCP server and then pass the result off to Claude as well. I have already implemented the code that is going to call list tools and call tool for us somewhere else inside this project. So now that we have added in this functionality, now that we have defined these tools and the ability to call a particular tool, we can now run our CLI again and attempt to get Claude to make use of these tools. In other words, we can ask Claude to inspect the contents of some particular document and even edit a document. So let me show you how we do that. Inside of my MCP server, I just want to give you a reminder that there is a document with an ID of report.pdf, and it has some text here of something like a 20-meter condenser tower. I'm going to go back over to my terminal, and I'm going to run my project with a uv run main.py, and then I'm going to ask Claude what is the contents of the report.pdf document. And make sure you put in exactly report.pdf here. And when we run this, we're sending off, along with the request, our list of tools. Claude is going to decide to use the read document tool, and it's going to get the contents of the document, and then we will see that, yes, Claude was able to get the contents of that document. We are told that the report is something about a 20-meter condenser tower. All right, so at this point, we have added in some functionality around our client. Remember, the client is what allows us to access some functionality that is implemented inside of the MCP server. At this point in time, we have been able to list out some tools that are created by the server and execute a tool that has been implemented by the server. In this video, we're going to move on to the next major feature inside of MCP servers, which is resources. To help you understand resources, we're going to be implementing another feature inside of our project. Here's what we're going to add in. I want to allow a user to mention a document by putting in an @ symbol and then the name of a document. Whenever they do so, I want to automatically fetch the contents of that document and insert it into the prompt that we send off to Claude. So in total, there's going to be kind of two aspects to this feature. Whenever a user types out the @ symbol inside of a message, we're going to automatically show a list of all the different documents that they can mention inside of a little autocomplete window. Then, whenever a user submits a message with a mention inside of it, we're going to automatically get the contents of that document and insert it into the prompt that we send off to Claude. So, for example, if a user says something like, "What's in the at report.pdf file?" I would want to assemble a prompt like this and send it to Claude. So, we're going to have the query inside there from the user. And then we're also going to tell Claude that the user might have referenced some document, and here is the contents of the document. So the approach here, or the idea here, is that we will not have to rely upon Claude to go and make use of some tool to figure out what is inside of the report.pdf file. Instead, the user can just preemptively mention the file, and we're going to automatically insert some context ahead of time. Now, one thing I want to clarify here is that we're kind of talking about two separate features. The first feature is that whenever a user types in the @ symbol, we really need the MCP server to give us a list of all the different documents that the user can possibly mention. And then the second aspect here is that whenever a user submits a message that contains a mention, then we need the MCP server to give us the contents of a single document. To get this information out of our MCP server, we are going to be making use of resources. Resources allow our MCP server to expose some amount of data to the client. We usually define one resource for each distinct read operation. So in our example, we need to get a list of documents and read the contents of a single document. So we would probably end up making two separate resources. One resource would be responsible for returning just a list of document names, so we can put them inside the autocomplete. And then we would probably make another resource that will expose the contents of a single document based upon its document ID. When we define these resources, they are going to be accessed through our MCP client. So the entire flow that we're going to eventually put together here, whenever a user types in something like "what's in the at," and then presumably they're going to put in something right there, as soon as they type in that at character, we need to display a list of document names to put in the autocomplete. So our code is going to reach out to the MCP client, which in turn is going to send a read resource request off to the MCP server. Inside of that read resource request, we're going to include something called the URI. That is essentially the address of the resource we want to read. This URI gets defined whenever we put together our resource initially. So the URI is that right there. When we send off this read resource request, the MCP server is going to look at the exact URI that we put inside of here, and then run the function we put together right there, take the result, and send it back to us inside of a read resource result message. We can then take the data inside there and display it inside of our autocomplete or do whatever else we need to do with it. There are two different types of resources, direct and templated. You'll also sometimes see direct resources referred to as static resources. A direct resource just has a static URI, so it's always going to be the exact same thing, such as docs://documents. A templated resource will have one or more parameters inside of its URI. So for example, we might have document/ and then kind of a wildcard right here. So we can put in any document ID we want to. And whenever we ask for this resource, that document ID right there inside the URI will be automatically parsed by the Python MCP SDK and provided as a keyword argument to our function. The keyword argument will have the exact same name of whatever string you put in right there. So doc ID right there will be doc ID right there. As you can probably guess, we'll make use of templated resources anytime that we want to allow a little bit more selection or variety or customization in what someone is asking for out of our MCP server. Implementing resources is pretty straightforward, so let's go back over to our editor and we're going to add in some resources to our server right away. All right, so back over inside my editor, I will find the mcp server.py file. I'm then going to scroll down a little bit and I'm going to find some comments for writing a resource to return all document IDs and writing a resource to return the contents of a particular document. Now for this first one right here, I put in the comment document IDs. Remember, for us, our document IDs are essentially the name of the document. So for us, we're really just returning these IDs. They're going to serve the purpose of the name. That means we can put them directly into that autocomplete element. All right, so to make our resource, I'm going to delete that to do, and then I'll add in a mcp.resource. The first argument is going to be the URI for accessing this thing. Again, it's kind of equivalent to a route handler. So I will use docs://documents. And I'm also going to add in a MIME type of application/JSON. A resource can return any type of data. So it can be plain text, it can be JSON, it can be binary data, anything. It's up to us to kind of give our client a hint as to what kind of data we are returning. To do so, we're going to define this MIME type. A MIME type of application/JSON is a hint to our client, who's eventually going to ask for this resource right here, that we're going to be sending back a string that contains some structured JSON data. And so it would be up to our client to deserialize that data, or essentially turn it into some usable data structure. Underneath that decorator, I'll write out my function of list docs, and I'm going to return a list of strings. And then inside there, I will return list docs keys. So just take all the keys out of that dictionary and turn it into a list, and I'm going to return it. Now, you'll notice that we are not returning distinct JSON here. In other words, we're not actually returning a string. The MCP Python SDK is going to automatically take whatever we return and turn it into a string for us. All right, let's take care of our second resource. So I'm going to delete that comment and then replace it with MCP resource docs://documents. And then this time I want a templated resource because I'm putting in this wildcard right here. And then my MIME type this time around, just for a little bit of variety, I'm going to be returning plain text because it's going to be just the contents of the document, and I'm not going to wrap it up in any kind of structure. Now, just so you know, in a real application, something like read a document, I would probably return an entire document record. So some kind of dictionary that contains maybe the ID, the content, the author name, the author ID, and stuff like that. But just for the sake of an example, I'm going to return just the text out of the document to show you how we would normally return plain text. So in this scenario, my MIME type would be text plain. And then I will make fetch doc. I'm going to take doc ID, which is going to be a string, and I'm going to return a string. Once again, whatever word you put right there, it's going to show up as a keyword argument inside of your function. If we added in some additional parameters inside of here, such as maybe doc type or something like that, it would just show up as an additional keyword argument like so. Then inside of here, I'm going to first make sure that the ID that this person is asking for actually exists. So if doc ID not in docs, I'm going to raise a value error with a F string that says doc with ID not found. And then if we get past that check, I will return docs, doc ID. And that's it. Now let's try testing this stuff out inside of our MCP inspector once again. So remember, at our terminal, we can run the command uvrun mcp dev mcp server.py. That's going to start up a web server at port 6277, or excuse me, 6274 is the default. So I'm going to make sure I open that up inside my browser. Here we go. I'll click connect. I'll then find resources. And then I should be able to list out all the different resources that are available. Now, when I list out resources, this is going to be specifically static or direct resources. So I'll see only docs/documents. And then I can separately list out all my different resource templates. And so I'll see that I have one resource template of fetch doc. I'm going to first try to run the /documents right here. We'll see what we get back. So this is the actual message, the exact structure that gets returned from our MCP server. You'll notice that it has a text property, and inside there is all the data that we are returning, serialized as a JSON string. So again, it would be up to us inside of our CLI application to take this text right here and deserialize it from this JSON string into a usable list of strings. Then we can also test out fetch doc. So I'll click on that. I have to enter a doc ID. So I'm going to put it in. I want to read the report.pdf file, and I'll read the resource. And now I should see the contents of that particular document. And you'll notice this time around, once again, I get a text plain. So that's a hint to me that this is plain text and I should not attempt to deserialize it from JSON in any way. We have defined two separate resources inside of our MCP server. So now our client needs the ability to request these resources. To do so, we're going to add in a single function inside of our MCP client. And remember, this MCP client is going to have some functionality that we're putting together that is going to be used by the rest of our application. And I've already put together that code already. So somewhere else inside of this project, something is going to try to make use of this function that we're about to add into the MCP client. To get started, I'm going to open up the MCP client file again. I'm going to scroll down and find read resource right here. So our goal inside of here is to read a particular resource by making a request off to our MCP server, and then parse the contents that come back depending upon its MIME type, and then just return whatever data we get. So you'll notice that an argument to it is the URI. This is going to be the URI of the resource that we want to fetch from the server. In order to make a request, just to get all of our types nicely, we're going to add 2 imports at the very top of the file. I'm going to add in an import for the JSON module, and from Pydantic, I will import any URL. Then I'll go back down to our read resource function. I'm going to clear out the comment and the return statement. Then I'll get a result from calling await self session. I want to read resource. And then again, this is really just to get the types to work out. We're going to put in any URL with the input URI. Then I'm going to take from that result result contents at 0. And I want to make this clear right here why we are adding this in. So just a moment ago inside of our inspector, we saw the response we get back. So this is essentially that result variable. The result has a contents list, and there's going to be a list of elements inside there. We really only care about the very first one. So I want to get the first dictionary. I want to access the type property and the MIME type. I want specifically the MIME type because it's going to help me understand what kind of data we got back. If it is JSON, then I want to make sure I parse the text as JSON and return that result. So let me show you how we're going to do that. I'm going to add in a if is instance of resource types text resource contents. And inside there, if resource MIME type is equal to application JSON. So this is our hint in use. If the server told us that it's giving us back some JSON, we need to make sure that we parse the text content as JSON. So I will return, in that case, a JSON loads of resource.text. And then otherwise, if we don't fall into that if statement and return early, I want to just return resource.text. So in this scenario, we'd be returning the text as just plain text. We're not parsing anything. So this would really be the case in which we get back the contents of a single document. All right, so that should really be it. We've got our read resource put together. Now, again, I want to remind you, I know I've said this several times, but I just want to remind you because I think it might be a little bit unclear. The code that we're writing inside of the MCP client is being used from several other places inside of this code base. So somewhere else in this code base, we're going to be calling that function that we just put together to get the list of document names, and then eventually get the contents of a document to put into a prompt. So at this point, everything should essentially work because the rest of the work has already been done for us. So with that in mind, let's go back over to our terminal and we're going to test out our CLI application again and see if this mention feature works. Okay, so back over here, I'll do a uv run main.py, and now I should be able to say something like what's in the at, and there we go. I see my list of resources and I can use the arrow key to scroll through. Once I am at a resource I like, I'll just hit space and we'll insert that resource. So what's in the report.pdf document? And now I can tell you that everything is working as expected here. In other words, the contents of this document is being sent off to Claude inside of a prompt. So if I submit this, I should see an immediate response and it's going to tell me what is inside of report PDF. So this time around, Claude did not have to use a tool to read the contents of the document. All right, so that is resources. Again, we make use of resources to expose some amount of information from our MCP server. The last major focus we're going to have inside of our MCP server is going to be on prompts. Once again, just like we did with resources, we're going to implement a small feature inside of our project, and we're going to use this feature to understand what prompts are all about, just like we did with resources a moment ago. Let me tell you about the feature we're going to add into our program. We're going to add in support for /commands. So for example, I want to have a format command. I've got some screenshots over here of how it's going to work. Whenever a user types in a /, we're going to list out some number of commands that are supported by our application. For right now, we're going to have just one command called format. So if I type in just /, I should see a little autocomplete right here, and the only autocomplete option should be format. If I then select format, I should be prompted to add in some document ID after it. So one of our different document names like report.pdf or whatever else. Then, whenever a user runs this command, the goal is to get Claude to reformat this document using Markdown syntax. So, in other words, take the plain string that we have without any special formatting tied to it inside of each of our documents right now. Remember, inside of our MCP server, our current document content is just plain text. We want to feed this into Claude and somehow get Claude to rewrite it using Markdown syntax. So I would expect to see some output like this, something that says, I'll help you reformat the document. Claude is then going to use a tool to read the contents of the document. And then finally, inside the final response, I want to see the content of that document rewritten down here in Markdown syntax. Now, there's something interesting about this feature that I want to point out. The real core of this feature, like the real goal here, is to allow a user to reformat a document into Markdown syntax. And that is an operation that actually doesn't require you and I, the developers, to write out any code to implement. What do I mean by that? Well, a user can already launch our CLI and say something like reformat the report.pdf file in Markdown syntax. A user can already do this, no issue whatsoever, and Claude is going to do a reasonable job of it. It's going to take the contents of our document and reformat it into Markdown. And as you can see right here, it worked entirely perfectly. So what are we really doing with this feature? Well, the thought process here is that if we just left this up to users and allowed them to manually type in something like convert this to Markdown, they might get a okay result, but they might get much better result if they had a really strong prompt that is custom tailored for this particular scenario of converting a document into Markdown. So a user might be a lot happier if you and I sat down as the MCP server authors and wrote out and tested and evaled and went through the entire process of developing a really thorough, fantastic prompt, like the one you see on the right-hand side. So again, just to repeat, yes, a user can execute this entire workflow on their own, but if they use this fancy prompt over here instead, well, I think they would be all the better. This is the real goal of the prompts feature inside of MCP servers. The thought here is that ahead of time, we can define a set of prompts inside of our server that are custom tailored to whatever our server is really specialized to do. In our case, our server is all about managing documents, reading documents, editing documents, and so on. So we might decide to add in a set of prompts that are very high quality, that have been evaled and tested, and we know that they work in a wide variety of different scenarios. We can then expose these prompts for use inside of any client application, like the CLI app that we are putting together right now. Now, one thing I want to point out here is that we could develop this prompt and just put it directly into our CLI codebase. That is totally possible. We could do that, obviously. But again, the thought here is that your MCP server that might specialize in some particular task might expose some number of prompts that people can just come and use without having to worry about developing them ahead of time. To define a prompt inside of our MCP server, we're going to write out a little bit of syntax very similar to the tools and resources we have already put together. We will use the prompt decorator. We will add a name to the prompt and optionally a description as well. Then, whenever the client asks for this prompt, we'll send back a list of messages. These are actual user and assistant messages. So we can take the messages and send them off to Claude directly. All right, so let's go over to our server and we're going to try putting together our own prompt. And just like you see right here, it's going to be all about taking the contents of a document and somehow rewriting it in Markdown format. Okay, so back inside my editor, I'm going to find my MCP server file. I'm going to go down a little bit to the comment about rewriting a document in Markdown format. I'll delete that to do, and then I'll add in a MCP prompt, the name of format, and a description of rewrites the contents of the document in Markdown format. I'll then add in an actual implementation. So format document. I'm going to receive as an argument a doc ID, and then optionally we can add in a field description here as well, just like we did with our tool earlier on. So I can optionally add in a field with a description of ID of the document to format. And I'm also going to add in a type annotation of string, just to make sure that's really clear as well. From this function, we are going to return a list of messages. I'm going to make sure I add in an import for this base thing at the top right away. So right underneath the existing MCP server import, I will add in from MCP server fast MCP prompts import base. Then back down at the bottom, Inside of here, we're going to define our very well tested, very well evaled prompt. I wrote a prompt out ahead of time. I'm going to paste it in like so. So this prompt is just asking Claude to take in a document ID. Implicitly, we are kind of asking Claude to fetch the document ID's contents using the read document tool. And then after getting that document, just go ahead and rewrite it with markdown syntax. And finally, after rewriting it, edit the document as well to save those updates inside of our server. Now, after defining this prompt, we're then going to return a list of messages. So down here, I'm going to return a list with base user message, and I'm going to feed in our prompt that we just wrote out to it, like so. Now I'm going to save this file, and then let's go start up our MCP Development Inspector and test out this prompt from that interface. So at my terminal, I'll run that same command again, and then navigate to that address inside my browser. I'll make sure I connect to my server. I'll then find the prompts section. I'm going to list out all the different prompts that are available to us, and at this point in time, we have one prompt, just format. So I'll click on format, and then I have to enter in a document ID right here. This time around, maybe we'll put in a document ID of, how about outlook.pdf. So I'll put that in, and then get prompt. And then here is our list of messages. So these have been put together ahead of time. I've got one message part here, so a text part with our full prompt right there. We could see that the document ID was interpolated into it. So now that we have these messages, we can take them and send them off to Bedrock. And hopefully we're going to get back some appropriate kind of response. So once again, the entire idea here behind these prompts that we might implement inside of our MCP server is that the prompts we are defining are going to be well tested, well evaled, really specialized to one particular use case. Our last major task is to implement some functionality inside of our MCP client and allow us to list out all the different prompts that are defined inside the MCP server, and also get a particular prompt with some variables interpolated into it. So let's first implement list prompts. I will delete the comment and replace it with a result is await self session list prompts, and then I will return result.prompts. And that's pretty much it. And then get prompt. Now, to be clear, when we get an individual prompt, we're going to be given some number of arguments. These arguments will eventually show up inside of our prompt function. So for example, inside a format document right here, we expect to receive a document ID. Inside of this args dictionary, the expectation is that there will be a document ID key, and that will be passed in to the appropriate function over here, and then we will get that value interpolated into the prompt itself. So inside of the get prompt function, I will get a result from self session get prompt. I'm going to pass in the prompt name. That's the name of the prompt I want to retrieve. And then I'll pass in the arguments. And then I will return result.messages. So those are the messages coming back. They form some kind of conversation that we want to feed directly into Claude. And that's it. That's all we have to do for our client. So now we can test this out inside of the CLI itself. I'll flip back over, run the project again. And now if I put in a slash right here, I'll see that I can access this format command. Now format is really just the name of the prompt that we're going to invoke. So if I select that and then hit space, I'll then be asked to select one of the different documents. Maybe I'll go with plan.md. I'll hit enter. And then we're taking that entire prompt, really just that single user message, and feeding it directly into Claude. So Claude now has the instructions to go and reformat a document into markdown syntax, and it has also been given the ID of the document that we want to reformat. So the first thing it needs to do here is go and fetch that document's contents, and it will do so by using the get document tool. And then finally, Claude is going to respond with the markdown version of this document. So here is the document with a bunch of markdown syntax inside of it. All right, since it looked like this worked just fine, let's do a quick recap on prompts and make sure we understand what they are all about. We begin by writing out and evaling a prompt that has some relevancy to our MCP server's purpose. In our case, we were making a document server, so having some functionality or something about rewriting a document in a different style, I think it kind of makes sense. Once we have put our prompt together, we'll define a prompt inside the MCP server, and then our client can ask for that prompt at any point in time. When we ask for the prompt, we will put in some number of arguments that will be provided to this prompting function right here. as keyword arguments. And then our function can make use of those keyword arguments inside the prompt itself. We are all done with our project, but before we move on, I want to do a quick recap on the 3 server primitives that we learned about. So tools, resources, and prompts. In particular, I want to highlight something interesting about each of these, namely what part of an app is really responsible for running each. In other words, in a typical application, who is really running each of these things and who benefits from them? Well, we would say that tools are model controlled. This means that Claude alone is really responsible for deciding when to run a given tool. Resources are app controlled. In other words, some code running inside of your app is going to decide that it needs some data provided by a resource. It will be your app's code that decides to execute a resource and use the return data in some way, maybe by using that data in the UI or something like that. In our case, we fetch a resource and then use that data inside the UI to provide a list of autocomplete options. We also fetch a resource to augment a prompt. Both those things were really application-related code that was authored by you and I to put together. And finally, prompts are really user-controlled. So a user decides when a prompt is going to run. A user might start the invocation of a prompt by clicking on some UI element, like a button or a menu option, or they might make use of a slash command, which is what we did. The reason I highlight what is controlling each of these is to give you some idea of their purpose. So if you ever need to add capabilities to Claude, you're probably going to want to look at implementing some tools inside of your MCP server or consuming some servers' tools through your MCP client. If you ever want to get some data into your app for the purposes of showing content in the UI or something similar, then you probably want to use a resource. And if you ever want to implement some kind of predefined workflow, you probably want to look at prompts. Now you can see examples of all these ideas inside of the official Claude interface at claude.ai. So here's what it currently looks like for me. You'll notice that underneath the main chat input are some buttons right here. If I click on one and then click on one of these examples, you'll see that I immediately dive into a chat. So this was a user-controlled action. I, as the user, decided to start up this particular workflow, and I'm making use of a prompt that was probably already written ahead of time and probably has been optimized in some way. So to implement that list of buttons right there, we would probably want to put together a series of different prompts inside of a MCP server. Likewise, if I go back and maybe click on this little tab right here, the plus button, you'll notice that I have a Add from Google Drive button. Now, I'm not going to click on it because it's going to show some of my internal documents, but if I click on that button, I'm going to see some documents that I can add into this chat as some context. Knowing what documents to actually render in that list, and then whenever I click on one, automatically injecting its contents into the context of this chat, that is all application-related code. So it is solely the application that needs to know the list of documents to render here. And that's, again, specifically UI-related elements. So to implement that listing of documents from Google Drive, I would probably look at implementing a resource inside of a MCP server. And then finally, if I enter in a message to this chat of something like, what is square root of 3, use JavaScript to calculate the value, and send it off, I'm clearly expecting Claude to somehow execute some JavaScript code, which would likely be done through the use of a tool. In this case, the decision to use a tool was 100% model controlled. It is the model that decided to use some JavaScript tool execution. To implement something like this inside of a MCP server, we'd likely want to, you guessed it, provide a tool. So in total, that's our 3 different server primitives. And each one is really intended to be used by a different portion of your overall application. So we got tools, which are generally going to serve your model, resources, which are generally going to serve your app, and prompts, which are going to serve your users. And once again, these are high-level guidelines, and the only reason I mention them is to just give you a sense of when you should use each of these primitives, depending upon what you are trying to put together. This is going to be an exciting module. We are going to learn about building agents, which are one of the most interesting use cases of language models. However, as exciting as agents are, we really have our work cut out for us. You see, the field of agents is still being explored. There are a variety of different open questions about absolutely foundational aspects of agents. For example, there isn't even a single agreed upon definition of what an agent is. So with this difficulty in mind, let me show you how we are going to cover agents inside this module. Here's our plan. We are going to kick off this section by examining two agents that have been authored and released by Anthropic. They are Claude Code and Computer Use. If we can understand how these agents were designed and how they work, we can extract some insight into what agents really are and what makes an effective agent. We are going to start with Claude Code. I'll walk you through the setup process, we'll understand its use cases, and get some hands-on experience with it. We will then repeat that process with Computer Use, and then circle back and analyze what makes these agents so successful. Let's take a look at Claude Code. We'll do some setup, learn how it works, and see some advanced use cases. Claude Code is a terminal-based coding assistant. This is a program running in your terminal that can help with a wide variety of code-related tasks. To help you with coding projects, Claude Code has access to many different tools. So it has many basic tools like the ability to search, read, and edit files. But it also has many advanced tools like web fetching and terminal access. Finally, Claude Code can act as an MCP client. And you know what that means? It means it can consume tools that are provided by MCP servers. So we can easily expand the capabilities of Claude Code by adding in some additional MCP servers. Let's now go through a little bit of setup and install Claude Code on your machine. Setup is easy. We're going to first install a copy of Node.js. You might already have Node installed on your machine. And to figure out whether or not you do, open up your terminal and execute the command npm help. If you see a result come back, that means you probably already have Node installed. Once you have Node installed, you'll do a npm install command that will install Claude Code itself. Finally, by default, Claude Code tries to access Anthropic's API. So we need to update a little bit of configuration just to get Claude Code to make use of Bedrock. This takes the form of setting 3 different environment variables, which I've listed on here at the bottom of the screen. One last thing to just keep in mind, you also need to set up your AWS credentials, or alternatively, set the AWS access key and secret key. Now, a full setup guide can be found at the official Anthropic documentation at docs.anthropic.com. Now, I'm going to let you go through this setup process on your own. Again, just these 3 steps right here. As soon as you are done, we're going to walk through a little project together and see what Claude Code can really do for us. To get you some hands-on experience with Claude Code, I created a small project for us to work on. You should find the source for this project in a zip file attached to this lecture. I would encourage you to download this zip, extract its contents, and then start up your code editor inside of this new project directory. I've already opened up the project inside of my editor. Now, once you have the project open, you might be tempted to look through the project contents and maybe go through a little bit of setup, which is described inside the README file. But before you do, there's something important I would like you to understand about Claude Code. Claude Code is not a tool that is just going to write code for you. Naturally, it absolutely can, but that's not the only thing that Claude Code is about. Instead, you really want to view Claude Code as another engineer who's working on this project alongside you. Every task that you would normally go through on a normal project can really be fully delegated off to Claude. So this includes everything from initially setting up a project, to designing new features, to deployment, and to support. As we go through this project, we're going to leverage Claude heavily to aid us in various steps. We will use Claude to set up the project for us, to plan out a new feature, to write tests and code, and then later on a slightly different project, I'll show you how we can use Claude Code to automatically discover and fix errors in a production environment. So let's get to it. Back inside my editor, I'm going to open up my terminal and then launch Claude Code inside there by executing Claude. Then, once I have this open, I'm going to put in my first directive to Claude. I'm going to ask it to read the contents of the README file and go through any setup directions that are listed inside of here. I will ask Claude to read the contents of the README file and execute the setup directions listed in it. Claude will then use a variety of different tools to read that file and then execute a series of different commands. It will create a new virtual environment, activate the environment, and then install some dependencies. Once that is complete, we are going to run a command that will help Claude get a better understanding of our project. We're going to do so by running the init command. This is a command that we're going to execute inside of Claude Code itself. When you execute this command, Claude will automatically scan your codebase to understand your project's general architecture, coding style, and so on. Once complete, Claude will write all of its findings into a special file named claude.md. Whenever we run Claude again in the future, this file will be automatically included as context. And just so you know, there are 3 different Claude files. project, local, and user. We're going to see some references to these in a minute, so we'll discuss what they're all about then. Whenever you run this init command, you can also optionally add in some special directions for some areas for Claude to focus on. So let's try this out right now and see what is generated for our project. I'm going to run the init command, and when I do, I'm going to pass in some special instructions. I'm going to ask Claude to include some detailed notes on defining MCP tools. Once it is all done, I'm going to take a look at the newly generated claude.md file. So this is a summary of what Claude thinks of our codebase. At the top, it will list out some important commands that it might need to run in the future. We'll get some listing around our coding style that we've used inside this project. And then as I specially requested, it also included some information around defining MCP tools. As I mentioned a moment ago, this file is going to be included as context for Claude in any follow-up request we make in the future. Now, projects change over time. We might change our coding style or add in some additional commands. So if that ever happens, we can very easily manually edit this file, or we can choose to rerun the init command. If you rerun this command, Claude will update the contents of the claude.md file. Finally, as a very small shortcut, we can put in a pound and then type in some specific note that we want to be appended into the contents of that file. So we can use this as a tool to give very specific small directions to Claude that will be included in all follow-up requests. So for me, I might add in a direction here that says something like, always apply appropriate types to function args. And if I run that, I'll then be asked where I want to add this little note. And this is where we see that project memory, local memory, and user memory appear. In my case, this is a note that I want to be shared with everyone who is working on this project, so I will add it to project memory. Once I add that in, I can then check the contents of my claude.md file, and either somewhere under code style or perhaps at the very bottom, I'll probably see whatever note I just added in. At this point, we have added a new file to our project, and this project is being managed by Git. So normally, we would open up our terminal, stage this new file that we just created into Git, and then commit those changes. We could do all that manually, but it'd be a lot faster if we just asked Claude to do it for us. So I will ask Claude to stage and commit all changes. Claude will then take a look at all the different changes we have made to the codebase, write a descriptive commit message, and commit those files. Next up, I would like to show you some techniques for increasing Claude's effectiveness when writing code. We are going to add a new feature into this project. As a reminder, this project is a very small, very simple MCP server. We are going to ask Claude to add in a new tool to the server that will read a Word document or a PDF file and convert the contents to Markdown. Now, we absolutely could just type in directions for that to Claude, something like make a Word doc plus PDF file to Markdown conversion tool. But before doing that, I want you to know that we can dramatically increase the effectiveness of Claude by putting in a little bit more effort. So let me show you how. Think of Claude Code as being an effort multiplier. If you put a little effort into how you direct Claude, you will get back significantly better results. I'm going to show you two different workflows, two different ways of instructing Claude on how to approach a task. Both of these workflows require a little bit of effort on your side, but they allow Claude to tackle much more complex problems. In this first workflow, we're going to go through three distinct steps. First, we're going to identify some areas of our codebase that we know are relevant to a feature that we are trying to work on. We're then going to ask Claude to specifically read and analyze those files. Second, we're going to tell Claude about the feature we want to build and ask it to plan out a solution. So the steps we'll actually go through to implement whatever feature or problem you're trying to solve. And then finally, after Claude has gone through that planning step, we will ask Claude to actually implement the solution. Let me show you how we would do this for our particular feature of adding in some new document conversion tool. So first, I'm going to go through my codebase and identify some different relevant files. You'll notice there is a tools directory, and inside there is a math.py file. This is an example of a tool that has already been put together. So this might be some file that is relevant for the feature that we are trying to build, just because it gives Claude a better idea of how to author a tool. Second, we might ask Claude to take a look at the document.py file, which includes a very helpful function, binary document to Markdown. So this will take in some amount of binary data and convert it to Markdown. So we can tell Claude to take a look at these files, and Claude will get a better idea of how to write a tool in the first place, and then how to actually do the conversion. So I'm going to add in some instructions to Claude and ask it to just read the contents of those files. Next, I'm going to ask Claude to plan out the implementation of a new tool called Document Path to Markdown, which will take in a path to a PDF or Word document, read the file, convert the contents to Markdown, and return the result. I'm also going to tell Claude specifically to just plan the feature out and not to write any code just yet. In response, Claude is going to give us a pretty well-detailed plan that's going to go through a couple of different steps that will be required to implement this entire thing. Finally, I will ask Claude to implement this plan. It's first going to update the document.py file, which is definitely correct. It's then going to update the main.py file, which is also good. And then finally, it will author a test around this new tool. It's then going to run the test suite and make sure that the test actually passes. You'll notice that in the summary message, Claude also tells me that it added in some error handling for non-existent or unsupported file types, which was definitely appropriate, even though it wasn't something that I actually asked for explicitly inside of my description of this feature. I'd like to show you another way that we could have asked Claude to implement this feature. Before I show you this alternative, I'm going to get Claude to remove all the code that it just wrote by stashing these changes. Now I am back to a clean slate where I don't have anything related to that new feature that was just implemented. The second technique that we are going to explore is a test-driven development workflow. Again, this requires some more effort from you up front, but it dramatically increases Claude's effectiveness. With this workflow, we will again ask Claude to take a look at some relevant context. Then, before writing any code, we're going to ask Claude to think of some different tests it could write related to our feature. Next, we will select the most relevant tests and ask Claude to implement them. Finally, after we have got some working tests put together, we will ask Claude to write out a solution and write code until the tests actually pass. So let me show you how this approach would actually look for the same exact feature, one where we are building a tool that's going to read a document off of our hard drive and convert its contents into Markdown. First, I'm going to run the /clear command. This is going to clear up my conversation history with Claude, essentially reset its context. In this case, I'm doing this just so it doesn't cheat off of its previous solution. Then I will ask Claude to read those two relevant files once again. Then I'm going to add in some very clear instructions to think of some tests that it might write to evaluate this new feature that we want to build. Again, I'm going to ask it specifically to not write any code just yet. The suggestions I get back are really solid. Now, I don't really want to have to worry about tests 6, 7, and 8 because those are a little bit more specialized beyond what we're doing right now. So I'm going to ask Claude to just implement tests 1 through 5. Now we will move on to the last step, where we will ask Claude to write out some code to make these tests pass. Very good, all the tests pass. Now, before we move on, I just want to remind you one more time that Claude Code really is an effort multiplier. You can put in very simple directions, and Claude will do its best, but you can dramatically increase Claude's effectiveness by putting in a little bit of effort on your side as well. In this video, I want to show you one of the most interesting aspects of Claude Code. Claude Code has an MCP client embedded inside of it. That means we can connect MCP servers to Claude Code and dramatically expand its functionality. To demonstrate this, we are going to connect Claude Code to the MCP server that we have been working on. We just authored a tool called Document Path to Markdown. We can now expose this tool to Claude Code, allowing it to read the contents of PDF and Word documents. So we are dynamically expanding the capabilities of Claude Code. Let me show you how to set this up. Back inside of my terminal, I'm going to end my running session with a Control-C. I'm then going to add in an MCP server to Claude Code by executing Claude MCP add. Then we're going to put in the name for our MCP server. Now the name can be anything you want it to be. In our case, we are making a server related to documents, so I'm going to call our server documents. And then finally, we're going to put in the command that we use to start up our server, which for us is uv run main.py. So uv run main.py. And that's it. I'm going to execute that, and then I'll start Claude Code back up with Claude. And now we can make use of that tool that we just put together. To really test it out, inside of our test directory, there's a fixtures folder, and inside there are two demo files, so a Word doc and a PDF doc. They both contain just a tiny bit of documentation around MCP itself. So I'm now going to ask Claude to convert the contents of either one of those files into Markdown. And my expectation is that Claude will make use of that tool that we just authored a moment ago. And if we scroll up just a little bit here, sure enough, it worked. So this actually is the contents of that file. This ability to consume MCP servers adds an incredible amount of flexibility to Claude Code and really opens the door to some really interesting development opportunities. For example, you might decide to add in a series of MCP servers related to your particular development flow. For example, if you use Sentry for production monitoring, you can add a Sentry MCP server to allow Claude to fetch details about errors that are occurring in production. If you make use of Jira, you can add in an MCP server that will allow Claude to view the contents of specific tickets. If you're a Slack user, you can add Slack to message you whenever Claude is completed working on some particular problem. These are just a small fraction of the possible enhancements that you can add into Claude Code. So it would definitely be worth your time to think about how you can enhance your particular development workflow. In this video, we are going to explore one of the greatest productivity gains around Claude Code. Because Claude is a lightweight process, you can easily run multiple copies of it. Each instance can then be given a task, and these separate instances will then work in parallel. This technique allows a single developer to command their own team of virtual software engineers. So in the remainder of this video, I'd like to show you some of the specifics of implementing this workflow on a real project. The first big challenge to address is the fact that two instances of Claude might want to work with the same file around the same time. They might end up writing conflicting code or even invalid code because they're not aware that some other process is modifying that same file. To solve this, we can make sure that each instance gets its own separate workspace. Each instance can then work with its own copy of your project, make changes, and then eventually merge those changes back into your primary project workspace. A common way of implementing this is by using a Git worktree. Git worktrees are a feature of Git, so if your project is already managed by Git, you can use worktrees immediately. Worktrees are like an extension of Git's built-in branching functionality. A worktree allows you to create a total copy of your project inside of a new directory on your development machine. Each worktree corresponds to a separate branch. So if we have feature A on the left and feature branch B on the right, we can easily create two separate folders, each of which contain a complete copy of our codebase. Then we can run separate instances of Claude Code for each worktree. They will each work in their own separate environment in total complete isolation. Once each copy of Claude Code has then finished some feature, we can then commit the work for each worktree and then merge them back into our main branch, just like we would merge a normal branch. Now, this might sound like a really complicated workflow that would be very tough to manage, but remember, you can delegate an amazing amount of work to Claude Code, including tasks around Git. So we can actually get Claude Code itself to manage this entire workflow. Let me show you how. First, we could write out a prompt that will ask Claude to create the worktree for us. We might ask it to also open up our code editor inside of the newly created worktree folder. And that's what I'm asking for inside this prompt. I'm asking Claude to make a new worktree inside of a directory at trees/feature A. I'm then going to ask it to symlink in some dependencies because those are not tracked by Git, and so they will not be automatically copied into the worktree directory. And then I'll ask Claude to also open up my code editor inside of that new subdirectory. Now let me show you how this would actually all work. So I'm going to take this exact prompt right here. I'm going to run it inside of Claude Code. Claude will then create the worktree, create the symlink of the virtual environment, and then open up a new code editor instance inside of this new sub-project folder. Inside of my original editor window, I'll see that there is a new trees directory, and inside there is a feature A folder. Inside that feature A folder is a total copy of my project, and that copy has been opened up automatically inside of this new editor window. So inside this new editor window, I can launch Claude Code and ask it to fulfill some task, maybe add in some new feature or write tests or do whatever else I need. And now this instance of Claude Code is running in total isolation. Before I ask Claude Code to do anything inside of here, however, I want to point out that this is a really long prompt to remember, and it's really tedious to have to copy paste all over the place anytime that we would want to create a new worktree. So we're going to do a quick side topic here really quickly, a little side feature of Claude Code that makes it really easy to create and merge in these separate worktrees. So we could automate this entire prompt by making use of another feature of Claude Code, support for custom commands. You can add in custom/commands to Claude Code by creating a markdown file inside of a special directory inside of your project. The special directory is .claude/commands. Inside of a file inside that directory, we'll write out our entire prompt, and then we can easily run this custom prompt anytime we want to. Let me show you how we can use this feature to easily create a new work tree. So inside my original editor window, I'm going to make a new folder called .claude. Inside there, I'll make another folder called commands. And then inside that, I'm going to make a file called, how about create worktree.md. And then inside of that, I'm going to paste the prompt that we saw just a moment ago. Now, this prompt has a hard-coded feature name or hard-coded branch of feature underscore A, and I don't always want to have exactly that string. So I'm going to replace it with a special string of $arguments, all capitals. This allows us to inject some additional argument when we actually run this custom command. So now if I save this file and restart Claude Code very quickly, I can run /project : create worktree. It's called specifically create worktree because that is the name of the file I created inside that commands directory. I'll then put in a space and then the name of this new worktree. And I'm going to call it feature underscore B this time around. So now feature B is going to be taken and substituted in for wherever I had placed $capital arguments. So now if I run this, I should very quickly see a new worktree created. And before long, I've got my new code editor instance. So now this one is open inside of worktree feature underscore B. And I can see that the additional worktree has been created inside that trees directory. Now that we've seen how we can create multiple different work trees, I want to give you a full demo here. I'm going to create 4 separate work trees. Each one is going to be designed to complete some different task. So I'm going to have 4 instances of Claude Code running. The first one is going to add in some tests around documents. The second one is going to add in some logging. Third one is going to add in 2 new tools. And then the fourth one is going to add in a subtract tool. I'm going to run all these tasks in parallel, and then I'm going to merge the changes from all of them back into my main branch. So for step number 1, I'm going to create 4 separate work trees. I now have 4 separate editor instances, one for each feature that I want to implement. I will start up Claude Code in each and give each of them some directions on some feature to add in. When a work tree is complete, I will ask Claude to commit that code. Then, when they are all complete, it is time to merge all these changes from these different branches back into my main branch. We do not have to do this by hand. Instead, we can ask Claude to do it for us. So I put together another prompt here, which I'm going to wire up as an additional custom command inside my project. This prompt is asking Claude to go into one of our different feature work trees, take a look at the most recent commit just to understand what was done, and then attempt to merge those changes back into the main branch. I'm going to add this prompt in as another custom prompt inside my project. So inside of Claude commands, I'll make a new file. I'll call this one merge worktree. Paste that in. I'll then restart Claude Code. I'll then run the merge worktree command, and I'm going to first ask it to merge in, how about the document tests branch that was just created. I can then repeat this process for all the other work trees as well. When I merge in the subtract feature, there will be a merge conflict, but Claude is going to automatically resolve the conflict for me. When everything is merged in, I can then ask Claude to clean up all these different work trees that have been created. And that's it. So I've now implemented 4 separate features entirely in parallel through the use of Git work trees. This is clearly a really big productivity increase, and it scales up to as many different instances as I feel like I can manage at a single time as an engineer. Claude Code is not just about helping you author some code inside of your editor. It can also help you after you have deployed your application in monitoring for errors and helping you fix those errors as they arise. So in this video, I'm going to walk you through a sample workflow where we are going to take a look at a production application that is throwing some errors, but only in a production environment. We're going to see how we can make use of Claude Code to automatically find and fix those errors. So first, let me show you a little sample application I put together. This is a very simple chatbot, and I'm currently running it locally on my own computer. You can see the evidence for that. I'm currently at localhost 3000. If I ask any question here, let's say maybe what's 1 + 1, no problem, I'll get back an answer rather quickly. This chat application also has the ability to make simple artifacts. So for example, it can show a built-in spreadsheet. I'm going to ask for a spreadsheet with some fake data, and it appears that everything is working 100% as expected. Now remember, this application is currently running in my local development environment, but because everything is working just fine as I'm testing it right now, I might decide to go ahead and deploy it into production. So I've already done that ahead of time. I've already taken this exact app and deployed it off to AWS Amplify. So this is a production version of the exact same app. It is hosted at Amplify right now. I'm then going to repeat the exact same test that I showed you a moment ago. I'm going to first ask, what is 1 plus 1? Then I will follow up with the exact same request that I made a moment ago in the local application. So make a spreadsheet with some fake data. And we're going to see that the request goes through, but unfortunately, the spreadsheet itself is completely empty. There's actually no data that has been generated. So it is now clear that something in this production environment is not really working as expected. Everything in development worked just fine. The exact same series of operations, completely fine in development, but specifically in a production environment, I am running into this error. To figure out what the issue is, I could take a look at my CloudWatch logs. I already opened those up, and I've already hunted through those logs and found the source of this error. So I've got an error message here. It states the provided model identifier is invalid. And then I've got a lot of debug information included in here as well. So I, as an engineer, could take this error message, which I had to hunt down inside of my logs, and do a little bit of local debugging to try to figure out why this is failing in production, but not locally. Alternatively, I could delegate this entire task off to Claude. Let me show you how. Inside of my GitHub repository for this project, I created a GitHub action, which is going to run automatically every day, very early in the morning. On the screen right now, I have the results of a sample run from earlier today. I'll show you some of these logs from the GitHub action in just a moment, but first, let me show you a diagram that's going to help you understand what is going on inside this. Okay, so whenever this GitHub action runs, it's going to check out my repository, install some dependencies, and then install and set up Claude Code. I then also install an AWS CLI, which allows me to reach out and get some logs from CloudWatch. I then pass off some directions to Claude Code. I ask it to reach out to CloudWatch and find all the errors that have occurred in the last 24 hours. I also include some logic in there to remove duplicate errors and reduce the total number of errors down just to be manageable for Claude's context window. Once Claude has a list of errors, it then iterates over them and attempts to fix each one. And then once Claude hopefully has successfully fixed these errors, it will commit those changes and automatically open a pull request where I can view its work. So in this case, as we just saw, I'm getting an error in our production environment, and I saw that error inside the logs. If I now go over to my list of pull requests right here, I'll see that Claude automatically ran, it automatically found the issue, applied a fix, and then created a pull request. So now I could very easily review this pull request right here. The entire issue is explained to me in plain detail, and in this case, it was just a typo on my behalf. I accidentally put in an invalid model ID that was only used in a production environment. So Claude noticed that, it found the correct model ID, and put the correct one in, committed the changes. So now I can very easily review the changes and merge the pull request. This is just one sample workflow that you might use to automatically monitor and fix your apps in a production environment. Remember, Claude Code is very flexible, and you can create your own custom workflows, just like this one, to aid your own debugging efforts. Let's take a look at the computer use feature inside of Claude. We're going to cover this in 3 different parts. I'm going to first give you a quick demonstration of computer use and help you understand why it's useful. We'll then take a look at some behind the scenes stuff and understand how computer use works. And then I'll show you how to set up the reference implementation so you can test out computer use on your own. So let's get to it. Let's first go over a quick demonstration of computer use. For this demonstration, I've put together a very small web application. All it does is show a text area that supports the ability to mention a file or some kind of resource using the @ symbol. So if I enter test and then @ I can scroll through a bunch of different options and then eventually hit enter to select that particular option. Now, at first glance, this thing appears to be working just fine. I can add in as many different mentions as I want. But if we use it a little bit more, we'll start to see a lot of janky behavior. For example, if I add in 2 mentions and then press the backspace key, I'll see that I suddenly get a pop-up on the top left-hand side of the screen. So it's clear that this thing doesn't quite work as expected. Now, I could spend my time as a software engineer to sit here and figure out all the different cases in which this component fails. Or alternatively, I can delegate this task off to Claude's computer use. Let me show you how we would do that. Now, I have already set up a computer use environment in this window. So this is a demo that you and I are going to eventually set up on your computer a little bit later on inside this section. On the right-hand side is a browser that is running inside of a Docker container. So this browser is completely isolated from the rest of my system. And then on the left-hand side, I have a chat interface where I can give direct instructions to Claude and get Claude to interact with this browser in some particular way. Inside of that chat interface, I'm going to enter in a rather large prompt to Claude. I'm going to tell Claude that it's going to do some QA testing on a React component hosted at some particular address. I then outline some testing process for Claude and then some different test cases to go through. And at the very end, I'm asking Claude to write out a concise report that summarizes the output of all these different tests. So again, I'm using Claude Computer Use here to automate some QA testing, just to save myself some time. I'm going to take this big prompt, enter it into this chat interface, and then Claude is immediately going to spring into action. Claude is going to follow some of the instructions I listed inside there, so it's going to try to navigate to that site where I hosted this application, and then go through each of those different test cases. The first test case will just verify that the autocomplete options appear. The second test case will verify that pressing enter will insert a mention. And the third will make sure that pressing that backspace key shows the autocomplete options underneath the mention itself and not on the top left-hand side. After all the test cases run, we'll see some output in the chat window. So it tells me that the first test and the second test passed, but the third one failed. So again, this is a sign to me that I probably need to go and investigate this test case myself and figure out how to fix this. Either way, Claude's computer use functionality saved me, the developer, a lot of time in this QA process. Now that we have seen a demonstration of computer use, let's get a better understanding of how computer use actually works behind the scenes. To help you understand computer use, we're going to first get a quick reminder on how tool use works with Claude. So whenever we want to use a tool, we will make a request off to Claude, including a user message and some tool schema. This tool schema describes some additional functionality that we want to expose to Claude. So in this example, I might send across a tool schema of something like get weather that would presumably allow Claude to fetch some weather in a particular location, like maybe San Francisco. Claude is going to take a look at the user's message and realize that it can't really answer the question by itself. So it's going to decide to use that get weather tool. To use the tool, Claude will respond with a tool use part. So this will have a tool use ID, a name, and some input that it wants to feed into the tool. In this case, it would probably be a location of San Francisco. Then our server is going to have some amount of code written by you and me that will receive that location and then return the current weather at that spot. We're then going to take that result and send it back to Claude inside of a tool result part. So we can summarize this entire process in a diagram like this. We initially send Claude some kind of question and a list of tools. Claude decides to use a tool. We run some code or do something on Claude's behalf and then send the result back to Claude. It turns out that computer use follows the exact same flow because computer use itself is actually implemented with this exact same tool system. So here's how computer use actually works. We send a request off to Claude that includes a very special tool schema. The schema we send is very small. It's exactly what you see on the left-hand side, and it doesn't match the typical structure of a tool schema. Behind the scenes, this schema will be expanded into a much, much larger structure like the one you see on the right, and this larger structure is what actually gets fed into Claude. This large schema tells Claude that it can call an action function, and that the action function takes arguments like mouse move, left click, screenshot, and more. Claude might then decide to make use of that tool in some way, so it will send a tool use part back to us. Remember what we saw a moment ago with the getWeather function. Whenever Claude decides to use a tool, it is up to us, the developers, to actually fulfill Claude's tool use request in some way. So to simulate a computing environment for Claude, we can set up a Docker container running some program that can programmatically execute key presses and mouse movements. Once we execute the requested key press or mouse movement, we then send a response back to Claude. So to summarize, this is exactly what's going on behind the scenes with computer use. Claude isn't actually directly manipulating a computer. Instead, computer use is implemented using the tool system, and it is up to us to provide the actual computing environment. The last thing I'd like to do is tell you how you can get started with computer use on your own. Luckily, you do not have to create that Docker container from scratch on your own. Anthropic has already implemented a reference implementation. This is a Docker container that already contains code to receive tool requests from Claude and execute programmatic mouse movements and key presses inside of the container. I've provided a link to the reference implementation on the left-hand side. Setting up this implementation is really easy. All you need to do is get a Docker implementation. You might already have one installed. You then also need a local AWS profile. And once you have both of those, you'll execute a simple Docker command, and that's going to give you access to the same interface I showed you just a moment ago. You can then chat directly with Claude on the left-hand side of the screen and test out Claude's computer use functionality. We have now taken a look at two agentic tools authored by Anthropic. So let's now spend some time to reflect on how they work and use that knowledge to better understand what agents are all about. First, I want to review Claude Code. I went back to our small project and gave Claude an additional task. I asked it to write out some tests for a particular corner case. Claude then used a series of tools to fulfill the request, and I've shown the entire log for this operation on the screen. Now, out of all these different tool calls, 2 were used to read existing files inside the project, 1 was used to write to a file, and 1 was used to run a test. Now, I'd like to think critically about each of these different tool calls and what they were meant to achieve. In other words, why did Claude decide to use each? Well, 3 out of the 4 tool calls were really intended to gather information about the environment. By environment here, I really mean the codebase that Claude was operating on. The 1 remaining call was intended to modify the environment in some way. We can see a similar pattern with computer use. When I asked Claude to test out that mentioner component, Claude made a variety of different tool calls. Just so you know, the computer use tools automatically return screenshots. So if Claude attempts to type or move the mouse, it'll immediately get some visual feedback of the environment. So as we examine the tool use of Claude Code and computer use, we start to notice a pattern really quickly. Both of them are using tools, and these tools are largely focused on just delivering or getting information into Claude. Let's summarize some of this tool use inside of a table and use it to better understand what agents are all about and what really goes into making a successful agent. So in both Claude Code and computer use, we're going to see that they share a wide variety of different qualities in how they work, how they run, and how they are getting information into Claude. Both these make use of tools extensively, and they both run tools inside of a loop until some goal is achieved or until some unrecoverable error occurs. They both rely upon tool calls as their primary source of information about the environment, as opposed to relying upon some kind of RAG process, or relying upon a developer to write out a super detailed prompt, or relying upon a user to write out extensive instructions. They're both given a very small, very focused set of tools, where each tool has a very clear purpose. Finally, they are both intended to work on high-value problems, where failure doesn't cost much money. In other words, Claude is writing code, which is traditionally a very high-value task. It takes a tremendous amount of knowledge and experience to write effective code. At the same time, if Claude makes a mistake in the code it generates, there's not necessarily an immediate, inherent economic or safety impact. Compare this to Claude, say, building a complex design for a bridge, where an error could have a very large safety impact. In summary, when we consider building an agent, there are a few concepts we need to keep in mind. First, an agent is a language model that has access to a set of tools and is being executed repeatedly until a goal has been achieved. Second, context is king. Claude doesn't have any knowledge of the outside world at all, and it relies entirely upon being given a set of tools to inspect the environment. Third, we really want to think about using agents only when we have a high-value task where an error or failure won't have a large economic or safety impact. And finally, the best way to make sure you are building an effective agent is evals. Creating some evaluation criteria and evaluating your agent against it is the only way to ensure that you are making an effective agent.
Welcome to the final video. We've covered a ton of information in this course. We really just have 2 goals in this video. We want to review, recap some of the things we talked about, and then explore some next steps. So as a recap, we covered a lot. We learned about Anthropic and some of the research we do. We talked about the family of models and various use cases. We covered fundamental topics in the world of generative AI. And then we covered working with the API to actually send requests to the model. And we covered things like sending basic text prompts, parameters like max tokens, what stop sequences are, what stop reason means, what temperature does, what system prompts do. We covered prompt engineering. We talked about tool use and computer use and some agentic workflow basics. We talked about writing evals. Really, really critical. I know I've said that a million times, but I'm going to use this video to highlight the importance of evaluations again. Do not forget them. Do not let customers skip them or try and convince you to skip them. They are critical. And then we talked about some more advanced topics, including RAG and fine-tuning. A lot of information here. So what is there left? Where to go next? There are some topics that we recommend you look into as next steps. Always stay up to date with the latest in Anthropic's research. We publish quite a bit. And then moving beyond that to more specific actionable topics, large language model orchestration. Basically workflows involving more than one model. Different models, maybe just from the Anthropic family, orchestrating Haiku alongside Sonnet as an example. We hinted at some of this when we talked about agents and agentic workflows. We can have a slower but smarter model, dispatch actions to a whole bunch of, a team of cheaper Haiku models or something like that. Explore RAG alternatives, and then explore agentic workflows. This is still very much an emerging field that is changing constantly, but we expect this to be the big trend going forward, the thing that companies are most interested in, and that customers are probably also going to be most interested in implementing. The trouble is that it's still a new field, right? There's a lot of exploration to be done, a lot of research that's being done, and experimentation that you can do yourself to decide and understand which of these workflows work. Are there novel approaches? I showed a slide with 7 or 8 different possible agentic workflows. There are many, many others out there. There are libraries and frameworks out there to help you build agentic workflows. This is an emerging field, and again, something we expect to be a big trend going forward. So thanks for joining us. I hope you learned something. I know it's a lot of content, and this slide alone is 3 or 4 separate courses easily worth of content. All right.